Hi everyone, and welcome to this chapter. In this chapter, we're going to be talking about RxDart. RxDart is a reactive state management solution. And when I say reactive, I know that some developers will kind of shy away from using any type of reactive state management solutions for their application. This is not only for Flutter, but it's also for instance, Swift. And also I know that, for instance, in Python and other languages, then you can have reactive state management solutions. But some developers are kind of like scared of these solutions. And they basically just shrug off the idea of using anything reactive. It seems like there is a stigma around reactive solutions in any type of programming language that I've used, at least. And when I talk with a lot of developers, they're kind of like, they say they don't like it, but if you really ask them, but can you use it? Do you know how to use it? Then they usually don't actually know how to do that. So Rx is something that a lot of developers want to learn, but are scared of doing that. And simply because for a lot of developers, there's a misconception that there's a huge learning curve to Rx. And for me, when I started learning Rx, it was many years ago, but it took about 2 weeks. And during those 2 weeks, I kind of had headache because there was a lot to learn. And it's like a mind shift of how to think about data flow. And what we're going to do in this chapter is kind of going to break down Rx. And I'm going to show you exactly how it works. And we're also going to go above and beyond RxDart, because Rx, what we need to learn about Rx really is that it's not just about a library. In that, for instance, by end of this chapter, you're not just going to learn RxDart, but you're actually going to learn Rx. And Rx is this reactive solution, as I've mentioned, which you can then transfer your knowledge from RxDart to any other Rx, for instance, RxJava or Rx Kotlin or RxSwift, because all these Rx libraries, they work pretty much similar to each other in that there is a vocabulary to learn. And then there's, as I said, there's a little bit of a learning curve. But once you've learned those basic concepts, that knowledge is transferable to other languages and technologies as long as you're using Rx. So by you learning Rx, you're actually investing time into learning a technology that is not only bound to Dart or Flutter, but it's also going to allow you and enable you to use Rx in any other programming language, as long as you can learn the basics of the other programming language as well, such as the syntax, for instance. So in this chapter, I'm going to teach you RxDart, but most importantly, I'm going to teach you Rx. So what we're going to do first is we're going to build quite a few small example applications. Kind of we're going to get into Rx slowly. So I'm going to show you a few examples, just slowly building up the knowledge base. And then at the end of this chapter, we're going to create a full-fledged application that integrates with Firebase. With authentication, we're going to have logging in, registration, logging out, deleting account. And also we're going to create, and in this application, we're going to create, for instance, contacts, and then allow the user to delete those contacts and etc. So and we're going to learn a lot of things. This might be quite a lengthy chapter just because Rx itself could be quite basically a long thing, a long journey to go through to get better at Rx. I don't want to skip over a lot of basic concepts that are necessary in order for you to become an Rx developer. So without further ado, let's just go ahead and create our project that we're going to base all the applications in this chapter, or all the examples in this chapter are going to use the same code, code base. And we're just going to commit our changes for every step of this chapter. And then we're going to tear that code down and build up on top of what we have, for instance, on the dependencies and etc., to create new examples. So what I'm trying to say in here, you don't have to create separate projects for every example. We're just going to have one project. And then once we're done with an example, we're going to commit that code and then change the same code base to basically build on top of that to make the next example. Okay. So let's go ahead and bring up terminal. I'm going to bring it right here. So let's go ahead and I'm going to do some screen reshuffling in here so you see the screen better. So let's go and create our example. So let's say Flutter, create testing RxDart _ course. And I always specify the organization because it's just so much easier to specify the organization from the absolute beginning rather than having to change the organization later. So if you have an organization, please just place it in here in a reverse domain name style. So for me, my company here in Sweden is called Pixology, and then I have a domain name at pixology.se, and so the reverse domain name would be se.pixology. So that's what I'm using in here, but you may have some other domain name which you are more than welcome to place in here. So let's go ahead with that, and then this is going to create the application for us. And let's go to testing RxDart, and then I'm going to open up Visual Studio Code in here. Okay, and it wants to restart Visual Studio Code, and yes, let's update it actually. So let's take care of that. Okay, so the first thing that we need to do in here is to go ahead and add RxDart as a dependency to our project, okay? So let's do that. I'm gonna bring up Terminal and Visual Studio Code in here, okay? I'm gonna bring it up so you see it better. So let's say Flutter pub add, and I'm going to go in here and say RxDart. So this is going to go ahead and fetch the latest version of RxDart and then place it inside our pop spec. So if you open up the file pop spec YAML, then you'll see in here, if you search for Rx, then you'll see that we have RxDart 0.27.3. And we could always also go to pub dev and search for RxDart and see the latest version of RxDart, the one that's available in here. And we can see in here the version number. If you go to installing, 0.27.3, and that's the exact same version that is placed right here. So just make sure that you install RxDart as I just showed you in the terminal. After adding RxDart, we're also going to use Flutter hooks. Now, there is a chapter that I've recorded in the same state management course on YouTube, freely available, in which I talk extensively about only and exclusively about Flutter hooks. Flutter hooks is also another sort of state management solution for Flutter, maybe not as encompassing as RxDart, but it also allows a high reusability grade of code. So if you're, for instance, familiar with text editing controllers in Flutter, you know that when you're using text editing controllers and you have to convert your widget to a stateful widget, simply because you want to instantiate this text editing controller upon your widget being created, and you want to dispose of it when your widget is also being disposed. But using Flutter hooks, you don't have to do any of that. Really, there's like these use functions that allow you to create a text editing controller without you having to dispose of it manually, as long as your containing widget is of type hook widget. Now, I highly suggest that you actually watch this chapter about Flutter hooks, which I've provided, but I also understand that since it's quite a long chapter as well, quite rightly, because Flutter hooks is its own complete like state management solution, kind of, you could say. But if you don't want to watch that chapter, I'm just going to talk a little bit about Flutter hooks as we go along. So don't worry about it. You can still watch this chapter independently of the Flutter hooks chapter, because we're not going to go too much into details of Flutter hooks in this chapter anyways. So with that said, let's go ahead and add Flutter hooks also as a dependency. So for now, if you don't know anything about Flutter hooks, all you have to know is that it's a state management solution which allows you to reuse your code to a high grade. And then we're just going to add it to our project and use just a few bits and pieces of it, okay? So let's go ahead and say Flutter pub add Flutter hooks, as you can see. Okay, so this is going to add Flutter hooks to our pub spec, as you can see in here. All right, great stuff. Now that our dependencies are added to the project, let's go ahead and select a device to run our application on. So I'm just going to say Flutter select device here in Visual Studio Code. iPhone 13 Pro will do. Then I'll go to main Dart file in here, and let's just run our application without debugging to see how that goes. So at the moment, it's trying to run the application on iPhone 13 Pro in debug mode, as you can see. So this might take some time. Actually, it took only 6 seconds, so that's really good. I'm just going to close the widget inspector and bring up our application. As you can see, we have the default Flutter application in here with no bells and whistles. So this is perfect for us to basically build our Rx application on. Let's go to the main Dart file in here and create a simple scaffold. Now, you can see that there's a lot of code in this basically template application that Flutter created for us using Flutter Create, and we don't need any of this really. And I have actually a video, as you can see, I've linked it at the bottom of the screen on YouTube, where I talk about creating a kind of like a code snippet in Visual Studio Code that allows you to write, for instance, FSA as in Flutter scaffold application, and it fills the entire application's this main Dart file for you. So I'm going to delete everything in here and just type FSA, as you can see, Flutter scaffold app. And what it does, it just literally pastes the code for me that I've placed inside my code snippet. And if you are curious about how that works, please go ahead and click on the link that I provided at the bottom of the screen to learn more about creating snippets. But if you can't be bothered with that, all you need to do really is just to create an app in here, which is a stateless widget with a material app, and then a home page, as you can see in here, which is also a stateless widget, and it has a scaffold with an app bar. So there's really nothing magical about that FSA that I typed. It's just a code snippet shortcut that creates this for me. But if you don't have that, it's completely fine. As long as you have a home page and an app that are separate stateless widgets, then you're good to go as well. So let's go in here and change our home page to become a hook widget. We're going to use text editing controller for this first example, and we're going to use Flutter hooks for that. So all you need to do really right now is just to change the stateless widget to a hook widget, and I'll explain more for those of you who haven't watched the Flutter hooks chapter. So let's say hook widget, and this is going to auto import package Flutter hooks for us. So right there, okay, and you can see it's imported right there for us. So what hook widget does is it allows you to circumvent having to go and create a stateful widget just because you want to have text editing controllers, okay? And what we're going to develop in this example in this chapter is, as the first example, we're just going to create a text field. And as you type text inside that text field, we're going to update the app bar's title in here, okay, with the text that you've entered in the text field, just as an example of how Rx kind of works. So for that, we need a text editing controller. And because we don't want to go and create a stateful widget, then we're going to change this to hook widget and use a text editing controller, as I'll show you soon. As you can see at the bottom of the screen, I'll also mention that we're going to use Memoized, but you don't have to worry about that right now. I'm going to show you how all of that works just in a second. What we need to do then is to hold on to some sort of a text stream. And what I mean by that is, as the user is entering text inside a text field in Flutter, the contents of the text editing controller that is controlling that text field are going to change. So it's kind of, when you're working with Rx, you have to think in terms of streams. And by streams, I just mean pipes. So nothing fancy really. It's just a name that's called a stream. And it's also stream in Flutter and Dart, because asynchronous programming in Dart is done with futures and streams. A future is as an object, as its name indicates, that will be returned to you in the future, not now necessarily. So you have to await on it using the await keyword. And a stream is similar to a future, but it returns objects, plural, in the future. And it could also just not return anything and finished, or it could start, produce some objects and finish, or it could start, produce one object and finish, or it could start and never finish and never produce any objects. So what I try to tell anybody who's trying to learn Rx is that Rx is very similar to Git branches in that it has every branch has a start. And when I say branch, think about streams in Rx. Every branch has a start. It may or may not have some commits, and it could then interact with other branches in the same repository, for instance. So you could have a main branch, and then you could have a develop branch or streams. They could have commits. You can merge these commits. You can cherry pick these commits. You can rebase these commits on top of each other. So there's different operations that you can perform on your Git branches. And in Rx, using streams, like branches, you can also perform operations on these values that are produced inside of your streams. Or if there's an error in any of these streams, then you can handle that as well using some operators, okay? So what we need to do right now is to think about behavior subject as a stream that holds on to its latest value. And what that means is there's this concept of behavior, or there's this concept of streams and subjects in Rx, which is a little bit too early to actually go into details of. But what you need to know is that usually a stream is like a branch on Git that you can make commits to. And as you make these commits, whoever's listening to these commits being made, it can grab those values. So it can, let's say that you have 4 listeners to a Git branch, and then you'd say, oh, here's a commit that is being made. Here's another commit. But the way streams work also in Rx and in Dart is that if then you have a subscriber that wants to listen to these changes to that stream at a later point than those values or those commits were made to that stream, then that listener is not going to know the entire history of what has happened on that branch, except that the listener or the subscriber will get all the updates that have been made to that branch or stream after it has subscribed to that stream. Okay, so there is a timeline that you have to think about in that, okay, the stream was created a day ago. There were 2 values produced by that stream, and then here's a new subscriber. And then this new subscriber is just going to get all the new events and anything after that, but it's not going to get the historic events that has been made on that stream. However, so that's how streams usually work. But when you go and talk about behavior subject is a special kind of stream in RxDart that uses stream controller actually inside its implementation. However, a subject, as you need to learn that in Rx, and that actually works with RxSwift, RxJava, RxKotlin, RxDart. It's the same thing. If you have a subject in any Rx-related library, it does the same thing. So the thing that is special about subjects is that they hold on to their last value. So let's say it's a stream that produces the current date every second. So let's say now produces now. So every second it produces a new value. And if you have a subject, anybody who subscribes to that subject at a later point will be able to read the last produced value of that stream. Unlike a normal stream that will just lose its last value and will produce new values and kind of broadcast it to anybody listening. So that's kind of like, I don't want to go too much into details, but just know that a behavior subject is a special kind of stream that holds on to the last value that it produced, and it will provide that value to any new listener as well as any existing listeners. Okay, we're going to go and use a behavior subject. So let's go inside the build function of our hook widget and create our behavior subject. And what we need to do in here is we're going to use a function in Rx hooks, Flutter hooks, called use Memoized. And you may be a bit like worried about Memoized, and you'd be like, oh my God, what is that? But also remember that Flutter internally actually has Memoizeds. So it is not like a foreign or alien term. A Memoized is an object that you hold on to until a point arrives. Okay, so it's kind of like, you could think that it's memorizing that object. So it's kind of like storing that object until a specific event happens, and then you can dispose of that object. Okay, so what this use Memoized does, it comes from Flutter hooks, and it allows you to instantiate an object which you can then relinquish the control over at a later point. For instance, when your hook widget is rebuilt. So if you look at the function signature, it's literally says you have to return an object in here, and it has to be a function that you provide as the value to this parameter, and then you just do something in this function and then produce a value, and then I will return that value to you. And then the second parameter in here is the keys, and what this keys is an array of objects that any of them changing will cause this use Memoized function to trigger this function again. So what really it does is that it says produce a value and then give me a set of things that might change in the future. And if those things change, I'm going to call this function again to produce a new value. Okay, so it is a way of going around the limitation of having to use stateful widgets in order to create objects that then you can relinquish the control over after the stateful widget is rebuilt. Okay, so let's go ahead and create a function in here. And in here, we're literally just going to create a behavior subject of string. As you can see in here, so we're saying that we need a behavior subject. And then for the keys, we're going to use this widget's key, just like that. Okay, so in here, let's just go ahead and say that this is our subject, final subject, just like that. And you can see now our subject is actually a behavior subject of string. And the reason that it is a behavior subject of string is that we're going to hold on to the string that the user is going to write inside a text field. Okay, great stuff. So let's go ahead now in that we want to then be able to close this subject, because you see subject, if I go in here and say close, there's a function that you have to call on any behavior subject that you create in order to close that subject. It's kind of like resource management or a cleanup function that you need to ensure you're calling, okay? And in order to do that, using Flutter hooks, we're going to use effects in here. Okay, so we're going to say here's use effect, and then we're going to say in this effect, we're going to say subject dot close. Okay, and then we're actually going to use the subject as the key in here. So we're going to say every time the subject changes, meaning that when this widget is rebuilt and a new widget is actually a new subject is created, make sure to dispose of the previous subject. Okay. But let's see actually if we can pass the subject close in here directly. No, we can't do that. All right, that's fine. And that's because subject close in here is actually a future, and then use effect actually expects a future to be returned in here. You can see. Actually, it's not. Void function effect package used for side effects, optionally canceling them synchronously. Okay. That's fine though. So we have a function in here, and that function itself returns this function to be called, okay? Because you could see in use effect is actually a function that returns a function. It's a little bit special, okay? But we could write a little comment in here and say, create our behavior subject every time widget is rebuilt. And then in here, we can write another comment and say, dispose of the old subject every time widget is rebuilt. Okay. Remove this as well for the sake of consistency and put the comment right there. Okay, so that was the closing part. I note that I've brought the title at the bottom of the screen a little bit late, but that's also fine. So we have use effect and use Memoized. So if you don't want to do all of this, to be honest with you, when I say all of this, it's actually quite a little bit of code. But if you want to turn this hook widget into a stateful widget, you could also do that. To be honest with you, it's not a huge deal. I can show you just quickly how you could do that. So if you go in here and say that this is a stateless widget, okay, just like this, and then I'm going to turn this guy to a stateful widget, then what you'd have to do is to go ahead and say a late final subject, or you would say behavior. So again, this is not a part of this course. I'm just going to give you an idea of how you could do this without Flutter hooks. If you're not comfortable with Flutter hooks, you can always use a stateful widget, okay? So you could say, here's my subject, final late, and then in here, you say, call it subject. Then inside init state, you would say subject is behavior subject of string, okay? So you create your subject after init state, and then under dispose, right before calling super dispose, you would say subject.close. Okay, and I don't think we can. Yeah, actually, we could make it async and then await on it. So that's how you could do it without Flutter hooks. So if you're getting stuck and you really don't like Flutter hooks, don't worry. All you have to do is just use a stateful widget. All right. So I'm going to revert back now to how we had it with hook widget and just keep it the way it was. Okay, so let's go ahead in here and create our text field. All right. So inside the body in here, let's go inside our scaffold and say the body is a text field. Okay. And then unchanged, so this callback gets executed whenever the text field's contents have changed. And the cool thing about it is that if you look at its signature, it says, okay, it is a function. You give me a function to call in here, and I will give you the text that the user has entered into this text field. All right. So somehow we want to be able to place that text that has been entered in this subject. So the wrong way of doing this is to actually create a function that takes a string in here and then going into your subject and say subject sync add string. Okay, so this is the wrong way of doing it. And I actually don't want to say wrong. Maybe it's kind of like a longer and unnecessarily complicated and long way of doing it. So I have to first explain this, that a subject is both a read source and also a write source. And what that means is that in Rx, in any Rx Kotlin, RxSwift, RxJava, RxDart, there are various types of streams. And one stream is a read-only stream. Let's say a normal stream in Dart. Let's not even talk about RxDart, but in Dart, we have streams that are read-only, and they're marked with the stream class. Then you have streams that are read and write, and they are created using a stream controller. So if you create a stream controller, let's say in here, stream final name is a stream controller string. Okay, you don't have to type this, to be honest with you. I'm just testing it. So let's import Dart async. So name, you can see, you can say for sorry, let's go into stream control. And you can see it actually is a stream sync, and stream sync is also an event sync, but it's also a stream consumer, okay, as you can see in here. So meaning that you can both write to it and read from it. So here's your stream, you see, is a pure stream, and also you have a sync. So a stream is read-only, and sync is kind of write-only. So what that means is that a stream controller in itself is read and write. So you could expose a stream controller's stream property to anybody outside the class that creates the stream controller who's interested in reading the values of that stream controller and any new values produced. However, sometimes you only want to be able to write to that stream controller from special places, such as this place, for instance, in the text field. It's only interested in setting the value of this subject, and it's not interested in reading the value of that subject, which is a stream as well, remember. So keep in mind that streams are there. You could actually say there are three different types of streams: read-only, write-only, and read-write. So there's only these three types of streams, okay? A sync is write-only, a stream is read-only, and a stream controller that has a stream and a sync is read and write. Behavior subject in itself uses stream controller. So what did we learn? Stream controller is read and write, meaning that a behavior subject is also read and write, okay? So in here, when we were saying subject sync, we're writing only to the stream. Okay, so we're not interested in the subject's stream, but we're only interested in its sync. We're dumping values in this sync. Just remember a kitchen sink that you put stuff in it, okay? So what you need in here is to take the string and literally just directly add it to your subject. So instead of creating a wrapper function in here and then adding the value to that sync, what you could do is literally just pass the subject sync add in the unchanged property. The unchanged argument of your text fields constructor. Okay, this ensures that this add function gets called with the correct string upon unchanged, and then this subject will then get that value, the last value produced by the text field. So what we need in here is to go ahead And now that the subject's value is being changed, we need to go ahead and basically read those values. So as I mentioned, a subject internally, a behavior subject in RxDart internally uses a stream controller. A stream controller has a stream. So guess what? If you want to read the latest values of your stream that are being produced as the user types data in this text field, you could simply use a stream builder. And stream builder is something that's already built into Dart. So you don't have to do anything special, really. So let's go ahead inside our app bar in here. And actually, let's add some padding to our text field. So let's go ahead and say rapid with padding so that the text field isn't really having zero margins around the screen. So for the app bar, we have this title at the moment. It says cons text. Let's go ahead and remove this and instead say that we have a stream builder, okay, of type string. And we have to provide two properties or two parameters to this guy. And one is the builder, okay, which you can see is now a, sorry, the stream itself. It has to be a stream of string. So let's say we have a stream. But what is our stream? Well, it's our subject, okay? So the subject itself is a stream, but it's also a write source. So if you want to be a purist in here, you could say subject.stream, okay? But remember, a behavior subject is in itself a stream as well. So you don't have to necessarily go into its .stream. But if you're a purist, you'd want to do this, okay? But to be honest with you, I'm actually not a purist, so I don't really care about this part. But yeah, it's completely up to you. What we want to do in here is to ensure that we're getting into a little bit of RxDart operators. Now, we don't want to just go ahead and read the stream. Let's say that the user is typing at an incredibly high speed, and it's just entering text like crazy in this text field. What you want to do is to limit the number of times that your app bar is updating its title, simply because maybe you're not interested in all the updates as soon as they appear, but you want to kind of like limit the number of times you're updating that title so that the user can basically chill a little bit and see the updates at a little bit more smooth rate than every update appearing immediately, okay? And to be honest with you, I'm actually making up this scenario simply because I want to talk about operators, because it's important that you learn how operators work in Rx in order to be able to build your knowledge up to create fully functional applications using Rx. So you can see now we have this stream, and if you type dot, you will see quite a lot of stuff in here. You see async map, every, expand, join, last where, and then there's other stuff such as distinct. So what happens in here, as you can see, distinct also, since our stream is a value stream or a stream of string, but distinct also, when you call it, it also returns a stream of string. So it doesn't change your source it doesn't change your source stream, but it kind of does something with that stream. It's kind of like it's doing some consumption of that string value, and it's kind of producing another stream to you. So if you go into the implementation of this distinct, you'll see that it's inside, you can see async and then stream.dart. So this is actually coming from Flutter. So this has really nothing to do with our RxDart. Okay, so this distinct is always there. You don't have to do anything special to get that. So what this does is that if your stream produces two values, adjacent values next to each other. So if this is the timeline that your stream starts from here, and it starts and it goes like this, produces the value of hello here, and then produces another value of hello in here, then these two values are actually not distinct, meaning that they're duplicate. First one was distinct because before this hello value, there was no other hello value produced next to it or before it. It was the first value. So distinct simply returns it to you. It says here is this value because there was no previous value, and therefore this value is distinct. However, if right after this hello, another value is produced of type string, and it also says hello, then this second value is no longer distinct because the value right before it was also hello. So in this case, stream puts a stop to this value and says, hey, you're not going through, you're not distinct. The value before you was the same as you, so you just stop right there. Therefore, this stream that produced two values after distinct will only produce one value. Okay, now that we have distinct put in place in here, let's go ahead and add another Rx operator here to the mix. As you can see at the bottom of the screen, the second operator that we're going to use after distinct is called debounce time. And debounce is something that you will actually hear in any Rx that you're using, Rx Kotlin, Java, Swift, and RxDart. And it is an operator. And what it does really is that it allows you to ignore values that are provided by a stream source, as long as those values are followed by another value within a time period. So let's say that you, in here, let's go ahead and say debounce time. Right after distinct, we say debounce. We have to, I believe we have to import actually. Let's say we don't have, I can see in here what's happened is that if you look at the import statement that is provided on top of the file, we've imported subjects. So this is because we wrote behavior subject in here, and Visual Studio Code tried to auto import it from RxDart subject. So if you remove this line and go back in here to behavior subject and bring up the pop-up menu in here, we basically imported RxDart subjects, but we should have imported RxDart because that's where all the RxDart header files and all the source files exist. So let's go to it and import RxDart in here. And then after distinct, we should have the ability to use another operator called debounce time. And you can see it says transforms a stream so that will only emit items from the source sequence. It just means it gets items from a stream whenever the time span defined by the duration passes. So what debounce time does, for instance, in here, if we say const duration seconds 1, it ensures that the data that comes out of this entire stream won't be more than one item per second. So as you're typing your text in the text field in here, for instance, in this object, which is being, with the text is being provided by the text fields unchanged, as the user is typing, that user could be typing a lot of characters per second. However, we're only getting the results of the typed texts up to the cut time of 1 second. So let's say that I've typed hello. I want to type hello world, and then I say hello, and then I managed to type that within 1 second. And the world part, I'm typing a little bit slowly. I'm saying hello, and then WORL. As I'm typing this, every second that passes, I will get the most up-to-date text up to that point. So here we say debounce time. It is very useful when you're trying to, for instance, debounce time is an operator that is super useful, excuse me, if you're trying to do API calls based on text input. So let's say that you are building some sort of a GitHub client, and then as the user types in some text that, which is like, for instance, searching for repository names within all GitHub, then you could say, okay, I'll take this text that the user is typing, but I don't want to make API calls per text, text changes. So I may be typing a lot, and then after I've typed, maybe you've already made like 50 API calls because you're making API calls per text change. However, if you add a debounce time in there, you'll ensure that you're making API calls at most once per second or once per the amount of time that you specify in your debounce time. Okay, so that's where it is very useful for. Okay, after that, let's go ahead and provide an initial data in here, which is our string. And then we're going to say, please start typing. Okay, like this. And then we go inside the builder itself, and then we say context and then snapshot. Okay, in here. And we have a comma in here that we have to enter. For the builder, let's go ahead and say, actually increase the text size so you can see it better if you're on a mobile device. And for the builder, what we're going to do is just return a text in here. And then we're going to say snapshot require data, which is going to grab the text from our stream. So the stream is going to start with this, and then every time the user starts typing, then that is going to change as well. Okay. So I'm going to do a hot restart in here and then bring our application. You can see the title by default at the moment says, please start typing. And I'm going to remove the software keyboard so that I can use my Macintosh's keyboard to start typing. I did that with Command K on Mac. And if you have iOS Simulator, you're most definitely on a Macintosh. But if you have a Hackintosh on a Linux machine or a Windows machine, then you don't have the Command key on your keyboard. So you'd have to say Control K. But on a Macintosh, it's Command K to trigger the software keyboard on and off. Okay. So you can see that the stream, which is the stream builder of string, at the moment is our subject string, but our subject hasn't really provided any values yet, simply because the text field on change hasn't triggered anything yet. So if you go in here, let me make this simulator a little bit bigger as well. So as soon as I start typing in here, I can say H, and you can see after 1 second, it responds. So if I say E, waits 1 second. And then if I keep typing, you can see nothing is provided to the title, but I have to wait 1 second for that title to be updated. Okay, there we go. So that's what debounce time does. So if I say hello world, I have to wait 1 second because of the debounce time. Okay, and then that's where we see the results. But if you remove this debounce time from here, okay, and then save your project, actually I'm going to do a hot restart just in case. Then as I type, the results are going to be reflected on the title. So you see hello world, right? But as soon as you have the debounce time, it ensures that any item from your stream that is followed by another item within this time span of 1 second is going to be ignored until you actually wait 1 second. And then that result is going to be reflected in your stream builder. Okay. So this was a very simple example, and it really shows you how great and how rich the API for Rx can be. Because if you looked at this thing, this was something that was provided in async for Flutter anyway, so it's nothing that Rx is providing you. However, debounce time is an operator that is provided by RxDart, and it really shows you that you can very easily mix and match Rx operators to create rich APIs and rich applications without you having to go ahead and create some sort of a timer. Because even if you had to implement debounce time yourself, it would require quite a lot of time and effort from our side to actually do that. So with Rx, you can really mix and match existing operators to create really, really great applications, as we'll actually explore in this chapter. So now that we're done with this, let's go ahead and commit and tag our code as we usually do in all examples for every course that we do in YouTube. So I'm going to clean this window in here, and let's go ahead and say git init dot to create a repository in the current directory. And then I'm going to say git status and then git add all like this. Let's say git commit step 1. Okay. And then let's tag it as well as step 1 so that we can jump between the commits so easily without having to actually go to the SHA1 of the commits. So if we say git log, then we have step 1. And if you say git tag, then we have step 1 there as well. Okay. So with that done, let's go ahead and move to the next example. Okay, then. Now that we're done committing and tagging our code, let's go ahead and move on to the next example that we're going to work on in this chapter. So as I mentioned before, Rx is really just a collection of asynchronous operators. I've been working with Rx for a very long time now. I think about more than 6 years. And during this time, what I've learned about Rx is that you need to think, I mean, there are actually a lot of things I've learned about Rx, but many of those things are with the technicality of Rx, such as how it actually works, what the implementation details are. However, there is a higher perspective of how you should be looking at Rx. Rx is nothing magical. It is just a collection of operators that are working with asynchronous streams, or pipes, as I sometimes call them as well. So what you need to know about Rx at a high level, if you want to learn it, is really just playing with values that are asynchronously produced on a stream or a pipe. So Rx is nothing more than that. You need to just really think about the asynchronous nature of the produced data and how you're playing with it. What I like to usually tell people who are learning Rx about operators and what operators are actually in the world of Rx is that you need to think in terms of Git. So in Git, you have branches. Those branches are available in Rx, and they're called streams or pipes, but more officially streams. Now, excuse me. Now, those branches that you have in Git, which are streams, they can have commits. And those commits that are produced on a branch are similar or are the same as values produced on Rx streams. Now, in the world of Git, you can do a lot of things with these commits. So you can, for instance, cherry pick them, you can amend them, you can duplicate them, you can reverse them. These things that you can do with Git commits are operators in the world of Rx. So exactly as you have it in, for instance, Git, let's say you have two branches, a develop and a main branch, and there are commits being made in these branches, let's say, or maybe just two feature branches if you're kind of getting like a headache thinking about someone making a direct commit to the main branch. So let's say there are two feature branches, and then people or developers in the team are making commits to these two branches, and then at some point you want to merge these two branches together. So you're taking commits from every branch and then you're merging them together. So the merge is an operation that you're performing on these two feature branches. And unsurprisingly, there is an Rx operator called merge that does the exact same thing. So given two streams with values being produced on any of these, and when I say streams, think about Git branches. With values being produced in the streams, think of commits. And you want to bring these commits together, and then you want to create a new branch. And you can do the same thing in Rx using merge. It's an operator available already in all implementations of Rx. And this mind shift of thinking about Rx as just manipulator of asynchronous data using its operators will allow you to learn Rx a lot faster. If you don't think of it as this monster that some developers have created in their heads simply because they haven't really spent enough time with Rx to learn it, as I usually say, it's always easier to hate than to learn. It's a saying that a colleague of mine used to say, and I really believe in that because a lot of developers these days go ahead and hate on something without actually having learned it. So if you spend enough time with Rx and really understand that it is a series of operators, things that you can do to asynchronous data, it will make your experience a lot easier with Rx. Now, given that we have operators working with streams, you may be wondering, okay, but what operators are actually available? Where can I learn about these operators? And there is a really good website that you could say is a part of the Reactive X community. And it is called RxMarbles, as you can see at the bottom of the screen. And I personally love this website. Simply, as you'll soon see, it visualizes the various Rx operators. It doesn't have all the Rx operators, but it has the majority of them and the most important ones. And it visualizes for you in an interactive way how they actually work. So let's go ahead in here and demonstrate how RxMarbles actually set up. So I'm going to open RxMarbles in a separate window in here, and I'm going to then bring it right there so we can see it together. Here is RxMarbles website, and let's see if I can increase the size. Yeah. So, all right. So I mentioned merge. So let's find merge in here. Okay, here it is. This is what RxMarbles website calls a marble, basically, because these are small marbles, okay? You have these marbles, and you have to look at these as streams. So here is a stream that you can see. It starts here, and this line right here is actually a line that you can move you can see I can actually drag this line to the right and left to determine, to tell RxMarbles where this stream is actually ending. You can see if I end it here, the last marble that is on the stream is actually moving with it, because once the stream is ended, it cannot produce a new value. So you can also individually move these marbles. You can see that they go like this. You can move them individually. You can bring them together, but you can't move marbles between streams. So that's one thing. So as you can see, now that we're looking the merge operator, it is giving us two streams with various marbles on them. They're color coded and they also have their own values, 20, 40, 60, 80, 100. And then we have another stream that starts here and it ends right there. Okay, and I can move the ending part of the first stream to this point as well. And these marbles, then you have the ability to play with them in order to see the result of this merge operator. So at the end, right here is the result. Let me actually see if I can drag this up a little bit. So let's see if I bring this here, could you see it better? Perhaps, yep. That would be better, and maybe do it like this. So let's see if I bring it right there. I just want to make sure that you can see the entire contents of this merge operator. So let's say in here that we have this first stream that is producing a value of 20. And then we have another stream that is producing a value of 1 at this point in time, which is a lot after the value of 20. And then we're saying that we're merging these two streams. Right here is the result of merge. So imagine that you have a branch in Git, and then there's a commit being made here, and you have another branch in Git, and there's another commit being made here. Then you're merging these two branches. The result of that merge will actually look like this. It will be 20, or the first commit, the second commit, the third commit, and then the fourth commit is on the second branch. But at the end, when you merge it, it will appear in between the third and the fourth commit of the first branch. This is exactly what you'd expect. And if I move this first commit around, you can see that the result of merge will be the first commit from the first branch, first commit from the second branch, because in the timeline, the first commit in the second branch appears before the second commit on the first branch. And if I move this commit, that is the second commit on the second branch, right after the first commit on the second branch, you will see that the result that is produced is the first commit from the first branch, first commit and the second commits from the second branch, followed by the second commit from the first branch, third, fourth, and fifth commits from the first branch. And then once these two streams are both completed, then the result of the merge also completes. You need to think of timelines. You need to think of when things are happening. And also you need to think about the operator. Merge in this case is very easy to understand because it literally takes the events that are producing any stream that it is merging, and it will just produce a resulting stream that is, it's the merging of those streams. And remember, Rx operators such as merge are not limited to two streams. Here, for the sake of simplicity, RxMarbles is displaying us two streams. However, it could be 3, it could be 10, it could be 100. Almost never 100 streams you're going to merge, but you get the idea. So you can merge multiple streams, but the important thing about merge, and most operators, almost all operators in Rx, is learning what that operator does. So you need to think in your head also. After you've seen these marbles, it will be a lot easier for you to visualize in your head what that operator actually does. So I highly recommend that you open RxMarbles, especially when you're trying to learn Rx in the beginning, and go ahead and play a little bit with the various operators that are provided in here. You can see we have concat, merge, start with. There are a few of these that are very common. For instance, combine latest, concat, merge, race I've never used after 6-7 years of Rx, start with latest from, zip, debounce time and debounce, distinct until changed, filter, first, ignore elements, skip, all the skip families, all the take families and throttles, they're very important. Buffers, I've not really used. I haven't had the reason to use them, so I'd say that they're not that common to use, perhaps. Any concat and any map and merge operators are useful to know about. Any switch map, which is kind of like flat map, are are important, and scan as well is important. And here we have also at the bottom, which you may not see, are delay operators. So I think these operators that are just named are very important for you to learn. And I highly suggest that you play with them a little bit, at least in RxMarbles. You don't necessarily have to learn the exact implementation in RxDart, at least not for now. But go ahead and play with them to learn more about those operators in Rx, okay? After RxMarbles, we also have the home of Rx. So as I mentioned, Rx is like a family or a community of Rx implementations. So Rx itself is the idea of how software should work, or how state should work, or how values or like asynchronous values should be produced over time. So it's just an idea. However, you have then concrete implementation of Rx. You have RxDart, you have RxKotlin, RxSwift, and then you have RxJava. So there are many implementations that take this basic idea and then go ahead and implement it in their own way. Now, let's go into Rx's website in here. So Reactive X. And here's the website that I mentioned at the bottom of the screen. Okay. So let's increase this. And then you can see on top, there are documentations, and then there are languages. So you can see .NET, Scala, Clojure, Swift, and others, Java, JS. And then there's documentation. So Rx documentations are very important for you to learn about or learn from. Because as you can see in here, Rx really is just a series of, how do I say, it's a series of concepts blended with the operators. So there are two things that are very important to learn from here from the documentations. One is the observable, which in RxDart is called stream. And then the other ones are the operators that we've talked a little bit about, such as merge, okay? So I think it's very important that you go ahead and read about at least observables and how they work. We're not going to go through all of this right now, but I'm going to sprinkle quite a lot of content from Reactive X as well in this course as we're talking about RxDart. So once you've read about observables, I also recommend that you go into operators and just have a quick look around. You don't have to learn all of these. I mean, to be honest with you, there's so much material, but you kind of like get the idea of how they work. Like switch, what does switch do? How does zip work? You see, here's the marbles for zip as well. So play with these if you can and get the basic idea of reactive programming, because once you learn Rx, hopefully by the end of this chapter, then you can transfer this knowledge to many other places. As I said, Rx is everywhere. So if you learn RxDart, you can easily transfer the knowledge from RxDart to Rx JavaScript, for instance, RxJS. So it's the same thing, although the implementation of the library is completely different. It's in a different language, but the basics are the same. So you can, if you go from RxDart to RxJS, you'd be like, oh, I already know how all of this works. So you may not know the implementation details, so you will have to still know JavaScript because the language is different, of course. However, Rx at its core is going to stay the same. So now that we've talked about this, let's talk about this example that we're going to develop right now. The first example that we did was very simple. We just jumped into using a behavior subject and two operators like distinct and debounce time. In this example, we're going to take it to the next level and implement something that has API calling, and it has a block, which is a business logic, but we're not going to use the block library, but we're going to use the term block. And also it has, making API calls, caching, and etc. we're going to do in this example in this chapter. Now, we are basically going to start by removing some unnecessary imports, which we have in here. As you can see at the bottom of the screen, we don't need Flutter hooks anyway at this point. Let's go ahead and say Flutter pub remove Flutter hooks. And if you go to our pub spec, then there should be no Flutter hooks available in here, okay? Dependencies. So what we need to do is to develop a simple search API. So we're going to have 2 JSON files, and we're going to serve them locally using an extension in Visual Studio Code. So I highly suggest that you have Visual Studio Code installed on your computer if you're going to follow along with this example, because we're going to use an extension here called Live Server, which is going to host our files locally for us so that we can kind of like pretend we're making an API call. Okay. And this example is going to be very similar to an example that's in the official RxDart repository, but I've taken it to the next level a little bit, and I want to basically demonstrate all those ideas here for you with a lot of explanations. So hopefully you get the idea of that example a lot better. Okay, so now that we've done that, let's go and clean up our application in here, because you see, after we've removed Flutter hooks, the main Dart file is kind of like messed up because, yeah, we don't have access to these use effect and other APIs that we're using from Flutter hooks. So I'm going to go in here and say FSA, which is Flutter scaffold application. Okay, and then that is replacing all the imports and everything for me. So then I have a very basic application in here. If you bring up the simulator, you see we have a home page and nothing else in here. Okay, so just clean up the main Dart file, so you don't have any traces of Flutter hooks in here. We need 2 JSON files basically. What we're going to do is to create a very simple application that allows the user to type in some text. We're going to have 2 JSON files, one for animals and the other one for persons. Then we're going to define in these JSON files 6 objects, 3 in each, 3 persons and 3 animals. And then what we're going to do is to allow the user to type in some text in this text field. And upon the user typing any text in this text field, we're going to go to our API. So we're going to create like an API file that has the logic of doing the search and etc. And in this, once we do the API calls, once we get the results, we're going to cache them. So the next time the user types something in, we're going to use the cached responses. So we're not going to make API calls every time. After that, once the user types some text, if that text matches any of those objects that we found in any of those 2 JSON files, then we're going to display the results to the user inside the list view. So it is quite a simple application, but we're going to go through quite a lot of logics and like bind it all together and bring it into making quite a solid application that has its own block. It has its own logic state management caching. Okay, let's go ahead first into the extensions and search for Live Server. And in here, you can see Live Server available. It's free, installed by 21.5 million people. And I've already installed it, so I don't have to do that again. But if you haven't done that, please go ahead and install this. So we have Live Server in here. And what we need to do is to go ahead and define our JSONs. So in here, we have lib test web. And then I'm going to just create a new file. And let's just say APIs animals.json. Okay. So I've already prepared the animals. I'm just going to paste them in here. So it's going to look like this. Your JSON is going to start with a high-level array in here. Okay. And then you have 3 objects: name, Fluffers, which is who's a cat. And then we have Woofson, which is a dog. And we have Buns, who's a rabbit. So please go ahead and define these 3 objects inside your animals JSON file, which is inside APIs. Okay. We've just created this, so we haven't yet served it, but we're going to do that soon as well. After that, let's go and create a persons JSON inside APIs. So I'm going to say a new file, and I'm going to say persons JSON. And I've already prepared persons JSON as well. I'm just going to paste it in here. We're not going to do these mundane tasks, to be honest with you, in my courses. So if it's just a simple task of creating a JSON, then I'd suggest that you pause this video, have a look at what I've pasted in here, and do the same thing, because it's kind of like outside the scope of this chapter or this course to talk about JSON. But I hope that you know how JSON looks like, at least. So here we have an array, and then we have 3 objects in here: name, foo, age 20. So for persons, we have name and age fields, and for animals, we have name and type fields. Okay, that's really good. So what we need to do now is to go ahead and define a class that defines a thing. A thing can be either a person or an animal. So let's go ahead and define this thing class. So we're going to go into lib, as you can see at the bottom of the screen. So if I find lib, right, okay, and then I say new file, and then let's say models, and then we have thing.dart. So in this thing.dart, the literal thing that both animals and people have in common, if you look at our APIs, is their name. They both have a name, right? Name, and then animals also have names. So let's go ahead and define this thing. So I'm going to say an immutable class thing, and let's import foundation and then just say show immutable, okay? So we're going to define this thing. Let's go in here then and say we also have a final string name, because everything, an animal or person, has a name. So let's go ahead and create the constructor for this guy. We say const, and then this is a required parameter, okay? Just like that. So final and then const thing. Great stuff. Now that we have thing, let's go ahead and define the animal class. So I'm going to bring up the caption at the bottom of the screen. Let's go here inside models, right click and say animal.dart. Okay. So we have the animal.dart class, and every animal, I mean, if you look at the animals JSON, we have cats, dogs, and rabbits. So let's go ahead and define this first inside the animal.dart file. Let's say we have an enum, and we say animal type, okay? And in this, we're going to go ahead and say we have dog, cat, rabbit, and then unknown, in case we read an object from the animals JSON file that doesn't have a type that we understand, okay? So that's why we've implemented unknown in there. So let's go ahead and create an immutable class in here called animal, as the file name suggests as well. Import foundation and then show immutable. Okay, I'm using Flutter 3, and I've noticed that Flutter 3 is a little bit more flaky at the moment, the current implementation of Flutter 3. So it displays quite a lot of errors as I'm typing, but that's okay. That's going to be fixed hopefully in the future updates of Flutter 3, because Flutter 3 is still very fresh. So every animal has a type. So let's say final animal type, and we'll just say this is a type, okay? Also, this animal extends thing. So it's going to be auto-imported, right? And then since thing has the name and animal has the type, we have to bring them together. So let's go in here and say that we want to create a constructor for this, okay? So we say this is required this type. And also we need to call super with a name. Remember, a thing has a required parameter called name. So let's say name. Also, name is unknown because we haven't taken that parameter in. So let's say required string name, just like this. And let's turn this animal constructor into a constant constructor. So now we have the animal with its type, and then the animal itself has a constructor which passes the name to a super, and it holds on to the type itself. Okay, let's go ahead and implement the toString method for this guy. So let's say toString override, and this is a simple arrow function. I'm just going to say animal, name is $name, and type is $type. Okay, so what we need now is to create a factory constructor on this animal class that allows us to construct an instance of animal given a JSON, so a JSON map. Because if you look at our animals, it is an array or a list of JSON maps. So this is a map. Every one of these curly brackets from its start to its end is a map of string and dynamic. Okay, so because the values could be anything, but the JSON keys are always strings. Okay, so let's go ahead and start creating a factory, and we're going to say animal from JSON, and then we're going to say we have a map of string and dynamic, and let's call this guy JSON. Okay, so like that, and in here our job is to parse this JSON. So let's say final animal type because we have to first extract the animal type, okay? Or we don't have to extract it, but it's just more work. And I prefer to do the things that are more work in the beginning, so we go over that hill and it'll be downhill from there. So let's extract animal type. So we're gonna call it animal type in here, okay? So what we're gonna do is gonna say switch. Let's read from this JSON field called type. And we're going to say this should be a string, okay? And we're going to say 2 lowercase. Let's see, put a parenthesis here. 2 lowercase, and then we trim it as well, okay? So we're switching here. Let's say case rabbit. In case this is rabbit, then we're going to say animal type is animal type rabbit, okay? In the case of dog, we're going to say animal type is dog. So I'm just going to copy and paste that code. And then we have the case of a cat. So I'm just going to copy that entire case. And I'm going to say cat. And then in here, we're going to say cat as well. So we have rabbit, dog, cat. And for all of these, we have to have breaks as well, because, yeah, otherwise it will fall through to the next line. So break, break. And in any other case, the default case, animal type, it's going to be animal type unknown because we don't understand any other type, okay? Okay, so I don't think we need a break for default case because there's no other case after default, so we don't have to worry about that. Good. So let's create then an instance of animal in here. Let's say an animal with the name of the JSON name, okay, as a string. And then we have the type of animal type, just like that. All right, so that's how the implementation looks like for animal, at least, okay? So let's just keep that like that and start working on the person class, as you can see at the bottom of the screen. So after creating this animal .dart file, let's go ahead and close all these files basically here that we don't need, just to avoid some confusions. And let's go, as you can see at the bottom of the screen, and create the person class. So we have models, animal.dart. I'm going to right click on models. I'm going to say new file, and then let's say person.dart. So let's go inside this person.dart. Excuse me. It is going to be very similar to animal. So I'm going to go to animal.dart file and copy the contents of that and paste it in here. So we have thing and we also have foundation. We don't need animal type in here. So let's change the class also to person. And let's in here, as you can see in person JSON, so if we open person's JSON, every person has a name and also we have age. Whereas name is defined in thing, age needs to be defined in person. So let's say int and let's say age in here. The constructor is going to be called person. We have the required string name, which is going to be passed to things constructor. And in here, we're just going to say age. All right. The toString, let's just say person, name is name, and then let's change type to age, and then we're going to say $age. Here we have person. We don't need all this animal type business in here, so let's remove all of that. And inside this factory, what we're going to do, actually, we're not going to have a factory. Let's just say person from JSON, okay? And then we're going to define or assign the values for our properties right here. So the age is going to be JSON, the field of age as integer. And then we're going to say name, and the name is going to come actually from super. So in here, let's just call super, and we pass the name from our JSON field of name as a string, okay? Just like that. So this is a constructor, so it's not a factory constructor. Inside the constructor, we set the value of the age field, which is regulated and stored inside the person class itself. And as part of the initialization or the constructing of the instance of this person class, we're going to call super as well to pass the name, of course, okay? That's great stuff. So person's Dart file is also complete. So let's close these files. So we need also to define an API with caching. And this is where the majority of the logic of this example goes to, because using this API, we're going to be able to get a search term, for instance. So what you search for, let's say you search for foo And this string is going to be provided to us. And then we're going to go first, hit the cache. So if you have any local cache, look for that data. And if we don't have the cache, then we're going to make an API call. So as you can see at the bottom of the screen, we're going to go inside lib and bloc API Dart. So new file inside lib and then inside the block folder. And I'm going to say api.dart. Okay. So let's go in here and start implementing the API class itself, as you can see at the bottom of the screen. So I'm going to go in here, excuse me, and I'm going to say class API like that. Okay. So nothing more than that. And then we're going to go and define the animals and the persons for this API class. So these are going to be variables because they're going to be our cache. So whenever we make an API call, for instance, and grab the latest values inside the animals.json and persons.json, we're going to store those parsed values then inside two variables. We're not going to call them cache or anything. We're just going to call them animals and persons, as you can see at the bottom of the screen. So let's go and define two variables in here. And that's the reason, the idea of having two variables inside this API class, which are going to be used for caching, prevents us from having this class as an immutable class. Okay, so let's say list of animal like this, and then we're going to say animals. As you can see, it is an optional list, so by default is null, and animal needs to be imported. So let's then say list of person, auto imported persons. Okay, let's go ahead then and define the constructor also for our class. So let's just say we have a default constructor that has no values that need to be passed to it. All right. And after creating the constructor for our API class, we can move on to creating the function that actually can help us download and parse a JSON file. Because remember, in this API, what we're going to do is to whenever the user is typing something, after that person's, for instance, stopped typing, then we want to hit our API and search for that thing that the person's typed in the text field. So this API class should be able to hit a backend with a URL and expect the result to be a JSON and parse that JSON with a list of things in that. Because remember, if we go to persons, if I go here and say persons, we have a list of things in here. Remember, this is a list. And also we have animals, which are a list of things in here as well. So this API should then have a function that allows us to provide a URL. And in return, we're going to get a list of things. Let's go ahead and define this future. As you can see at the bottom of the screen, we're going to say future of list. And this is going to be dynamic for now because, well, yeah, we're going to cast that later. And we're going to say get JSON, and we're going to give it a URL. And I usually try to use as much as possible HTTP client, like the built-in IO stuff inside Dart, because I've seen a lot of developers go ahead and import like HTTP package and start using HTTP. But in a lot of cases, you don't really need even the HTTP package. You can get away with HTTP client for most parts. It's very rare that you actually have to use HTTP, but some developers prefer to use HTTP because maybe it's got a little bit simpler interface. But here we're going to use HTTP client. So let's say HTTP client was going to be auto import from Dart.io, as you can see in here. So we create a client, and then on the next line we say get URL. Here we have the URL already. So then we're going to close the request. So we're going to say then, if this is our request, we're going to say request of close. Okay. And we get the response from the result of this, and then we have to transform this. Excuse me. We have to transform this so we actually get our string in here, which will be our JSON string. So let's say then, and this is our response. Okay. Let's say response like this, and we're going to say response transform. And what we want to transform this is with UTF-8 decoder. So let's say UTF-8, and this is going to be auto-imported, as you can see in here, from Dart convert. And we're going to say decoder, okay? And then we're going to join the result, so it becomes one string. After getting that, you can see in here, the function is actually getting a string in. So let's say this is our JSON string. Okay, then we have to parse this guy. So we're going to say JSON. And let's say JSON dot decode our JSON string. Okay. And we're going to say the result is actually a list of dynamic. Like that. Okay. So let's see what it says in here. The argument type string can't be assigned to the parameter type URI, and we have to parse this. So URI parse. And I apologize that I'm coughing. I have a little bit of a cold, so it's tickling my throat a little bit. So I apologize if I have to sometimes clear my voice. Okay, so now we have a function in here that we can give it a URL, and then it can go and use HTTP client and grab the response from that as a list of dynamic. But we know that this is going to be a list of thing, but we haven't parsed that yet. Okay, so it's just a list of dynamic for now. Good stuff. What we need then is when the user starts searching, let's say that if you look here inside persons, we have foo, but we want to allow the user to be able to search even for foo, or foo with capital double O's. And we need kind of like a case insensitive search. Okay. And for that, we have a little bit of an extension, that we're going to create on string, which is going to take an incoming string and see if that string is contained or is available in the current string, which is the instance of this. But it's going to do that entire thing by trimming both strings, both the this string and the incoming string, and also is going to lowercase them. So it's going to be a case insensitive search. Okay. So as you can see at the bottom of the screen, we're going to create an extension on string. So let's say extension trimmed case insensitive contain on string. Okay. And let's say in here, we're going to say bool trimmed contains, and then we're going to say string other. Okay. And in here, we're going to take the instance of this, but we're not going to mention this, and we're going to trim it. And then we're going to make it lowercase, and then we're going to say it contains the other string, other trimmed and to lowercase. Like that. Okay, so I think if I put a comma there, other trim lowercase contains other. Yeah, this looks fine to me. So, all right. So what happened here is that it's basically searching within this to make sure that the incoming string actually exists, whether it is its case is different or if there are spaces to the right and the left. Okay, that's why we're trimming and also doing it to lowercase. So we have this extension now. So let's go ahead in here, and also we need, as you can see on top of this API, we have two lists, and these are meant to be our caches. So if we've already hit the API before, meaning that if you've already called the get JSON and parsed the API and stored those values inside animals and persons, what we want to do in here is to have a function that can help us retrieve given values from these lists. So we need this function, as you can see at the bottom of the screen. It's called, what do we call it? Extract things using search term. So let's go ahead and implement this function. Okay. Let's go also in here and define search term, because at the moment the search term is a string, but it is a bit nicer to do a type definition like this. And this is my opinion only. So let's say search term, and say this search term is a string. Okay, so instead of passing string everywhere, we can just pass search term. Okay, so I'm going to copy and paste the header of this, or the definition of this function. Okay, and let's import thing in here like this. You can see it says extract things using search term. So what this function is going to do is just going to go through these cached values in here and see if it can find the given search term. Okay. So let's go ahead and grab the cached animals and cached persons, as you can see in here, animals and persons. So let's change the name of these properties in here to animals and persons, because yeah, they need to be underscored because they're private properties in here. Okay. And then what we're going to do is to have a look at these terms in here, sorry, the cached animals and the cached persons, and see if it can find the given search term in them. So let's say if the cached animals is not null. So because you know that this property is optional, so by default it's null, meaning that we haven't yet hit the API and we haven't yet cached these values. Okay, so if that's not null, meaning that we've already hit the API, and also the cached persons is not null, so we've basically cached both these values from before, then we're going to start accumulating a list of things. Let's say result, and this is empty for now. We're going to say for final animal in cached animals. Okay. Then we're going to say if animal name trimmed contains, we're using our own extension, the search term, okay, or the term. Either the animal name contains the given term, or the animal dot type dot name trim contains the term. And we're going to accumulate this inside the result in here. Okay, so we're going to say result add animal. And we're going to do the same thing, the same for loop in here. So let's say in here we're going through, go through animals. And then after this, we say go through persons. So I'm going to copy paste this for loop from here and paste it right here. So let's say person in cached persons. Okay. And if the person's name trim contains term, or the person's age to string like this, trim contains the term. Okay. Then we add that to the result. And then at the end of this, we say return the result, and then an else statement, then we say return null. All right, so you can see it's a very easy implementation. Basically, all it does, it goes through these two lists and searches in the properties of any animal or any person for the given term. Should this term exist in any of these properties of any of these objects of animal or person, then it accumulates those objects inside a list of things, and at the end returns that list. If we don't have these values cached from before, meaning that if any of these, like either the animals or the person's caches are null, then we're not going to hit the cache, and we're just going to return null. You could optionally search first for the cached animals if it's not null, and then search for the cached persons if it's not null. However, I'm doing it very simple in here, meaning that once you start hitting the APIs, as you'll soon see, we're going to hit both of them. So when the user, let's say that the user lands inside our application for the first time and starts searching for something, and then stops typing, then we're going to get the hint that, oh, it's time to hit the APIs, both of them. And we're going to hit both of them at the same time, okay? So the purpose of the application really is to make sure that both APIs are hit and then the results are cached. So given that assumption, given that basically requirement, maybe, we're sure that if we've cached values, then they're both cached, both animals and persons. Otherwise, it means that we haven't hit the API, all right? So that's really good for this function. Fantastic. After we're done with this function that retrieves the cached values, let's go ahead and do the implementation for the real search, which is going to first look in the cache using our extract things using search term. If the value that the user has entered, the search term, exists in the cache, then we're just going to return that value or those values. Because remember, the result of this function is actually a list of things, okay? However, if those values don't exist, we're going to first call the APIs, both of them, and then accumulate the results and also cache those APIs that we just called, okay? So as you can see on the bottom of the screen, this function is going to be called search. So let's say in here, we return a future of list of thing. And in here, we're going to call this function search, and given a search term, then we're going to return the result to the user. So let's first say final. In here, we can call the search term. And then in here, we say term is a search term. And then we're going to trim this. And we're also going to lowercase it, okay? Or to lowercase and trim. It doesn't really matter in which order you do this. Then what we're going to do is to look in the cache. So let's say search in the cache. So let's say final cached results is extract things, and then we're going to pass our term in here, and then we're going to say if the cached results are not null, then return cached results like this, okay? And we have to make this function an async function so we can use a return statement in it. If we didn't have the values cached inside these two, basically, when this function tells us the value was not cached, then we need to call the API in here, okay? So let's say we don't have the values cached. Let's call APIs. We start by calling, let's say we're going to call persons API. So in here, let's say final persons is await, and then we're going to make the API call using this function get.json. Do you remember from before? But in order to do that, we need to first start our live server and get the URLs for these persons and the things JSON files. So let's go in here and say a live server and say open with live server. So you can see we have the APIs folder. I'm going to click here and we have both animals and let me just change the size of this. And then we have animals and persons right there. Okay. So let's start with persons JSON and get this URL and go in here, get JSON. And right there, then we're going to give it the URL that we have like this. And persons then, as you can see, is going to be a list of dynamic. Okay. But we're going to get this and then say then, because we're on a future at the moment. So let's say JSON. And then we're going to JSON map this. And then let's say in here, we have a value. And then let's say person from JSON value, as you can see right there. Okay. Then persons is going to be an iterable of person, exactly as we want it. Fantastic. So we have that part. Then what we're going to do is to start caching this value. So let's say persons with the underscore. This is our private property. And let's say add all persons. Okay. Actually, we should perhaps set a value for it. Let's say add all can't be unconditional. So let's just say persons is our persons to list. Okay, so that's better. And we're going to do the same thing for our animals. So I'm going to copy this code and put it here and let's say animals and change the JSON URL in here and let's say animals. And in here, instead of person, we're going to say animal from JSON, and animals is animals.toList. Good stuff. So we've cached those values now, okay? Then what we're going to do is, you can see now that we've cached these values, in order to actually extract the search term from these cached data, we can call this extract things using search term. So let's just say return this guy with the given search term, which is our term, but this returns an optional list of thing. However, in here, we need an actual list of thing. So let's go in here and say, you either return the cached values or empty. And again, remember, when I say you return the cached values, this time around, cached values is after we've actually called the APIs and cached them. So it's a very important distinction in here to return the cached values or having first made the API calls and then return the cache values. Because if we don't have cache values, then the result is going to be null or empty. Okay. So this part's also done. So that's really good. We're pretty much done, I believe, with the API Dart file. So as we're developing the UI of our application, we're going to be in some different states. Let's say that the first state that the user ends in is just a state being stale. The cache, there is no cached value, no API calls have been made. Nothing has really happened. So that's one state. The other state is as the user is typing, then we're, for instance, going to start loading. So there's a loading state. And also we have another state where the user stopped typing, and then we've hit the APIs and returned some results to the user. So that's another state. So we're going to go ahead and define these results in here. So they're called search results. So we're going to go inside. I'm going to close these files, which we don't need anymore. Bring up the Explorer. collapse these folders. Let's go in lib bloc in here. As you can see, let's create a new file, which we call search result.dart. And we're going to go ahead and define first our search result as an abstract class, because we're going to basically subclass it. Okay, so let's say abstract class search result. Okay, like this. And we could actually make this immutable to ensure that all the classes that derive from it also are immutable. So let's just import foundation and then say show immutable. Okay, like this. Good stuff. I'm going to hide these errors that are being provided by Flutter 3, but we don't have to worry about them for now. Let's go and then implement the loading state. So inside the loading state is really just a search result, which has no other property. So we could go ahead actually and add a const constructor for this guy. Okay, and let's go ahead and say immutable class search result loading, and this guy implements search result. And we can create a const constructor for this guy as well. Okay, it's just some boilerplate basically. Then we also have to have a case where we get no results back. Because remember, if you go to our API Dart, this function that does the actual search, it returns a list. However, what happens if we cannot find what you search for? So let's say that we have some values inside the caches and you search for something that we don't have, then we're going to hit this statement right here at the end of the search, which is an empty list. So let's go ahead and define a search result for an empty state. Okay, so I'm going to copy paste that guy in here because this is really just boilerplate stuff and is not really contributing so much to this chapter as a whole. So I'm just going to copy paste as much as possible. So that's for no results. And also we're going to implement the case where we have errors. Okay, so I'm going to copy paste that as well in here. So let's say that we have a search result has error. It implements search result. However, it has an error object inside it. All right. After that, we also need to do the state, which is most important to us at the moment, which is having results. So let's copy paste that in here as well. So I'm going to bring it here. As you can see in here, we have a search result with results, implements the search result, and it has a list of things named results in it. So we have to import thing in here. So like that. What we need now is really to implement the business logic. I mean, we have this block folder, which in itself includes the API and the search result. However, nobody's really actually calling this API. Nobody's really looking for like text changes. And this block that we're going to implement right now, let me bring up the caption at the bottom of the screen, is going to be Rx based. So this is pretty much like the first bit of Rx code that we're going to write in this example in this chapter. So for me, this is the exciting part because we've done the boring part of calling APIs and none of that had anything to do really with streams or Rx at all. We had some features in them, but yeah, that's not really Rx. So in this block, what we need to do is to somehow allow a text field to bind its text changes to our block. And as those changes occur, then the block is going to use the API Dart file or the API class in order to search for what the user is typing in that text field. So we're basically talking in here about behavior subject. So we're going to expose this behavior subject as a sync of string. Remember, sync is write only. Then the text field is going to bind its unchanged unchanged parameter to this block's sync of string. As this value pours into the sink, and remember, we're talking about streams in here, kind of like think of water. That's the reason it's called sink as well. So we have a sink of string. The value comes from the text field, goes into the sink of string. And then this sink of string is going to grab this value, make the API calls, and then cache the results, return it. So that block is going to basically glue the logic together. Okay. Let's go ahead and create this search block. As you can see in lib block, I'm going to right click in here and say search block. Okay. And in here, we're going to start creating the class for our search block. So let's go in here and say basically we have an immutable class search block like this. Import foundation, you must be used to this by now. I do this quite a lot when we're creating immutable stuff, so good. Now that we have the basic search block class in here, we need to first define where the UI writes its changes. Remember, the UI is going to have a text field, so we just mentioned that it's going to be a sync of string, okay? So let's expose the write-only stream that the UI can use to start searching, basically. So we say a final sync of string, and then we're going to say search. In here, we have the search, and then let's go to the next property, excuse me, which is going to be the stream of results. So as the user pours their search terms into the sync, then we're going to expose a stream of results to that user. So it's beautiful. You write to something, and then you read the results back as a stream. Okay, it's a beautiful API in my opinion, at least when you're using RxDart. So let's define a final stream in here, and we say we have a search result. Let's auto import this, okay? And it's an optional search result because by default, when you start using the application by default, we say we don't have any search results at the moment, okay? And then we say results. Okay. Now, what we need to do is to create a private constructor for these two fields, because remember, whoever calls search block, like the UI, when it creates the search block, it doesn't know what values to provide for these two fields. It is not the job of the UI to provide these values. It's actually our own job in here inside the search block to provide these values, okay? It's nothing that the UI can provide to us. So we need a constructor. So what I'm going to do in here is create a default constructor, okay? And we're going to make this constructor actually private. So let's go ahead and make these required properties like this, okay? And then I'm going to say in here required. And let's go ahead in here, make this a constant constructor as well, a const constructor, and make it private, just like this. So it's a constructor named search block with an underscore, actually. So the name of the constructor itself is actually underscore, meaning it's a private constructor. What we need to also do now is to create a factory constructor for search block. So we have this private constructor, but the factory constructor is going to be called from whoever is actually creating an instance of search block. So let's say factory search block like this. Okay, so the factory search block needs an API. So let's say final API. This is a required parameter. Sorry about that. Required. And let's put this in curly brackets like this. And API we have to import as well. So the search block expects an API, so it needs to work with an API. And it's not going to create it itself. So it basically takes it in as a parameter. Okay. So we have quite a lot of errors in here. I mean, we have this and this and this. So, but don't worry about that. We're going to fix them soon. It is a little bit messy when they're all in your face, but we're going to fix them, I promise. So the first thing we really need to do in here is to define a behavior subject. So I know this is a kind of like a mental gymnastics. What you need to know in here is to look at what you're exposing as your interface. You're exposing a sync, a write-only stream, and you're also exposing the results. So the results of this search. So what we want is to create like a bridge between this write-only sync and also providing the results. So how do we do that? How do we grab the changes in the search? Remember, if you say in here, final text changes is a behavior subject of string, this is both a stream and a sync. Remember, text changes, sorry, behavior subject internally uses stream controller. And as we talked about it before, a stream controller is both read and write. A stream is read only. Sync is write only. Stream controller is read and write. If you have text changes in here, you could return it as part of the sync. You can actually convert this text changes in here. You can see you have a sync. So there's your sync parameter. How do we then get the stream of search results? Well, given that we return this text changes as sync as the sync of search, anytime the UI writes to this, our text changes stream controller produces a new value. By it producing a new value, we could use Rx to actually do the search and bind the results of that search to this stream of results. So it is very easy. However, it requires quite a lot of focus and understanding of how APIs work together with Rx and how you actually hide the details of your implementation so that the user doesn't have to be worried about how does it work internally. So we're going to fix that, so don't worry about that. So we're working now to implement this factory constructor. Let's keep doing that. So let's say final results, which is going to be this thing. So let's just actually aim to have results as this type, okay? And then we're going to say is equal to text changes. So as the user is changing the text, let's get the distinct values. And then actually, if we remove the stream for now from here, we get less errors because the data type doesn't yet match. So we get the distinct values, and then we're going to debounce time. And for this, for debounce time, we actually have to import Rx. So let's go in here and say import RxDart. Okay. So here we have debounce time. And let's say in here, we have a constant duration, milliseconds of 300. This is just an arbitrary number. You could make it larger or less, or you could completely remove debounce time. I don't, however, recommend actually removing debounce time completely, simply because when you're making API calls, even though in our example, we're making API calls only once and caching the results. However, sometimes in real production applications, you will be making API calls as the user is typing. In those cases, I highly recommend that you put a debounce time in there, because you don't want to bombard your servers with unnecessary API calls as user types. The user could be typing 300 characters, but you don't want to make 300 API calls. And apart from not putting so much pressure on your server, you also, on a mobile device, for instance, if you're creating an iOS or an Android application or both, you don't want the telephone or your agent, like your iPad, or even if it's your tablet, you don't want those devices to make 300 API calls, because those are expensive. And some people are like on paid plans on their phones, so you don't want to make them have to pay more because you're basically consuming all the data that they have available on their phones if they're not connected to Wi-Fi, of course. So highly recommend to put debounce time in here, okay? And what we're going to do in here is very, very exciting, because what we need to do really is, as the user is typing, if I put a semicolon in here, if you look at what the results is actually is a stream of string. It is literally the stream of what the user has typed, okay? So once that happens, what we want to do really is to make an API call. If we go back to our API class in here, remember, this guy is a future that does like your search. So how do we expand every element of our stream? So let's say that this is our stream. It starts here, okay? If I put a comment in here, let's say that this stream starts here when the application starts. Then it goes by, it goes on, and the user starts searching for F, okay? So this is a value that comes in here. And then the user doesn't do anything for 300 milliseconds. Then our UI, the debounce time realizes that, oh, user didn't do anything for 300 milliseconds, so I'm going to produce the value of F. So the result will be that right here, the value of F will be produced, because, yeah, that's debounce time. And once this value is produced, per this value that is produced, we want to make an API call, right? So we are on an asynchronous stream of data, and we want to make an asynchronous API call for every value that is produced in this stream. So there is a very handy operator. Remember, I said that Rx is just a bunch of operators. Once you learn these operators and how to use them, you've learned Rx. So there is an API, there is an operator called switch map. And you can see in here what it says really converts each emitted item into a stream using the given mapper function. So basically you get every element, and then from your switch map, you can actually return a stream of a result. Okay, so if I go in here and we say we have a switch map, and in here, we're going to actually return an optional search result, then what comes in here really is the search term, right? So if I say string of search term in here, all right, and then we open the parenthesis. So we get the search term in here, and our responsibility now is per search term is to provide a stream of search result as optional. So let's go ahead in here and say if the search term is empty, search term, oh, it's with a capital T in here. If the search term that the user has provided is empty, what we want is really just to return a null, a stream of search result with the value of null. So let's say return stream of search result as an optional, okay, with just a simple value of null. So that's that case. All right, so the search term is empty. However, if the search term is not empty, we have to call our API class in here, okay? So let's go in here and say Rx, we see there is this Rx abstract class in here, and Rx abstract class has a lot of functions that are quite useful, right? One of these functions is called from callable, right? You can see this callable, what it does is that it basically allows you to have a function in here that returns a future, and then the result of that future will become a string. So let's go in here, and then we say, okay, what we're going to do is to actually make an API call. So let's say API.search, and then we have the search term, okay? So if I say final foo is that, now you can see foo is actually a stream of list of things. So this is beautiful. So you did that with from callable, okay? Now that is a stream of list of things, what we want to do is to delay the result, the provided result in here. And simply, I mean, this delay is simply there because we want to fake network latency in here. These APIs at the moment are sitting on our computer, so there's pretty much no latency, or maybe just a very little tangible amount of latency in there. But to fake actually a longer network latency, for instance, being on a 4G or 3G connection, we're putting a delay of returning those results to the user. So let's say const duration seconds 1. And then what we're going to do is, since remember when we need to return search result. However, the result of this, so if I say final foo, you can see this is a stream of list of things. So we have a list of things, but we want to return a search result. So we need to map this. We're on a stream, but there is a very handy function on stream called map. So what map does is per element produced in the stream, it allows you to change that element to something completely different. So in here, if you wanted to, let's say here is the results, and all I do is just return an integer 1. Okay, so if I now go final foo, foo is a stream of integer. Because without this map, foo was a stream of list of things. But after map, since Dart understands that we're producing integers for any element produced by the stream before it, which is up to this point, since converting anything to an integer, the result will be a stream of integer. You could do this map as many times as you want. So if you say in here map results, let's integer, and in here you produce hello world, now foo is a stream of string, right? So mapping is one of the most used operators on Rx. So it is very, very commonly used. Mapping is synchronously done. So for every element that is produced in the stream, you need to do something synchronous, meaning that you're not allowed to make any API calls. And switch mapping is the exact similar operator for map. However, it is asynchronous. So remember, if you just need to change data, change data type synchronously, use map. However, if you need to do something asynchronous, use switch map, okay? So here we have map of results. So we get the results, and then we're going to say if results is empty, so if we didn't get any values, then we're going to return a const of search result, no result. Otherwise, so let me just break this down into separate lines so we see them better. Otherwise, we're going to return a search result has results or something. I think we call it search result with results, and we put results in here, okay? Like that. So now if you look at foo, what is it? Is a stream of search result. That is beautiful. That is really good, okay? So we have foo and we have our search results, but there are a few more things that we have to do. So as the user starts typing, what we want is to start loading. So we have to say per text changed in the text in this search term. Let's go in here. In here, you can see we have a sync of the search term in here, which is a string. Once that changes, every time that changes, we want to start the entire stream with a search result loading. Okay, so start with is another Rx operator that I believe is very important to learn because it's very commonly used. Its sole purpose is, let's say that, let me demonstrate that by putting a comment in here. And let's say this is a stream that starts here. This is a starting point, and it just continues, and then it produces the value of foo. Then it continues and produces a value of bar. Okay. However, let's say that you want to take this stream that is up here and change it so that by default it produces the value of actually, let's change this to bar and baz. Let's say that you want a stream that is exactly the same thing, but you want it to start that stream, the resulting stream, with the value of foo first. So then you would say, if this is stream 1 and you want this to be stream 2, then you could say stream 2 is stream 1, start with foo. Okay, so this creates a new stream that first produces foo and then reflects exactly the same changes that happened to stream 1. Okay, so start with is very, very, very useful, especially when you're, for instance, doing things that we're doing. So we're starting always in the loading state, okay? And it's just another operator that is handy to know about. So after doing this, we need to also handle errors. So there's an operator, we say on error, return with, and here we get the error and the stack trace. We ignore the stack trace. What we'll do then, we say search result, error, and we just put the error in there. So if we now look at foo, you can see as a stream of search result, okay? So what we could do is just to return this guy like that, okay? And then put a semicolon there. So you can see now, if the search term is empty, we just return null. However, if it's not empty, we do an API call, and then we place those values inside the appropriate search result object. All right, and let me just remove these comments that I place here as well. Great stuff. Now that we have results, we could say that this is a stream of search result optional. All right, and to be honest with you, you don't have to type it. But I just wanted to show you what it is. Okay, now guess what? Now that we have that, now that we have the results based on the user actually typing something from the factory constructor of our search block, we need to return an instance of search block. So let's go ahead and say return search block using the private constructor, and the search itself is going to be our text changes. Okay, because remember, search is a sync of string. Search is a write-only buffer. So the UI is going to write to this guy. However, the backing store of that write-only stream is, in fact, behavior subject inside our factory constructor. So let's go in here and take our text changes in here and expose a sync as the search. And results is just plug and play because we already have results in here, you can see, right? Which is a stream of search result optional. That was really it for the factory constructor. Again, if you're looking at this or doing this kind of work with Rx for the first time, it is mental gymnastics. However, know that Rx is an advanced state management solution. Don't give up just because in the beginning it's difficult. A lot of developers give up on Rx because they just can't wrap their head around it. And then they go ahead and start hating on it. And they go everywhere and say, oh, I hate Rx, it's just so difficult. But if you really ask them, how much do you have professional experience with Rx? They probably will say none because, well, they just gave up. Please don't be discouraged if everyone tells you Rx is bad, it's difficult, it makes the code polluted. Rx is as good as the developer using it. It is really just a series of operators and works with streams and futures, of course. So if you can wrap your head around how streams actually work and how you can transform streams, like you have a stream of data and you want to transform it to a stream of another data, and then for every object produced in one stream, you want to do something. If you can wrap your head around that, then you've already learned Rx. And I also say that if any developer can understand Git, you can understand Rx, because there's really no difference between the two. Git is very difficult to learn as well. A lot of software developers have difficulty with Git to start with, but once you learn it, then you start loving it. What is the difference here between Rx and Git is that Git is something that every software developer knows they have to learn. Git is something that you can't just say, I don't know how to use it. This day and age, I know about like maybe 15 years ago when I worked in England, Git was something still people were discussing. Like we were using Mercurial. Before that, we were using SVN, CVS. But once Git came, everyone was like, oh, we have to learn. It was very difficult, but everyone learned it. Rx is the same. It is kind of difficult to begin with. But once you learn it, then you know how to use it. And then you may actually love it. So all I want to say is please don't be discouraged by people telling you Rx is bad. If someone tells you Rx is bad, please ask them, what is your professional experience with Rx? And how many professional apps have you worked on that have used Rx? Chances are that person doesn't know how to use Rx. So just don't be discouraged if you think this is a little bit of a mental gymnastics. The next point that we have to take care of here is syncs. Every time you see a sync, just be a little bit wary that, actually, let's remove the subjects in here while we're at it. Sync has to be closed manually. So it's just like a sink in the kitchen. Then you have to like put a stop to it and put like a little plastic thing just to make sure that you've closed the sink. You have to do the same thing here in Rx. So what we need to do is to create a function in here, call it dispose perhaps, okay? We bring up the caption at the bottom of the screen as well. And inside this dispose, all we have to do is just to say close. A stream you don't have to close. So for results, you don't have to say close or anything or cancel, okay? So it's just the stream, the sync really that you have to close. So never forget that if you're exposing a sync, you have to close it as well, or at least provide a mechanism for the outside or the consumer of your API to close that. Okay. So it is now time, once we've implemented this search block in here, really, it's not more complicated than this. It is time to start working with the UI. So let's go ahead and collapse these pieces of code that we've written in here and go inside lib. As you can see at the bottom of the screen, new file lib views / search result view.dart. Okay. So inside the search result view, we are basically going to grab our search results, and for the search results, we're going to display the results to the user. So let's go to our block one more time in here inside the search block. What we need to work on in this search result view is a stream of search results, just like is specified in here. So let's say that given a stream of search results, we have to return a view. Okay, so I'm going to go in here and say, I want to create a stateless widget. Okay. And material is going to be important in here. Key we don't need. I wish it could just import material. So let's change that and let's say import material like this. what this stateless widget needs is our search results. So let's say final stream of search results, okay, or let's say search result in here. And let's import search results so that, yeah, that's fine as well. And then it says all final variables must be initialized. So let's add that to our properties, excuse me. And we're going to change this my widget to search result view. Let me change its name, search result view. Okay, so it changed the constructor as well. And in here, for now, we just say return text for now. Okay, so that's really good. What we need then is to grab the search results that come from this stream using a stream builder. And that's the beauty of Rx, because you don't need any kind of like block builder or anything similar to that. You already have everything you need. You have the futures inside async, inside Dart itself, you have streams, and then you have some additional stuff in Rx for controlling your streams and mapping them and switch mapping them, etc. So as long as you get your stream, you can just use built-in mechanisms inside Flutter, such as stream builder, to create your views. So let's say in here, we create a stream builder, okay? And the stream builder is going to consume an optional search result. You know about that, okay? Its stream itself is going to be our search result. And then we are going to have a builder, which is going to be our context and then our snapshot. All right, just like that. Inside this builder, then we're going to grab our data. So let's say final result is snapshot data. And remember, this search result, I mean, we could start this whole thing actually with a value, but what we're going to do is to say if. So we're going to put some if statements in here, okay? So actually, let's remove this for now. Let's do it like this. We say if snapshot has data, if we already have the data, then we get the data, okay? Because any snapshot returned, it may not have data. There's another property in here called require data if you know that you have an initial data, but we're not going to use that as well. So we're just going to say if you have data, then we're going to grab it. Otherwise, then we're going to just return a return const text that says waiting. Okay, so we can just focus on having data. Okay, so let's say if our result is a search result, because you see we have different search result subclasses. They all come from search result, but they have different names, so they have different purposes inside our application. So we say if the search result has error, okay, then we're going to say return const text got error. Else if result is search result loading, and let's just return a circular progress indicator. So let's say return circular const circular progress indicator, just like that. So this is the loading state, and this is an error state, okay? They're quite self-explanatory, to be honest. If we get no results back, that's if result is search result, no result. No result, what we're going to do is just to return some text, and I'm going to copy paste that so we don't have to type it by hand. Okay, it just says no results found for a search term. Try with another one. And then we say else if result is search result. And if we have results in here, then this is the exciting part, because that's where we have to build a list view. Okay, so this search result view that we're working on is going to be placed inside a column, or maybe even inside a list view. Sorry, maybe inside a scroll view. So what we need to do is not just to return a list view in here, but we have to put that list view inside and expand it, because otherwise our list view won't have intrinsic height. So it just won't be rendered on the screen. So in the case of having results, let's go ahead and say final results is results.results, okay? Because remember, search result with results inside has a list of things that we have to render, okay? Well, let's say return and expand it with a child And in here, we say a list view of builder, okay? And its item count is results length. And then we have to provide an item builder as well. Let's see if Visual Studio Code can help us. It couldn't. It has a context and an integer index. So let's say context and index. And in here we have our curly brackets. And let's just put semicolon in there to get the code formatting nicer a little bit. Okay. So in the case of having results, we're just going to return a list view embedded inside expanded. Good stuff. Now that we have that, let's go ahead and actually create our cells in here. So I'm going to say final item is results inside this index. Okay, so this item is a thing. So then we're going to say if item is animal. Okay, and let's say in here final string title. And let's say title is going to be item. Actually, title in this case is going to be animal. Okay. Else if item is person. And these things need to be imported as well. So let's import animal and import person. Else if item is person, we're going to say title is person. Otherwise, if it's anything else, because remember, thing is just an abstract class, so we could add more like classes that extend thing. But if those things are produced in here, then we don't know how to handle them because we can only handle animal and person. So in that case, we're going to say title is unknown. Okay. And what we're going to do is return a list tile in here. Remember, the job of this builder is really, if you look at it, you need to return a widget. So we're going to return a list tile. Okay. And list tile then has a title property, which is going to be title list tile. Okay. And it's going to be inside a text. And also the subtitle is going to be a text of our item to string. Remember, we have we have implemented toString on thing. Like if you go thing in here, actually we have a person, I believe, person Dart. Remember toString says person, I should say person, and also animal Dart has animal in here inside its toString method. So we've overwritten those toString functions, and we're going to take advantage of that and literally place it inside the subtitle of our list tile. All right. Good stuff. We have an error somewhere, and in here it says returned. Okay. Else if, right. Because it seems like we haven't really produced an else in here. So let's say else return text unknown state. I'll make this const as well. Remember, this else statement is from all the way from here because we're testing these results and seeing what they are, but we didn't have an ending else statement because what happens if this result, which is a search result, is not none of these things? In that case, we're going to return an unknown state to the user, okay, inside a text. But it's not red anymore, so that's really a good sign. So we're pretty much done with search result view. What we need now is a home view or a home page, because search result view ideally is just returning a list view, but we also need a column and we also need a text field. So let's close this file. As you can see at the bottom of the screen, we're going to go into views and create a home page. So views, home page, Dart. Okay. And let's go in here for homepage. We're going to make it a stateful widget. The reason for that it is being a stateful widget is that our homepage is actually going to instantiate our search block. And remember, search block, upon it being called upon the factory constructor, it was creating the sink and the behavior subject, etc. Actually, it wasn't creating the sink. It was creating the behavior subject. However, behavior subject is also sink, so you have to close it. So that's why we put the dispose function inside our search block. We need to have the home page a stateful widget as a stateful widget simply because we have to instantiate the search block once the home page is created, and we have to dispose of the search block when the home page is disposed of. So let's create a stateful widget in here. and I'm going to call this guy homepage. All right. And let's say that material is imported properly in here. So let's say import material, as you can see in here. Okay. So we've created a simple stateful widget in here. So let's go then and let's go ahead and add our search block in here. So let's say inside the state, we have a late final search block. And let's auto import this guy. Okay. And we say search block. On init state, after super init state, we're going to say search block is, and to be honest with you, we could make this a private property in here. Search block is an instance of search block, and an API that is provided to it is going to be an instance of API, which can also be auto imported like this. Good. That's for init state. Let's go for the dispose function in here. Before calling super dispose, we're going to dispose of our search block in here as well. And we could, to be honest with you, just change the name as well to _block, just like that. It's a little bit easier to remember because we only have one block inside our application. In later examples where we go into creating multiple blocks, then you may want to have, you may want to call those blocks different things like the search block, the cleanup block, whatever you want to call it, or the registration block, auth block. However, here we only have one block, so let's just call it block, okay? Good. Now that we have that, let's go ahead and implement the build function in here, which is going to be quite exciting. Let's go ahead and return a scaffold for the app bar. We're just going to call it as search. So let's say we have an app bar in here, and its title is a const text that says search. Search, just like that. Okay, good stuff. Now, the child of the scaffold, as I mentioned before, when we were implementing the results view, is going to be a column, which is going to have our text field. And after the text field, we're going to display the search results. So let's go ahead inside child in here. Oops. App bar. Then we have the body. Okay. And for body, we're going to say column for now. And its children is empty. Okay. Then I'm going to basically embed the column, wrap it with padding. Okay, that default padding is enough. Inside children, let's go ahead and create a text field. All right. And we have some decorations for it. I'm going to copy paste the decorations because it's kind of unimportant. But yet it is quite important as well. The decoration says enter your search term here. Okay. We have quite a lot of errors or warnings in here, which have to do with const. So, but since we don't need this const really here, I'm kind of reluctant to add it. So let's just live with these warnings for now. After the decoration, we need to, as we saw before, every time the user changes a text in this text field, we need to add that text into the sink of our block. So unchanged, we're going to say is going to be our block search add. Okay, so this is sending the text changes to the search sink in here. Okay, that's really good. So the text field is in place. Right after creating the text field, we need to go ahead and maybe add some spacing in here. So let's say const size box with a height of, what should we say, 10 perhaps? After creating the size box, guess what? We need to display the search terms. So let's go in here and say search results, the search results. So we're going to display the search result view. And this guy needs the search results as a string. Guess what? That's inside our block, and that's inside results. Okay, so I'm going to save that like this. So what we need to do then, now that the home page is done, it's a new widget. We need to go ahead and add this inside our main file. So let's go main Dart. So what we have in here, we have another home page. So let's just delete this one. And then inside here, let's import the other home page. Okay, so your main Dart file looks like this now. It doesn't have a home page internally, but it's using the home page that we just implemented. So I'm going to save this file, and I'm actually going to hot restart the entire application. Okay, the output looks fine to me. And let's go ahead and test this guy out. So I'm going to bring up the simulator. Okay, and as you can see in here, it says enter your search term here, and it says waiting. Then let's search for F, and you can see the loading. If I remove F, it says waiting, and I say bar, searching, and then returning bar. And if we search for floof, no results. Let's go to animals. We have fluffers, so let's search for fluffers. Animal fluffers, and we have buns, woofson. So if we search for O, or maybe if we search for U, then we should be able to find both fluffers and buns. Okay, so let me search for U in here. You can see we both found fluffers and buns. And also we have persons with foo, bar, baz. If I search for O, we should both find a person named Foo and an animal called woofson. So let's search for O. You can see that both were found. So this is really good. And you can see the loading states working. That's the start with. So it's kind of like coming to life, all the logic that we put inside the Rx bits of the block. So Rx is complicated to start with, but once you get to know how to use it, it is a joy to work with. It is something that I can stand by that statement to anybody who doesn't like Rx. I can literally tell them that, well, it's perhaps because you don't know how to use it. It is a joy to work with. It makes your code a lot easier to understand, and it has a steep learning curve. I can't deny it. However, a lot of things that are worth learning have a steep learning curve. Git has a steep learning curve. A lot of developers have problems with that to begin with. However, once you set your mind to this statement that I have to learn it, then you will learn it, and there's no other way. And if you want, I mean, to me, one of the best ways to learn is to tell myself that I have to learn it. And also the second thing is that I love it. Because a lot of software developers go into learning something literally from the absolute beginning. They were like, oh, I hate this so much. This is bad. This is wrong. If you go with that mindset into learning something, it's going to make your life a lot more difficult. So my advice is love it and really try to learn it. Okay? Go in with that mindset. Hopefully that helps you out. Good. Now that we're done with this, let's go ahead and commit our code. So I'm going to bring up the terminal. Let's go in here and let's say git commit or git add all git status and git commit step 2, as you can see at the bottom of the screen, step 2. Okay. And let's say git tag step 2 as well. So if you look at our commits, then we have step 1 and step 2. And if we look at our git tags, we have step 1 and step 2 as well. Now that we're done with that example, let's go ahead and talk about some more of RxDart's operators. And these are really not just RxDart operators. These are just simply generic Rx operators that are available in RxDart as well. But in order to learn Rx, we have to be able to master some of these important operators that are commonly used, from my experience at least, in Rx related projects. So let's explore some of them together. As I've mentioned before, Rx is, it is a toolbox. So it is I personally don't think of Rx as a huge library or a package, for instance, in Dart. It is mainly working with streams and futures, but it gives you some handy utilities and operators to work with in order to make your life easier. So as long as you're comfortable with streams and stream builders and stream controllers in Dart, you should be able to understand at least the basics of RxDart. What we're going to do now is to go ahead and talk about a new operator, which is called combine latest right now in this example, in this chapter. So what we need to do first is to get rid of some of the stuff that we've created in our project. So as you can see at the bottom of the screen, we're going to go and remove everything inside lib except for our main Dart. So I'm going to select the block, models, and views and delete them. Okay, so let's just delete all of those. And then we also have our APIs in here, which we probably won't need, but let's just leave them here. We also have our live server still running, I believe, so that's okay too. Now, let's go ahead inside our main Dart file and create an empty scaffold. And I already have the FSA shortcut in here. As I mentioned at the beginning of this chapter, I have a video on YouTube that describes how to create this FSA shortcut in Visual Studio Code to create a simple scaffold application. Even if you don't have that, just have a main function in here with run app and an app stateless widget, which creates your material app. And then in there, we're going to have a home page, which also is a stateless widget. Good. Now, we're going to go ahead in here and create a simple function. As you can see, we're going to call it testit. And the purpose of this function is just to create an asynchronous function that we can call from the build function of our homepage, so that every time that this homepage is rebuilt, then this tested function is going to be called and it's going to execute the logic that we're going to write in. So because we're just testing at the moment some operators in Rx, this function is called tested. So let's say void tested async function, and let's go in the build function right here and just say tested. Okay, just like that. We're not going to await on the results. We're just going to ensure that there's an async function and we're calling it. Okay, so let's save this file. I'm going to just do a hot restart of the application as well. And if you go to the simulator, this is how our application should look like, with just simple home page and just a tested function in here. Okay, so let's now talk about the combine latest operator, which is what we're going to discuss in this example in this chapter. What combine latest does is that it takes the latest element, as its name indicates, from two or more observables or streams in this case, and it takes that latest element and it passes those elements to you so you can map them to another value. It is a little bit difficult to explain until you've actually seen the marbles for it. So let's go ahead and have a look at the RxMarbles for combine latest. And I've already prepared it. I'll just place it right here. So what you'll see in here is that if you remember from merge, let's go to merge first. If you remember, this is the first stream. This is the second stream. And when we were doing a merge on these two streams, merge takes any element from any of the streams that is passed to it, and it will provide that value to the resulting stream. So just like merging commits on Git branches. So stream 1 produces the value of 20, and that 20 is immediately reflected on the result. Then 40, 60, and then stream 2 produces the value of 1, and that 1 is reflected on the result. So that's what merge does. It just produces any value from any of the streams that are being merged and then puts those values in the resulting stream. However, if you look at combine latest, you can see here that the first stream has produced the value of 1. However, that 1 value has not been reflected in the results. The reason behind this, and this is one of the reasons that some people have difficulty with combine latest, is that you need to actually have a look at the name of this operator. Combine latest is not like produce latest. Combine latest, meaning that it's combining the latest values of all the observables or streams that this operator has been provided with. In this case, there are 2 streams provided to combine latest, the first stream and the second stream. The first stream has produced a value, meaning that its latest value is 1. However, at this point that the stream 1 has produced a value of 1, the second stream has not produced a value, meaning that it has no latest value. Therefore, it cannot be combined with the latest value of the first stream. As you can see then, as soon as this A, or the second stream, produces the value of A, 1 and A are going to be combined in 1A, which is reflected in the result stream. You can play with these. You can see here now what happens is that the first stream produces then a second value called 2 in here, and then you will see in the resulting stream there is a 2A. And the reason behind this is that as soon as Rx looks at the value 2 being produced, it says, okay, the latest value of the first stream is actually 2. Do I have the latest value or any value that was produced at the end of this, or I shouldn't say at the end, I should say, do I have any value recently that was produced by the second stream? Yes, it was A. So the latest of the first stream and the second stream together is 2A. Okay, so that's how it calculates things. Once stream 2 produces the value of B, then the latest of first stream and second stream is in fact 2B, and that's reflected here in the results. Now, you could play with these marbles, and like if you move this B over here, and if I move this A after the production of the second value from the first stream, can you guess what happens? Do you think, I mean, if you pause the video right now and I move this A over here, do you know what will happen? How will the resulting stream actually look like? Excuse me, that could be a good thing for you to know. So if you're new to Rx and you don't know, for instance, completely how combined latest might work, I suggest that you pause this video right now and think about that. So what will happen is if I move this A production to after this, you can see the resulting stream will be right after A, it will be 2A. And then as soon as B is produced, then the latest of the first stream was 2. So it will be 2B right here. So do you see the resulting stream, how it changes? Right? It's very important to play with these marbles and kind of get an idea of how various operators in Rx work. At least that's my opinion. Okay, so that's how combined latest works. We got the basic idea of it. So let's go ahead now inside our project and test it. And we're going to create a simple stream, which is a stream of periodic. So let's go in here and say stream periodic with a duration of 1 second. So let's say const duration seconds 1. Okay. And then what we're going to do is that we're going to get this count that is being produced in here, and then we're going to output a string. We're going to say stream1 count is $count. Okay, so that's our first stream. And I'm going to save this inside a stream1. Okay, so that's our first stream. Then we're going to create a second stream, which ticks every 3 seconds. So this one ticks every 1 second or every second. And then the second stream is going to tick every 3 seconds. So let's go say a stream2, and it produces a value every 3 seconds. And then in here, we're going to say stream2. Now, how do you combine these two? Well, we're going to use Rx abstract class in here. And in there is, well, we have to also import Rx, of course. So let's go ahead and say import Rx. Then we're going to go in here and say RxDart combine latest. And as you can see, since there are no variadic parameters in Dart, there are some languages that support that, but you can just say combine latest, and then you can pass any number of values in here. For instance, Python supports it. So, but Swift and Dart, for instance, don't support variadic arguments. So what you need to do in here is to pick a flavor. So either you're combining the latest value of 2 streams or 3 streams, 4, 5, 6, 7, 8, 9. In RxDart, it goes up to 9, but I know in RxSwift, I think is up to 8. So you can combine 8 observables or streams in RxSwift, but you can't combine 9. If you want to combine 9, then you have to kind of create your own hybrid objects and then place your 8 first values in that first object and then combine that with another hybrid object. So you could create more combinations, but this is the default that is produced, so or provided. So in here, we know that we're combining 2 values or 2 streams. So let's go ahead and say stream1 and stream2 in here. And as you can see, it then provides us in the third parameter, it gives us those values back. So it says, okay, here's A, which is the last value of the first stream, and here's B, which is the last value of the second stream. Do something with it. So let's call them 1 and 2 in here, and let's produce a string. So let's say 1 is $1, and then we're going to say 2 is $2. Okay, and put a comma in there. And if you say final combined, now if you move your mouse over this combined, you'll see actually it's a stream of string because the result is a string. So if you looked at that marble, the result in here was like 1A, 2A. This is just an example because there's no mapping function. The map function in here, you can see, is literally this, is a string of x plus y. However, our mapping function in here, it maps it to another string that says 1 is $1 and 2 is $2. Okay, so combine latest always has a mapping function, which is a synchronous function. So if you look in here, it says, given the value in this first stream and the second stream, or the latest values in these streams, produce a new value of type t, and the resulting stream will be of that type as well. Okay, great stuff. So that's what we did with combine latest. Okay, so let's go ahead and add a log function to our application. So we're not going to use print because we're discouraged from using that in production applications, for instance. So I have a little import in here. You can see import Dart developer as DevTools show log, and then an extension on object that allows us any object to be logged to the console, as you can see in here. Okay, let's go ahead here, and after combined, we're going to log the results. So let's go ahead and say for wait for final value in combined, and we're going to say value log, just like that. Okay, so I'm going to save this, hot restart the application, and then let's go test it out together. So I'm going to bring the console up. If you look here, what's happening is, maybe I should actually start it from beginning. Boom. Okay, so you see stream 1 produces value every 1 second. However, stream 2 produces values every 3 seconds. And that's why the absolute first item took 3 seconds to be produced. This is one of the things that trips up a lot of new developers to Rx and a lot of newcomers to Rx. Like if I start this from beginning, you'd be like, okay, but stream 1 produces values every second. Why did the result take 3 seconds to be produced? So 1, 2, 3. You see, it waits 3 seconds. And the reason behind that is that stream 2 takes 3 seconds to produce its value. Until stream 2 has produced at least 1 value, stream 2 has no latest values, meaning that the result of combine latest is going to wait until stream 2 at least has its own last value or latest value. And at that point, here it's a stream 1 count 2, and then stream 2 count 0. So at the point where stream 2 actually produces its first result, which is 0, stream 1 has had the time to produce 0, 1, 2, meaning its third value. Then what happens is it goes by 1 second, and then stream 1 produces another value of 3. However, at that point in time, stream 2 has not had the time to produce a new value because stream 2 needs 3 seconds. This 1 second passes, stream 1 gets a new value of 3. However, stream 2 is still on 0. Another second passes, the same thing. Stream 2 has not had the time to produce a new value. The third second passes and stream 2 still has not produced a new value. However, at the beginning of the 4th second, where this value is still 5, stream 2 has the opportunity to create its new value, which is 1, because 3 seconds have gone by. So you can see it's really just, as its name indicates, is a combination of the latest values of those streams. You need to be careful a little bit about the weighting between the production of the values. Anytime, let's start from beginning. In the beginning of the combine latest, the result of combine latest will produce an element as soon as all the streams that are passed to combine latest have produced at least 1 value. So that's the rule to begin with. However, as soon as all streams have produced at least 1 value, after that, anytime any of the streams produces a new value will be produced in the entire result, because now that new stream that produced a new value got its own latest item, and then combine latest will have a look at all the other streams, be like, they also have their latest items. It may not be new, but they still have their latest items. Then it combines them using your map function, or by map function, I mean the function that we passed as the last argument to combine latest in here. And I don't want to say the third argument, because if you have combine latest 3, then you have the third stream in here. So the mapping function is always the last function in combine latest, okay? It passes those latest values to your mapping function in here, and with those values, you can produce a new value in here, okay? This value doesn't necessarily have to be the same type as these streams contain. So you could just produce the value of 1 if you want in here, and your combined latest will then produce an integer, as simple as that. So this will be a stream of int, you can see in here, okay? So where is this combined latest actually good for? In my opinion and in my experience, combined latest is quite useful when you're doing UI work. So let's say that you have 3 switches, for instance, on your UI, and then the user is like flipping these switches on and off. And these switches by default have a latest value when you create them. Like their latest value is actually their current value. Either they're on or off. And as the user flips these switches on and off, you may want to grab the latest value or the latest state of these switches and perhaps make an API call, or maybe do some filtering on a list. So combined latest is really good if you're actually combining latest of some, for instance, UI components, as long as they have some sort of a state or value, such as switches. So that's one way combined latest is very useful. Okay, so just to circle back to this tripping point that I've seen a lot of Rx developers have with combined latest, is that sometimes combined latest may just not produce any value. And then developers go and scratch their head like, why is it not producing a value? If that happens, just know that one or more of the streams that you pass to your combined latest has never produced a value. That is the only reason, usually, actually, or maybe that stream has failed, which itself means that it has never produced a value. So if you see combined latest not producing value, just have a look at all the streams that you've passed to combined latest and ensure that they're producing values, okay? Okay, we're done with this example. Let's go ahead and commit and tag this as well. So I'm gonna go to terminal in here, and let's say git status, change the log, and then git add all, git commit, step 3. And then let's tag the code as well as step 3. Okay, so git status, git log, we have step 3. And then if you say git tag as well, we have 1, 2, 3 in there. Good stuff. We are done with this example. So let's move on to the next one. Now that we're done with this example, let's go ahead and have a look at another quite important Rx operator, which is concat. And concat really, as its name indicates, is very similar to how you would, for instance, concatenate string. Meaning that if you have a string that says hello, and then you concatenate another string to that first string that says world, the resulting string will be hello world. And concatenation in RxWorld also works the same way, meaning that if you substitute those strings with streams, once the first stream finishes its work, meaning that it produces as values, or perhaps it's a value, or perhaps the stream finishes with producing no values, as soon as that stream finishes, the second stream that was concatenated to that first stream will begin its work, and so on and so forth. So if the second stream then terminates either successfully or with a failure that you've handled, then the third stream, if there is one, will then start its work. So concatenation is very, very important, especially if you're doing work that depends on the first. So let's say, actually, I should rephrase that. If you're doing work that depends on some work being done before it, this, in my opinion, is quite useful when you're making API calls. So let's say that there is a transaction that you have to do. Let's say that the user does something in your application, and by doing that thing, you have to make 3 API calls. The first API call is standalone. the second API call's input depends on the output of the first API call. Let's say that the user wants to check out the items in their basket, and then you make an API call to start a transaction with the backend to get a transaction ID. You make that API call, get the ID, and then you concatenate the next API call with the first API call, meaning that you get the transaction ID and you pass it to the next API. And then the second API continues its work and does something, produces some value, which the third API call, for instance, needs then to continue its work. So that's how concatenation works in Rx. So we're going to have a look at how that looks like by first looking at the marbles for concat. So I'm going to search here for concat. Excuse me. So you'll see here that the first stream has the values 1, 1, 1, 3 of them being produced on the first stream. And then the first stream ends here, you can see. This is the ending point of the first stream. And then we have the second stream that is producing the values of 2 and 2. Unlike merge and combine latest, the second stream's values don't matter until the first stream actually has finished and terminated successfully, upon which the second stream's values will be produced. So you can see the result of the concatenation is actually all the items from the first stream followed by all the items from the second stream. And if there was a third stream in here, then the third stream will start producing its values as soon as the second stream's finished successfully. So that's how the marbles look like for concat. So in here, actually, I need to change the text at the bottom in here. So I'm gonna say combine latest 2. So I had a little mistake in the caption I just noted. So what we're gonna do is to reuse the code that we've written in here. And let's just go ahead and keep the streams that we have in here. And the only thing we're gonna do is to remove this combined value at the end. So keep stream 1 and 2. And just remove the combine latest 2 and the results from the end. Okay, so what we need then is to do a little bit of a take 3 as well on our first stream. So this is a new operator called take 3. And actually, sorry, it is called take. It's not called take 3. This operator, as its name indicates, it grabs the values, as many values as you give it, an integer number. So let's say you say in here take, see it's an operator, you say take 1, or you say take 2, or 3, 4, 5. What this does is that it only cherry picks as many values on the stream as you provided here. So if you say in here take 3, if let's say that I'm actually going to write our own marble in here. So let's say that this is our stream. It begins here and it continues and provides the value of 0 and then goes ahead and provides a value of 1. I'm going to copy this and say 2 in here and then 3 in here. And let's say also 4 in here and then continues and it finishes. Let's say that this is our stream 1. Okay. If you say take 2 on this stream 1, the result, I'm going to write it here like this. What will happen is that the result of that stream will be this first stream, which is stream 1, but you've picked only, or you've taken only 2 elements from that stream. So what will happen is that the first value will be produced, that's 1. Then the second value will be produced, that's 2. And right there, the stream finishes like this. So that's what take 2 does. Had you said take 3, it will say, okay, I'll take only 3 items, 0, 1, 2. And the important thing is, as soon as the third item is produced, the resulting stream actually finishes. It terminates. It doesn't do like this. This is a completely different way of thinking about it. The stream will not continue until the first stream actually is finished. The result of take 3 in this case finishes exactly when the third item is produced on that stream 1. So by saying take 3 in here, we're saying, okay, we're only interested in stream 1's 3 first items. And the rest and the resulting stream, which is stream 1, is actually going to terminate when 3 items have been produced in this stream. So this is one thing that I usually say to people who are learning Rx. in Rx, when you're adding various, so let's say you have a stream in here. I'm going to write a multi-line comment in here. Let's say we have foo, and then you apply a new operator in here. Let's say you say take 3, and then you say debounce, and then you say merge, for instance. And this is usually not how we write Rx, like merge with what, but I'm just giving you an example, okay? A hypothetical one. And then you say merge and then concat. Now, what's important to understand here is that this foo, let's give it an ID of 1. This is one stream, okay? With the ID of 1. So this is stream 1. Actually, let's just call it stream 1. When you say take 3, this is not anymore the same stream. It is actually a new stream. It is not, doesn't even have the same instance. So this will, in fact, be your stream 2. When you say debounce, it will be stream 3. And then this is stream 4. And then this is stream 5. So if you then place this, let's say final result is this, what you're doing is that your result is in fact stream 5. So by applying operators to your streams, Rx operators, for instance, you're actually creating new stream instances, and then you're storing them in your variables. So in here, stream 1 is not this periodic stream that just goes on and on. This is a stream that is stored in memory, and we don't have a reference to it because we're applying a new operator to it called take 3. And this take 3 is actually creating a new stream, which is the result of this one, by cherry picking only the 3 first elements from that stream. So keep that in mind. In here, we're not working any longer with this initial stream. We're actually working with take 3. If you add new stuff to this, if you say take 1 on that one, then this is a new stream of its own, okay? Hopefully this clears things up a little bit in our head. So we're picking only the first 3 elements from this stream, and then after this, our stream 1 will finish, okay? And will terminate. So let's go ahead and concatenate these 2 streams. So let's go ahead and say final, if I can spell. Final result is stream 1 concat with stream 2, okay? So concat with, oh, this needs to be a list. Okay, and then we're going to say await for final value in result. We're going to say result log like this. Value here, value log. Okay, I'm going to save this and then I'm going to restart the application. Let's see what happens. This is really good, actually. I'm just waiting for these values to keep getting produced a little bit so we have some more data to work with. So let's see what happened. You can see that stream 1 produced the value of 0 because that's the first index. Then it produced the value of 1, second index, and then the value of 2, which is the third and the last index. The reason that it is the last index is that we have a take 3 on it, meaning that we only are interested in 3 elements from that stream. As soon as that happens, then you can see that this stream 1 actually completely disappears from this entire list. It doesn't exist anymore because it has completed its work. It has produced 3 elements that we were interested in. And after that, it doesn't exist anymore. At which point, stream 2 takes over because it is concatenated with stream 1, and it will produce the value of 0, 1, 2, 3. We could actually change this stream as well to produce values every second. And you'd still see that the stream will wait until the first stream has completed its work. So let's test this out now by having both of them produce values every second. So you can still see the stream 1 produce values every second, and stream 2 is now producing values every second. But stream 2 waited until the first stream was done with its work, okay? As I mentioned, concatenation is great for making API calls because if the first API call doesn't need any dependencies from before, it can do its work, produce some value, and then that value can then be provided for the second API. However, usually in those cases, a lot of Rx developers prefer to use a switch map or flat map latest, because if the first API is actually producing some values and that value needs to be provided as a second API, that's usually done with switch map. And the reason is that concatenation, as you can see in here, there's no way to really communicate the results of, actually, let's see if I can get rid of this. There is no way that stream 1 can actually produce some values that get sent to stream 2. So I know I said it earlier in this chapter that in this example that it is good for API calls when you want to concatenate and like if you're doing a transaction. However, that's done usually with switch map, because if values need to be passed from one API to the other, that's the job of switch map. Concat is good if you're in a transaction. So if you're, for instance, just making fire and forget API calls to say, here's an API. Once that's done, I want to do another API and a third API, etc., etc. So it's a transaction and things aren't really dependent on each other, but all of the APIs need to succeed for the result to be marked as a success as well. So let's go ahead now and commit this code. So let's go to terminal and say git add all, like this, and then we're going to say git status, and then we're going to say git commit step 4, and then we're going to tag it as step 4 as well. Yes. Okay, so git log, we have 1, 2, 3, 4, and then if you say git tag, we have 1, 2, 3, 4 as well. Great stuff. So we also saw how concat works, so we can move on to the next example. Now that we've committed and tagged this code, let's go ahead and move on to talking about merge, which is another very, very, very useful operator in RxDart and Rx generally. Let me bring up the marble for merge. Let's have a look here. I believe we've talked about merge briefly before, but let's talk about it again because it's just such an important Rx operator that I think every Rx developer needs to know about it. So merge works exactly like in Git. So if you have two branches with lots of commits, and then you merge these two branches, then the commits will be inserted into the same timeline as each other to produce one branch, for instance, at the end. Or if you're merging branch 1 into 2, then 2 will get all the commits chronologically from branch 1 in that order, as long as there's no conflict between them. But there's no conflict between items in Rx, really, so you don't have to worry about Git conflicts. So let's say here we have the first stream producing values of 20, 40, 60, 80, and 100. And then we have a second stream, which is only producing values of 1 and 1. And as you can see, when you're doing merge, all the commits or all the marbles or all the values from all the streams that you're merging with each other will be produced in the result. So here we have the value of 20. As soon as that stream is producing the value of 20, the resulting stream, the result of merge, is getting that value. If the second stream then produced the value of 1 right here, then that 1 will be produced. And if you bring it right here, you can see both are being produced. Not at the exact same time, but they will almost be at the same time, okay? So this is really simple. You can see merge is literally just merging basically 2 or more streams. So what we're going to do now is to do an example of merge as well. And what you need to know about merge and combine latest is that they kind of sound like they're doing the same thing, but they're doing two completely different things. Combine latest gives you a map function, gives you the last value of all the streams that you're combining, and it asks you to map those values to a new value. Merge simply gets the any value produced by any of the streams, and it will just give you that value. So the result of merging two streams of integer is actually a stream of integer or int. The result of merging 10 streams, excuse me, 10 streams of string is a stream of string. However, when you do combine latest, then you have a mapping function. So that's one of the biggest differences between merge and combine latest, in that combine latest has a mapping function. So it gives you the latest values of all the streams that you're combining, and it will ask you to produce a new value. And of course, the primary difference between them is that merge doesn't care about the ordering of all the values being produced. As soon as any value is produced on any of the streams, it will hand it to you. Combine latest always gives you only the latest value of all the streams. And if that's kind of difficult to understand, I need you to pause this video and think about it yourself. Think about the meaning of combine latest and the simple meaning of merge. Combine latest is a lot more complicated operator than merge, okay? So let's go ahead in here to our first stream and remove this take 3, as I mentioned at the bottom of the screen. We don't need that anymore. And then what we need to do in here, instead of saying concat with, we're going to say merge with, okay? I'm going to save this, go to the debug console, and I'm going to hot restart the application. You can see in here, as soon as any of these streams produces a value, then that value will be reflected on the resulting stream. You can go ahead in here and actually have a look at the second stream and change it to produce values every 3 seconds and hot restart the application. You can see stream 1's producing its values, and as soon as stream 2 produces its first value, that's also produced, that's also provided to the resulting stream, which is this guy, which is the result. So I think merge really is really useful, at least in my opinion, for immediate response to UI events. So if you have, for instance, a list view of checkboxes, as you can see at the bottom of the screen. So if you want to, for instance, merge the result of these checkboxes and then know that if all of them are true or if all of them are false, for instance, you can do that with merge easily. It's quite difficult to explain sometimes where you need merge and where you need combine latest. In my opinion, combine latest is usually useful when you really need all your streams to produce at least one value, and you always need the latest value of those streams. Merge, it gives you the last value produced by any of the streams that was merged into the combination. Since this is an abstract concept, it's kind of difficult to explain it. I think it will be a lot better explained when we, at the end of this chapter, start implementing real application, a complete application with Firebase. And in there, we're going to use merge. So you'll see soon where merge is actually useful. Okay, so don't think about it too much. Just know that merge, any item produced by any of the streams provided to the merge will then be reflected in the resulting stream. Okay. Let's commit and tag this as well. So we are on git log, git step 4. Let's say git add all, and let's say git commit step 5. And then we're going to tag it as step 5 as well. Okay. So if you do a git login here, we have 1, 2, 3, 4, 5. And have a look at our tags as well. We have 1, 2, 3, 4, 5. Good stuff. So let's now talk about zip, and that's also another very important Rx operator. And we're going to build on top of the same example that we've written in here, but instead of merge with, we're going to do an RxZip, and I'll explain that to you soon. Let's have a look at the marbles for zip. So zip is quite a visual operator. I usually tell people who are learning Rx about zip in my own way. I take both hands, like the fingers I have on my right hand and on my left hand, and then I simulate a zip. So if you have, for instance, a jack and you have a zipper, you drag the zipper up. And I don't know if you've ever looked at the mechanism behind a zipper. It actually works with having like a comb style things that are popping out of the right side, and then a comb on the left side. And then when you zip them, the mechanism goes like that. This will go here, and then this will go here. So they then lock into each other. And then the second item comes in here, and then the second item from another one. Then they lock into each other. So this is zipping. So this and this zip together, this and this zip together, this and this, and so on and so forth. So this is how a zip mechanism actually works. And it's the same thing in Rx as well. So if you look in here, what happens is, as a lot of people, when they look at zip, they be like, oh, but that's combine latest, because one was produced here, but there's no one on the result. So it waits until the first element is produced, or the latest element is produced by the second stream, and then the result will be 1A. So how is this different from combine latest? If I bring up the same another tab in here, and let's open combine latest, you can see immediately that the results are kind of different. So you see the first stream, the second stream in both zip, here's zip, and this is combine latest. You can see that the first and the second streams are exactly the same. They're identical. However, the result is very different. So zip is producing a lot less results than combine latest. And the reason behind it is that in combine latest, anytime, I mean, as soon as anytime the latest value of all the observables or streams has been produced, a new result will be produced. So let's talk again about combine latest. I just want to make sure that we understand the distinction between it. So here, the value of 1 is produced on the first stream, but there is no latest value on the second stream. Second stream produces its latest value, which is A, at which point combine latest will say, oh, now I have a latest value for the first stream and the second stream. What do you want to do with them? It calls our mapping function in here, which is like X and Y, which is the first value of the first stream, first value of the second stream, and it says do something with it. And in here, we're just making a string out of them, as you can see, and then it becomes 1A. Once the first stream produces a second value, RxDart will say, oh, the latest value of the first stream is 2. Do I have a latest value for the second stream? Yes, I do. It is A. 2 and A combined, concatenated into a string will be 2A, which will be produced. Right after the production of this value of 2 on the first stream, the value of B will be produced on the second stream, at which point RxDart looks at the first stream and says, do I have the latest value for the first stream? Yes, it is 2. 2B will be 2B. That's how combine latest works. Every time any of the streams or any of the observables in the combination produces a value, it looks at all the other observables or streams and says, do they have a latest value? In which case, if they do, in which case it will be then combined using the mapper into the value you want to produce. Keep that in mind. That's how combine latest works. However, zip works with indexes, meaning that as soon as the first stream produces its first value, let's say at the index of 0, then it looks at the second stream. It says, has the second stream produced a value at that same index, at the index of 0? No, it hasn't. Then the second stream produces a value of A, which is at index 0. So if you look at it historically, at like a historic line of indexes of values produced, at this point, A is the first element produced by the second stream at index of 0. So at that point, it says, oh, second stream produced a value at index 0. First stream has already produced a value at the 0, at the index of 0. These two need to be combined together, zipped together. So the result will be 1A produced as soon as this A is produced. Then the first stream goes and says, okay, I have a new value of 2. If this was combine latest would say, oh, 2A is the result. I can see I went out of do not disturb. So let's go to do not disturb again. If this was combine latest, the result will be produced of the value 2A. However, this is not combine latest. This is zip. Zip works with indexes. So the second value produced here has the index of 1 if we go from 0-based indexes. 0, 1. Then it says, oh, the first stream has produced a value at the index of 1. Has the second stream produced a value at that same index? No, because at this point right here, the second stream has only produced a value at the index of 0. As soon as the second stream produces a value at the index of 1, then it looks at the first stream. It says, has the first stream produced a value at the index of 1? Yes. Then these two need to be zipped together. So remember, zip mechanism is very visual. They combine together at that index. If these two go here and then this goes here, the whole zip mechanism is broken. And this is something actually that happens sometimes when you're dragging up a zipper on your jacket or your jeans. If you drag it too hastily, you drag it too hard, or something is stuck, just a little bit of a sand or something is stuck between your zippers, it could actually break the whole mechanism, and then you might have to fix it, or you have to oil it a little bit, which is quite, it seldom happens, but it still can happen. So in the world of Rx, that would never happen because it's a computer program. It's nothing physical. But just know that it works exactly like a zipper. First, second, third, fourth. Okay, just like that. I would actually say zip, the difference between this zip operator in Rx and how it is in the real world is that in Rx, you can actually zip more than 2 elements or more than 2 streams. In real life, you don't have a zipper that has 3 sides. Zippers always have 2 sides, meaning 2 streams. But in the world of Rx, you can actually zip multiple streams, but the basics are still the same. If you have 3 streams, the zip will produce a value as soon as all 3 streams have produced their first index. As soon as that happens, then you will get the result of the zip at that index. Okay? I know it was a lengthy explanation, but I think it's just so important to understand the difference between zip and combined lattice, and also their difference with merge. Okay, so let's go in here and change this code that we've written in merge with, and we're going to say rx.zip2, and then we're going to say stream1, stream2, and then it says it has a mapping function in here. Okay, so let's go ahead in here and say we write zipped result. A is like this, $A. B is $B. Okay, and a semicolon and a comma in here to break the lines down as well. Good stuff. Now we have that. I'm gonna bring up the caption, and also let's go to the debug console if I can grab it and do a hot restart. You'll see now zip result A stream1 count 0, B stream2 count 0. All right, you can see stream1 then produces a value of 1, but stream2 maybe has not produced a value of 1, but as soon as stream2 produces the value of 1 as well, they're at the same index, so the zip will produce a result. What we could do is do a little bit of an experiment in here and change the stream2 to produce a value every 5 seconds, okay, and do a hot restart. Stream1 at the moment is producing values, but you don't see it, and that is simply because stream2 doesn't produce values. So stream1 produced a value at index of 0. Stream2 produced 5 seconds after that, the same index. So you can see the result of this zipping produces values as seldom as the slowest stream in the zip. So if in here we had said 10 seconds, we will not get any values for 10 seconds because stream1 is producing every second, but stream2 is just so slow. Its first value will come after 10 seconds. So boom, that's the result. It produces its value at that index, at which point zip will say, okay, I'm going to get the same index from stream1 and produce the resulting stream for you. 10 seconds later, stream2 produces the index of 1, at which point the index 1 of the stream1s merged, or is actually zipped into the combination. I hope you understand this. It could be a little bit difficult in the beginning, but I believe if you just pause the video and think about it yourself, you will get it eventually. Good stuff. That was a short one as well. So let's go ahead and terminal and say git status, git add all, and then let's say git commit step. Which step are we at? Step 6. And then let's say git tag as well, step 6. And if you look at our logs, then we have step 6, 5, 4, 3, blah, blah. And then git tag as well, 1, 2, 3, 4, 5, 6. Okay, that was really good. So let's go ahead in here and clean up the code that we have in our main Dart. So I'm going to go here and basically change our home page as a stateful widget. So let's go ahead and clean up the code in tested, then remove the invocation of tested from our home page. And then I'm going to convert this to a simple stateful widget. Okay. So what we need to do in here, we're going to develop a little bit more advanced application. I mean, not advanced. It's a little bit more code to it using behaviors object. So, and for that, we need to clean up the main Dart file. So let's just save this file, hard restart, so we have a clean slate to base our work on. So let's have a look at what we're actually creating in this example. We will have a simple application with a button, and every time this button is tapped, we are going to start off a stream. We're going to have a list that we're going to display some with a stream builder. And we're going to have a stream that ticks every few seconds. However, every time we press this button, we're going to restart this stream. So we're going to work with behavior subject. We're going to work with a periodic stream, and we're also going to work with stream builder. And the reason really for this example is that I want to show you how switch map really works in RxDart. For those of you who are more seasoned developers and you work with Rx, perhaps, excuse me, in other solutions such as RxSwift and RxJava, for instance, you'll know switch map as flat map. And actually, if you've worked, for instance, with RxSwift, you'd know switch map as flat map latest, meaning that perhaps I shouldn't actually talk about so much what it means, because then I would be assuming that you already know Rx. But let's not make that assumption and instead work on our application. So in the stateful widget, let's go ahead and create first a behavior subject in our state object. So let's say late final behavior subject of string, actually date time. Okay, and let's just say subject. All right. And then let's go ahead and define the resulting stream that we're going to display in our list view. And this is a stream of strings. Okay. Let's go inside init state and set up our subject. So init state in here. Okay. And let's get rid of these. Let's say subject is a behavior subject of string. And actually date time, sorry about that. So every time the button is tapped, we're going to write the current date and time to this subject. Okay. So how do we set up this stream? Let's go and talk about setting up the stream in here. So let's say stream of strings. What we need is to say subject dot switch map. So what does switch map actually do? Switch map is like flat map. It is kind of difficult to explain, but I'll do my best to do that. Think now, don't think synchronously, think asynchronously in terms of streams. What switch map does is that as soon as a stream produces a value, it takes that value and provides it to you. And it says, for this value, give me a new stream. And the result of switch map will be your new stream. As soon as the source stream, in this case, our subject, produces a new value, then we go into switch map again. And the previously generated stream will then be gone. So every time your source stream, in this case, the subject, produces a new value, the subscription to the previous one disappears. That's where the switch one comes from. The map part comes from, well, you get the value and you map it to another stream. Okay, there is a good marble for it as well. We can have a look in here. Let's have a look at switch map. Switch map. Switch, if I can spell it. Here. So you can see in here, we have the value of 1. It's at the moment switch mapping it like this. So this is the first one being produced. And in here, then we have 1, 2, 3 being produced after the execution of this. So you can see that the result will be A1, A2, A3. And then B is being produced. And for B, we're also going to 1, 2, 3. So it'll be B1, B2, and then there is no B3 simply because before this 3 could be produced with B, then C is coming on the first one, meaning that at that point, the subscription to B and the production value, the production of the value B3 will not have the time to be completely finished. So C comes in and then says C1, C2, C3. You can see in here. So, but if I move the C quite a lot over this point, B will have the time to actually produce B3 as well. So the easiest way I can explain switch map is it is an asynchronous mapping of one stream to another by producing new values in the switch map. However, as soon as a new value is produced in the source, the previous switch map will die. That's the easiest way to explain it. It requires a lot of practice. You may not understand it immediately, but hopefully after this example, you'll get it better. Okay? So let's go in here and say, here we have a stream of strings. Its result, the stream of strings is this subject's date time. So let's put in here and say date time. And in here, then we're going to produce a new stream. We're going to say stream periodic. Okay? And the duration is going to be constant duration seconds 1, okay? And after that, we get the count of the stream, and then we're going to say stream count is, produce a string. Stream count is $count, and date time is $date time, okay? So, like that, and a comma there. So, you can see now what happens is that we created stream of periodic that is producing strings, and that stream itself is being assigned to the result that we're returning from switch map. So this is a stream of date time. However, the result of this will be a stream of string because the inner stream is actually a stream of string. So the result will also be a stream of string. Let's go to the dispose function and get rid of the this behavior subject in here, okay? So let's say dispose, and in here, before calling super dispose, we're going to say subject.close, okay? So don't forget that. So let's go ahead and create the body of our scaffold in here. So the body first is going to be a column. So let's say body, and we're going to say column with children empty for now. Okay. The first child of this guy is going to be a text button, and it has an on pressed. And on this pressed, we're going to say subject add date time dot now. So every time you press the button, we're going to add a new date time to our subject. All right. And the child of this button is going to say const text start the stream, okay? Like this. So expect it to find comma, all right? So that's our text button. Let's just hot restart our application, see how it looks like. So this is the button itself. But the first child of this column is in fact going to be a stream builder. So let's go ahead in here and create a stream builder. So for a column, here we have children, and let's say stream builder, and this is going to consume a string. And its stream itself, stream is a stream of strings, and its builder takes in a context and a snapshot, right? Like this. In here, we're going to go ahead and say if we have data, so we say if snapshot has data, return a text. of that string. So let's say final string is snapshot.data. It's required data because then it's not optional. And then we put the string in here. Otherwise, if we don't have data, we're just going to return text waiting for the button to be pressed. Okay. And then we make this a const as well. Great stuff. So let's put this to test. I'm going to hot restart the application. You can see at the moment, it just says waiting for the button to be pressed. And then if I press the button, you'll see that the stream is counting, which is the inner stream in here. However, the date time doesn't change because the date time that was produced in this subject stays the same since it was only changed when the button was pressed. You can see the count, the inner count, the count of this inner stream at the moment is on 21, 22, 23. However, as soon as I press the button again, a new stream is produced in this inner switch map. And the date time has been updated. You can see 6:24:49. Press the button again, 6:24:59. And the inner stream starts from beginning. Every time I press the button, the subscription to the previous stream inside switch map is disposed of and a new one is created. Okay, so this is how switch map works. It disposes of the previous subscription and creates a new one. All right. This was the last example which I talk about only operators. And I'm kind of excited actually that this was the last example, because in the next example, I mean, it's the last example, it's the last small example of this chapter, but in the next example, we're going to create a fully fledged application in Flutter with RxDart as state management that talks with Firebase. So let's go ahead, as you can see at the bottom of the screen, and commit this code, git add all. Let's say git commit step 7, and tag this as well as step 7. Okay, so git log step 7 and git tag. We also have all our tags. If I resize this, you'll see it. Okay, fantastic. So what we need to also talk about a little bit is the difference between flat map and switch map. If you're familiar with other Rx solutions, such as RxSwift and RxJava, you may know an operator called flat map. What flat map does, I actually have a video about that in YouTube. Without talking too much about that, what flat map does is that it doesn't dispose of the subscription from the previous mapping. That still keeps going. But switch map and flat map latest, as it is called in some Rx implementations, as soon as a new value is produced in the source stream, in this case, our behavior subject, let's have a look here. As soon as this guy produces a new value, the previous time the subject produced this stream will be disposed and a new stream will be created inside switch map, as we saw in the results, okay? So as you've seen now, Rx is really just about a set of operators that work with data. So it's just you playing with data and data types. It's not more than that. But the main cumbersome aspect of Rx is thinking asynchronously. As soon as you can nail that part, as soon as you can start thinking asynchronously in terms of data that happen in pipes and are produced in pipes, and what you can do with that data using operators, then you can say you've already started your journey on mastering Rx. So I know that I mentioned we're going to go and start building a full-fledged application with Firebase, but I think I was kind of running ahead of myself because we have 3 more examples in which we're going to slowly build up our knowledge of Rx. And after these 3 examples, then we're going to jump into the Firebase application. In these examples, we're going to explore a little bit more how we create blocks like business logics with Rx. And I really think that this is like one of the absolute most important building blocks of Rx and state management in Flutter. So let's put some more stress on this to make sure that we nail that. And then we can move on to the last example of this chapter, which is building a full-fledged application together with RxDart and Firebase. So what we're going to do in here is to use filter chip and it is a widget, which is, I've actually done a tip and trick about this as well in my Flutter tips and tricks GitHub repository. Maybe you've already worked with filter chip, but it's simply just a group of buttons ordered inside a column or a row that allows you to allows the user to, for instance, pick a specific item out of or an item type out of many other item types. So what we're going to do is to create a block here, and we're going to create a list of things, a static list of things. And these things can actually, for instance, be, if I have a look at the example that I prepared, they can be persons or animals. And then the user is going to be able to pick either to display all persons and animals, or only persons or only animals. And we're going to use filter chip widget for this example. In this example, we're also going to create a simple block for our filter chips, and even our blocks are also going to be able to produce the list of items that our application has to display. So it's a nice mix and match of different things we've learned so far. So let's go ahead and create that. So as I mentioned, it displays a list of things. So let's go ahead and create first the enumeration that dictates the type of things that we're going to display to the user. So what I'm going to do in here is to create a scaffold application. So just remove everything in main Dart, and I'm going to hot restart the application. So our app looks just like this at the moment. Okay. So let's go and create the list of things right after where we create the home page in here. Sorry, not the list of things, but the type of things. So let's go ahead and say type of thing. And we're going to say it's either an animal or a person. Okay, so it's a simple enumeration. Then we're going to create an immutable class that represents things such as person or an animal. So let's say immutable class thing. And what I'm going to do is I'm going to copy and paste the code for this class because it is not that difficult to write it. As you can see, it has a type, which is a type of thing, and it also has a name with the required parameters in here. Okay, so that's that. Now we're going to create a simple block in here, which I'm going to remove the debug console at the bottom of the screen so we get some more real estate in here. So this is going to be our business logic. So let's say immutable class block. Okay. And we're going to have 3 properties in this class. The first one is the sync. Remember, it's the write-only pipe that the UI can control. So the UI can tell us what the current filter is. So it's either there's no filters, or the filter is on person, or the filter is on animal. So let's go ahead and define this thing. And again, I'm going to copy paste some code in here because we already know how to create these things, like final sync type of thing. As you can see, it's optional, meaning that it can be null. And it's called set type of thing. Okay, so the UI uses that. Now, the UI also needs to know the currently selected type of thing, because remember, when we're using filter chips, we also need to tell the UI which filter chip is currently selected, meaning that it's going to have like a tick box or something next to it. So for the UI, to avoid the UI having to contain that state within itself, knowing which filter chip is selected currently, our block can actually expose that as a stream. Okay, so let's go ahead and expose that as a property in here, as you can see. Okay, fine with these errors occurring. And also, we're going to define a list or basically an iterable of things in here. So I'm going to paste that in here, as you can see. So these are the only 3 things that this class is going to expose. So this is write only. Okay, this is read only. And this is read only. So please keep this in mind. It's very important. Streams are read only. Syncs are write only. Stream controllers are read and write. Okay. And usually when you need, for instance, you can see in here, we have a set of things, set type of thing, which is a sync, which is write only. And then we also have the current type of thing. Since this is write only and read only, and it exposes the same data type, you can see a type of thing optional. Usually things like this under the hood in Rx are controlled with a behavior subject, because a behavior subject is read-write. And since the data type is the same, the behavior subject can both expose the sink and the stream. So keep that in mind as well, okay? So let's go ahead and create the const constructor for this class. So if you go ahead in here and ask Visual Studio Code to create the const constructor for this, my way of doing this is I go ahead and put a comma at the end, get the Dart formatter to format this, put my curly brackets like this. Then I get Option and Command in Visual Studio Code, and Option is Alt and Command is Control. So if you're in Windows or Linux machine, you want to say Alt and Control. Then I hold Alt and Control or Option and Command in Mac, and then I just go down like this so that I can select all these lines at the same time. Okay, just one more time. We go here, and we can then type required in here for all those parameters. Okay, let's turn this constructor to const constructor dot underscore, meaning that this is a private constant constructor. Okay. And the reason that we do this, I explained this, I believe, once before, but the reason that we create these constant private constructors is that the UI should not care about creating the block using these parameters, because it's not the UI that is actually going to provide these things to the block. It is the block's factory constructor that we're soon going to create, which is going to pass these parameters to the private constructor. So just remember, it's not the job of the consumer of the block to create these. That is the reason we create a private const constructor, and then we will create a factory for our block that passes these, creates these values, and then passes those values to the constructor in here, okay? So let's go ahead in here and start creating the factory constructor for our block. So let's say in here, factory, and our block is just called block, okay? And in here, what we need inside the factory is to first grab a list of all the things that we have to display, okay? So the block itself is not going to create the list of things. You see, it has an iterable of thing, but it needs to get an iterable of thing, which is the entire list of things it can filter, okay? So let's say that we get a required iterable of thing, and we call it things as a parameter, okay? And then in here, we need to basically do all the work necessary to create an instance of our block, all right? So let's create a subject for this type of thing, as you can see in here, okay? So because subject is read and write, and here we have write only and read only, so it makes perfect sense that the backing of both these variables is a behavior subject. So let's say type of thing subject, and this is a behavior subject of type of thing, optional, all right? And it has no value to begin with. Now, what we'll do is, what we need really is just to grab somehow, given a type of thing, like when the UI gives us a type of thing, which is then written to this variable, given that, we need to produce this, we need to produce this things list, okay? And so when we get the filter, we already have the iterable of all the things. So we have the filter and the iterable of things. We just have to produce a new iterable of thing based on that filter, okay? So let's go ahead in here and say final filtered things is, we get the type of subject, okay? And we are going to debounce it a little bit, because if the user is on those filter chips and then constantly clicking on these items on the person and animal UI elements, we don't want to keep producing elements. We just want the user to calm down a little bit. So what we're going to do is to debounce that, okay? So let's go and import Rx in here. So I'm going to remove this object, and I'm going to say import RxDart, the entire package. And let's go in here and then say debounce time and const duration, milliseconds perhaps, 300 milliseconds should be fine. And then we're going to map. So we say, given the type of thing, okay, then we're going to create an iterable, Okay, so we're going to say then we're going to create an iterable, a thing in here in this map. So it kind of helps to put these types in here because your map is going to produce this iterable of thing. So you might as well just excuse me. So you might as well just place it there so that if you, for instance, in here you say return 1, then you get an error saying that, oh, integer is not compatible with iterable of thing. However, if this thing wasn't here, these documentations sometimes drive me nuts. If that wasn't there, Dart would just say, okay, this is fine. But the result of this will be a stream of integer you can see in here. So sometimes it helps to put the actual expected return value right before the implementation of the actual generic function, like we're doing in here. So type of thing is optional. Remember, so it can be null. So we say if type of thing is not null, then we're going to say return all the things. Remember, things is passed to the factory constructor in here. So we're going to say things where the given thing in here, type, is type of thing. Okay. Great stuff. So that's our mapping for when the type of thing is not null. However, if the type of thing, if the current filter is null, then we're going to say return all the things. Okay. So this is all great in here. So you can see filter things is actually a stream of iterable of thing, exactly what we have to plug in here in the things property. But we're missing one thing. Behavior subject by default has no value. So we're not actually providing a value in here. So if we say null in here, you can see it's a too many positional arguments because there's no value. So what we need to do in here is somehow make sure that this stream of iterable of thing always starts with the current value of things, because the first time the user ends up in the UI of our application, the user hasn't really chosen any filter yet. So what we need to do is just ensure that this entire stream always starts with the entire list of things. Okay, how do we do that? Well, there's an operator called start with. Okay, so in here we can say this stream, this entire stream always starts with the current value of things, all the things, because there's no filter to start with. Okay, great stuff. So given this and this guy, since this is a read and write, so this is going to fulfill the contract for set type of thing and current type of thing, and the filtered things is going to fulfill the contract for things. Then in our factory constructor, we can call the constant private constructor and return an instance of our block. So let's say return the block using its private constructor. And let's break these parameters down a little bit. And in here, put a comma there as well. So set type of thing is going to use type of thing subject, but it's sync, okay? Then current type of thing is actually going to be type of thing subject stream. Oops. Okay, which is read only. And things is going to be this stream, filter things. Okay, so let's just return that. As you can see, Visual Studio Code is happy as well, so the code compiles without a problem. Now that we've exposed this sync in here, if you remember from before, every time you have a sync, it means usually that there is some sort of a stream controller behind that sync. So you need to close that sync in some sort of a dispose function. All right. So as you can see at the bottom of the screen, let me just bring it up. We need to dispose of that sync. So let's go in here right after the fact that the constant constructor, create a void dispose function in here. Okay. And then set type of thing, which is our sync. And then we're going to just close that. All right. So that's very important. Then we're going to go ahead, now that the block is complete, we're going to go ahead and define a list of things that our UI can display. I'm going to copy paste that. So you can pause the video right here if you want to and have a look at this constant list of things. And you could also say this is an iterable of thing if you want to. But if you just create it like this, it's going to create a list for you. Okay, and that's fine because a list is also an iterable, so not a problem. So we have foo, bar, baz, and buns, fluffers, and then woofs. And these guys, the last three are animals, and the first three are persons. Okay, So nothing special in here. Then we're going to go ahead and create our homepage with and make it a stateful widget, because our homepage is going to contain a block, which is our block, an instance of this block class that we have created or written. And then we have to make sure that we dispose of that block when our homepage is recreated. And then if you're familiar with Flutter hooks, then you could create this without having to use a stateful widget. You could just create a hook widget and then have use Memoized. But we're not going to do that. That's going to add another layer of complexity. But if you're curious about Flutter hooks and how it could make your code a little bit easier to write and read as well and understand, I have a very long video actually about that, Flutter hooks, in the same playlist of Flutter State Management Course, so on YouTube. So please go ahead and watch that if you're curious about Flutter hooks. Let's go ahead now and turn our homepage into a stateful widget. So convert it to stateful widget. We need a block in our homepage. So let's go ahead and define that inside the state. So late final block. And we're just going to call a block like this, either like that or as I show at the bottom of the screen, just like this. Okay. So we could just make it underscore, but this is also fine for me at least, but it's just a matter of renaming it if you want to. Okay. In init state, then we need to go and create an instance of our block. Okay, so init state, and in here, we're going to go ahead and say our block is an instance of our block class with a list of things set as things, as you can see in here. Okay, remember this was a constant iterable. After implementing init state, we need to go ahead and implement dispose. So on dispose, we have to dispose of our block as well. Okay, so that's very simple. Then we need to go ahead and add the filter chips to a column. So let's go ahead and change the title of our widget first and say filter chip with RxDart. Okay, and we have the app bar right there. And let's go for the body and say for the body, we have a column with the children at the moment empty. Okay. So now that we have that, we need to go ahead and add our filter chips to the column. So in here, what we need really is, because remember, filter chips, they need to know which filter chip is actually currently selected. And for that, we have this stream. So let's go ahead in here and have a look at this stream that tells us which filter chip or which type of thing should be selected. So since we have a stream to build our UI with, we need this builder. So let's go ahead in here and say, first of all, we are going to create a stream builder in here. Okay, so the first child of this column is going to be a stream builder of a type of thing, okay, as optional. And we're going to say the stream itself comes from our block current type of thing, okay? And then we have a little builder function in here, which is context and snapshot. Great stuff. Now, we need to get the currently selected type of thing, because remember, we're going to have two chips. One is for animal, the other one is for person. By default, none of them is selected. However, if you click or tap on any one of these chips, that chip should be selected and the other one should be deselected. All right. So let's go ahead in here and say that final selected type of thing is our snapshot.data. This gives us the currently selected type of thing. Then we're going to create a wrap. So in here is children is going to be type of thing, because we want to get both the values, animal and person. And then we're going to map these. So in here, let's say in here, we say type of thing. And our job in here really is to create a list of widgets that need to be returned inside the wrap. So if I said text in here, that would also work, but we're not going to use text inside the wrap. We're actually going to use our filter chip, okay? So let's say we return a filter chip, okay? As you can see, we need actually 4 properties in here. So let me add those 4 properties. So we say selected color first. So when the user selected a filter chip, what color does it have? So we're going to say colors, accents, blue accent, sorry, 100. And then unselected. And in here we say selected. And you can see selected is actually a Boolean, so it tells us whether that filter chip is currently selected or not. So we say final type is, if it's selected, then is it the current type of thing, which is passed as the parameter inside the mapping here, you see? Okay, it goes through the values of the type of thing. So first it gives us the animal, and next it gives us person. It passes that value in here. If the current chip for that type of thing is selected, then we're going to pass type of thing as the type. Otherwise, we're going to say null, okay? Because remember, what happens is that a filter chip can be unselected as well. So if you tap on a filter chip that's not selected, then it's going to be selected. And if you tap on it while it's selected, then it's going to be unselected. That is why we have this operator in here that tells us, that says, okay, if it's selected, then pick that type of thing. If not, then choose null. So it unselects that, okay? Then we go to set type of thing, and then we add this type, all right? So this is a sync, remember, you're writing only to it, okay? Good stuff. Now that unselected is done, for the label of that filter chip, we're just gonna say we have a text, and then we're gonna say type of thing, put its name there. And then for the selected, whether or not you're actually selected, we have this beautiful selected type of thing, which comes from the block, which then comes from the current type of thing. So as soon as you write to this guy, right, then this stream produces a new value, which then comes into the builder again, and selected type of thing will be actually the type that you selected in here. So it's beautiful, to be honest with you. So for the selected, we're going to say selected as long this filter chip is selected as long as the selected type of thing is actually equal to the type of thing that we're enumerating right now, like that. Okay, so that was our builder really for the filter chip. So let me hot restart in here. Let's go into our application and see how it looks like. You can see now we have our filter chips in here. So if I select one and I can unselect it, you see select, unselect, person, like that. And if I select animal, animal gets selected, clicking on person. So let's say this is the beginning of the UI. So the application got started from here. Then the stream builder gets, it goes in here and goes to the stream. It says current type of thing. Okay. Remember, current type of thing is from our block in here. Let's see if we can find it here. Current type of thing, which is the read-only stream, which comes from the type of thing subject. Type of thing subject by default has no values. It means it's null. And that is the reason that this guy is actually null to begin with, but it doesn't really have a default value. And that's why we come here. You see, this data by default is going to be null. So that's why the selected type of thing, you can see in here, it's not equal to any of these type of things that we're enumerating. Okay. And that's why none of them is selected. However, if I tap on animal, for instance, boom, then the unselected of animal type of thing got called. Then we set the type. So we looked at selected, selected was true. Then we're getting the type of thing, the current type of thing that we're enumerating. We're passing that to our block, then goes up here to our block. Okay. It goes in the sync, right? Set type of thing. And remember, set type of thing is just the sync of our subject. So basically the animal value is going in this behavior subject. Then the type of thing subject is producing a new value, which is animal. It's debounced by 300 milliseconds. It is passing here and is being mapped to an IEEE thing. So it comes here, it says, oh yeah, it's now animal, is not null. Then it's returning the entire list, but it's filtering it where that thing's type is the current type of thing. I know it's a lot of words, but it's really simple. It's just we're playing with data in here, okay? So then if I click on or tap on this current animal, which is selected, boom, this unselected got called. The selected parameter was passed to us as false. We came here, was like, oh, are we selected? No, null should be chosen. okay? And this type you can see is a type of thing optional. And then we're passing null to this write only sync. Null is coming here in our block and is being written to type of thing subject. And null is coming here, being debounced, is coming here, and then it is null. Then we're returning all the things, okay? So it's very simple. It's just passing data around, okay? It's just passing data in streams of things, basically, okay? So that is for our filter chips. They're working as expected. However, we need to display a list based on the data that our block is also providing, okay? So right after this stream builder, which is the first child of the column, which is inside the body of our scaffold, let's go ahead and create an expanded in here, okay? And its child is going to be a stream builder, okay, of an iterable thing, because this is where we're actually going to display the data for, basically display the list for the list of things, okay? So in here, we need two parameters. So the stream is actually our block, the stream of things, as you can see in here, okay? And then we have a builder, and then we're going to put the context and the snapshot, all right? So I wrote build, it should be builder, all right? So let's get the actual things to display in here. So let's say final things is snapshot data or empty iterable, okay? Put some commas to get the formatting right. And then we're going to display a list view. The displaying of the list view from a list of things is quite boring, so I'm just going to copy paste that code in here. You can see it's a list view builder, and we have item count from things length, and then we're going to grab everything from that list and then display a list tile. So let's go ahead with this code and test this out. So I'm going to go in here and bring up the simulator, and as you can see, we have our simulator here, and by default we're displaying everything because we have no filter. Remember, in our block up here we said if the type of thing is not null, then do the filtering. Otherwise, return all the things that are passed to the constructor or the factory constructor of our block. So that's why we're seeing everything in here. However, as soon as you say animals, then we're only seeing buns, fluffers, and woofs. If you deselect animal, then you can see everything being displayed. Person does the same thing, only displays persons. Deselecting person also displays everything. And you may notice a little bit of a lag. You see, if I'm really fast and switching between these, it's not updating the UI. And that is simply because we have this debounce time. So if I comment that debounce time and restart the application, you can see it immediately reacts, okay? So it kind of depends on what you're after. If what you're after is just super fast response to the user selecting and deselecting things, then yeah, you may want to go with removing the debounce time. However, I still believe that putting the debounce time in there just creates a little bit more of a calm experience for the user. So if the user's like jumping around and like clicking like this, then the UI isn't jumping like crazy, okay? But it's a complete, like it is completely up to you. It's up to your taste, basically. Okay, so as you've seen now, you get really far in creating a really stable and good state management solution in your application if you just use streams, stream builders, things that are built into Dart plus Rx, because Rx gives you a lot of operators to put on top of streams, and it gives you these behavior subjects, which are stream controllers. So it's very easy to build a fully functional application simply using RxDart as the state management solution of your application. At least that's what I think. Okay, now that we're done with this, let's go ahead and commit the code. And I'm going to bring up the terminal in here. So let's say git add all, and then we're going to say git commit step 8, and say git status, and then git tag as well as step 8 in here. So git log, have 7 and 8 and all the other commits, and then git tag, 1, 2, 3, 4, 5, 6, 7, and 8. That's perfect. Okay, so we're done with this example, and we can move on to the next one. With this example done, let's go ahead and have a look at another example. In this example, we're going to have two text fields using which the user can enter their first name and last name. We're going to have a simple block that uses the first name and last name that's entered by the user to construct a full name and display that to the user. So we're going to work with some other operators as well in this block, so you get your hands dirty with those as well. So let's have a look at this application in real life and see how it actually looks like. Okay, now the application is ready. I'll bring it up here. You can see that we have a combined latest with RxDart. So we're going to get used to using combined latest. So in here, it says both first and last name must be provided. And if I in here say food and then bar, it says foo bar. But if I remove bar, then it will display the same message as before. And if I provide the last name but remove the first name, it will provide the exact same message again. So in here, we need to, I'll also bring the caption at the bottom of the screen. In here, we need to provide both first name and last name for the full name to be displayed at the bottom of the screen. So in this example, we'll actually use combined latest. So because I believe we've used maps and switch maps, but combined latest is also such an important part of Rx that we need to get more into. Okay. So let's go ahead and clean up the code that we have in main Dart. So I'm going to remove the debug console and replace this entire thing with a scaffold application. Okay, so simple. And let's go ahead to this app. And if I hot restart the application, you see that we just have a simple home page in here. Okay, let's go ahead and create our block. So our block has, excuse me, it has a few simple properties, as you'll soon see. And so let's say an immutable class block in here, okay? And we need three final variables in here. So I'll copy and paste them right here so you'll see. And you can see here we have a set first name, set last name. So these are write only, so write only. The UI can write the first name and last name in here, okay? And then the full name is read only, so read only, okay? The job of our block is to provide sinks for the UI to write the first name and last name into, and also finally be able to combine those two values that are provided in here into a full name. Remember, all write-only sinks usually are backed by behavior subjects, okay? Excuse me. So two behavior subjects are going to control these, and then using the behavior subjects as streamed, we're going to be able to construct the final stream, as you'll soon see. Go ahead and create the private constructor for your block, okay? So let's go ahead and say create constructor, comma. Let's remove that, comma. And curly brackets, as we did in the other examples as well in here, okay? And then we make all of these required parameters. And let's make this guy a constant private constructor, as you can see here. Let's go ahead then after this and create a factory constructor for our block. So let's say, as you can see, this block doesn't actually have any input parameters. So the factory constructor is empty. So say factory block. So like this. And our job here is to call the, or actually do the logic behind all of these, the sinks and the streams, and then call the factory constructor and pass those values in. So we have the first name and last name behavior subjects. By default, they're empty or they contain null. So I'm going to paste them right here. What we'll do then is to use this first name subject and last name subject. And I can see we also have to import Rx. So let's go ahead and see if Visual Studio Code can help us with that. Import the entire RxDart package in here. Excuse me. And we're going to say final. This is the stream of string. And then we're going to say full name is equal to Rx combine latest. So we're going to combine the latest values of both these behavior subjects. And here we have stream 1 and stream 2. And the first stream is actually our first name subject. So let's put it here, first name subject. I'm going to actually bring this into separate lines like this. So we have the two streams in here. And then we have the mapper function right here. So what we need to ensure is that, remember, behavior subject by default, it has no values in it unless you provide a value for it. However, if you remember, combined lattice always needs that all the strings in combined lattice produce at least one value. Otherwise, the mapper function will not be called. So let's go ahead in here and say the first name always starts with null. Okay. And then we're going to take the first name and put it in here and change it to last name as well. They both start with null. Okay. So in here, then we say first name and last name. Okay. And inside this function, then we're going to have to return a string as well. Okay. So our job is to get the first name, which is a string optional, and then an optional last name as well. Okay. So we say if first name is not null and first name is not empty. Okay. And then last name is not null and last name is not empty. Then we can construct a full name. So let's say return the dollar first name and last name. Otherwise, we're going to say return both first and last name must be provided. So this return statement right here. Okay. So we have the full name right now. So it's a stream of string. And we also have our behavior subjects in here, which can be the backing of the syncs in here. Okay, so let's go ahead and call the private constructor of our block. So we say return an instance of our block with the set first name sync being the first name subject sync. Okay, like this. And let's put a comma in here and get the formatting right first. And then we're going to say last name subject sync. So this is the write-only copy of our behavior subject. And then the full name is already there. So we have the full name string in here as well. Okay, let's go ahead and implement the dispose function for our block. We have two syncs, so every sync needs to be disposed of. So let's go ahead and say void dispose in here. Okay, we could place the dispose after the private constructor. So first we have the construction and then we have the destruction kind of. So we say set first name needs to be closed. Okay, you can see here, and then set last name also needs to be closed. So that's the dispose function. Okay, so what we're going to do in here is to create we're going to create a consumer for our block, and our block at the moment, its consumption point is using the string. So you've probably seen that we have stream builders, and stream builders have an async snapshot, and then we usually go inside the async snapshot and say, okay, if, for instance, the async snapshot state is this, then do that, return this and that based on the snapshot state. However, we could also spice things up by going ahead and creating a new widget, which I sometimes like to use in my applications. And as you can see at the bottom of the screen, is going to be called a snapshot builder. So we're going to call this guy an async snapshot builder. Okay, and its main purpose is to allow us to cherry pick what needs to be displayed based on the state of an async snapshot. However, you don't have to create default parameters or you don't have to create widgets per snapshot state, because our async snapshot builder is going to have default widgets for various states of a snapshot. It is kind of difficult to explain, but think of a snapshot builder, think of a stream builder and its async snapshot. And async snapshot has connection state, and then it has like waiting, active, etc., etc. And usually you go inside those states and create your like text widgets or circular loading indicators, etc. But using this widget, what we can do is, which we're going to call async snapshot builder, you can say, I'm only going to provide a widget to be displayed once my stream is active, and the rest need to be provided by default by this widget itself. Okay, so that's where this is going to be useful. So let's go ahead and define our async snapshot builder. Okay, so, and again, this is not necessary. You could just get away using stream builder. But since we're going into a little bit more advanced topics talking about Rx, we could spice things up so it's not always as boring. Okay, so let's go ahead and say async snapshot builder. This guy has a generic parameter, which is the stream that is going to work with. And then we're going to say this guy extends stateless widget. So we could, to be honest with you, actually create a stateless widget like this, and we'd call it async snapshot builder. Okay, and then it has a T parameter, as you can see in here. So what we need in here is to basically define first what we could do, define first the stream that we work with. So we say final stream T, and this is going to be our stream, okay? Also, we're going to have 4 different parameters for the various builders of our async snapshot builder. So if we go in here and say final async snapshot, and we say blah, let's go into async snapshot just to get a refresher on what the async snapshot actually does. It has this parameter called connection state, and connection state is of type connection state. You can see it is none, waiting, active, and done. So there are 4 different states that an async snapshot can be in. And what we want in here is to provide callbacks that the async snapshot builder is actually going to call to say, hey, the state is active. What do you want me to display? Okay. So let's go ahead and actually create these callbacks first. So we say type def async snapshot builder callback. It has this T parameter. And then we're going to say the callback has to always return a widget. It is a function. Okay. And then it gets a build context in here. So we say context. And then we optionally provide the value at that the data of the async snapshot actually provides us. So we say value in here, okay, comma, and then a semicolon. So this is the callback. So what we're going to do is go ahead and for every one of these states, none, waiting, active, and done, create these callbacks parameters in here. So let's say final async snapshot builder of T. Sorry, yeah. Actually, what do we call it? Async snapshot builder callback of T. And let's go ahead and say on none, excuse me, on waiting, on active, and we have on done. Excuse me. Okay, let's go and add all those parameters to our constructor. Okay, so here is the caption at the bottom of the screen as well. So let's say add the final fields in here. They're all required. Okay, like that. Like this, good. And let's have a look at the parameters in here. I think the stream needs to be required, but all the other parameters we could just skip over. Okay, like this. And for that, we need to ensure that all of these are optional. So the reason behind this is that, as I mentioned at the beginning of the implementation of this async snapshot builder, is that the whole purpose of this is to ensure that these callbacks are optional so that you can cherry pick which state of the stream you want to produce values for. So if you want to use the async snapshot builder to only produce widgets for the active state of your stream, you could do that with this widget. Okay. So we have that at the moment now. So that's really good. And that's for the constructor of our new widget. With the constructor in place, it is time to go ahead and implement the build function. And the build function of our async snapshot builder is going to use a stream builder. So it's very easy. So let's go ahead in here and just return a stream builder. So we say return a stream builder of type T. And the stream itself is going to be the stream, which we already have inside our async snapshot builder, which is the string that we have to be passed as a required parameter. And then we have the builder. Okay. And this is where the magic happens. So we say snapshot like this. So then depending on the cases, so let's go ahead and say switch. So we say switch snapshot connection state. So it is our job to actually provide the default widgets for every one of these. Okay. So add the missing cases. In the case of none, so that's where we're waiting basically for data to start to be produced from the stream. So we say final callback. We create a callback. Remember, every one of these callbacks is optional. So if this guy is null, then we cannot actually call it. So let's go ahead and say a callback is either the given callback, or if it is null, we create another callback. Okay, so let's say callback is done like this, or then we create an inline callback with empty parameters, and we say we return a size box. Okay, so we just say, okay, if there's nothing to display, we just create a size box in here. Okay, and then we say return callback, and we call it as a function. So we say the context and snapshot.date like this. All right, so, and we remove the break. So this may look like black magic, but really all it's doing is either take this function or take this function. If this is null, if the provided on none is null, then we create an inline function that has just two parameters that we ignore, and then all it does, it just returns a size box. Okay, so it's very simple. So for waiting, we're going to do something similar. We're going to say final callback is on waiting, either we take that or a new parameter in here, excuse me, and we just return a const circular progress indicator. Okay, and then we call the callback just like this. Boom. All right. In the state of active, we can just say, okay, we either let's copy the connection state none and place it inside active, and then we say on active. Okay, and then we call the callback exactly like before. And in the state of done as well, we'll do the same thing. So copy that code and paste it in here. We say on done. Okay. And again, remember, I've decided that the default implementation for these states should return a size box, but maybe in the state of none, you actually want to return a text field, or sorry, maybe you want to return text saying that waiting for data, or no connection has been created. So it is completely up to you what your default widgets have to be for these different connection states. Okay, and then we put a semicolon there to get the formatting right as well. Okay. So perfect. Now we have this beautiful widget that we just created. It's very reusable, so you may want to put it inside a package or something if you want to reuse it in different projects, okay? Great stuff. Let's go ahead and convert our homepage to a stateful widget, okay? Because our homepage is going to have our block, and our block needs to be created and disposed of, and that's why we are going to create a homepage that is stateful. So convert it to a stateful widget. Perfect. And yes, that's really fine. That's all we have to do for creating our stateful widget. Let's go ahead and create our block. So in the state, let's go ahead and say late final block of type block here. And you may want to create like an underscore block. I'm just going to leave it like this for now. It's not that important. Let's go ahead inside init state and say init state, and then say block is our block in here. Okay, it doesn't have any input parameters, remember? For dispose, we're going to go ahead and say that we call super dispose, but before that we dispose of our block, which is going to close both those sinks, remember? So if you go here, block dispose, let's see here, set first name and set last name are going to be closed in that case. Okay, good. Let's go ahead and program our excuse me, our build function in here. At the moment, we have an app bar, but we're going to change the title to, I think I jumped in another editor because I have another editor on an external display here. So let's say combine latest with RxDart. That's the title of our application. And for the body, let's create a column in here for children is empty at the moment. And then what we're going to do is to create a text field, actually two of them, one for the first name and the other one for the last name. So I'm going to create a text field in here. So let's say the first child is a text field, okay? And it has a decoration. So let me put the decoration in here, okay? As you can see in here. And then it has a parameter called onChanged. We're going to get our block set first name add. Okay, so this is going to set as soon as the text of the text field changes, that text is going to be sent to this sink. All right, so then I'm going to copy this text field and let's put it in here and say enter last name here. Okay, and then don't forget to set last name in here. All right, so these are two text fields. Let's go ahead and see how the UI looks like. It looks like this for now. Then let's go ahead and use our async snapshot builder. So let's say then we want the async snapshot builder in here, which we know is going to work on string because our block, remember, this block guy has a stream of string. So that's what we're going to work with. So let's go here, back here, and say the stream is our block full name. And then this guy has to have, while the stream is active, while it is actually producing values, we want to create a text to be displayed to the user. So let's say on active, remember this beautiful parameter in here. So we say the context and the value will be provided in here. Then we say we return a text that either displays the value or an empty string in here. Okay, so you see how beautiful how beautiful and easily you can use our async snapshot builder instead of having to use a stream builder. Okay, so let's hot restart the application. As you can see, by default, is providing both first and last name must be provided, and that's because inside our async snapshot builder, or somewhere actually, let's see where we have provided that. Both first here. So it's in our block, as you can see in here. Okay, so if I type something in here, let's put it to test. So if I say foo and then bar, you can see the value is being provided. If I remove foo, the same message is displayed. If I enter foo and remove the last name, then the correct value is also displayed at the bottom. You might want to place this entire thing inside, like if you go to our homepage, you may want to go to this column and wrap it with some padding. So if you put padding in here, I believe, let's see. And it looks like this. It looks a little bit better, but that's my opinion. So you may not want to have the padding in there, or you may want to have more padding. It's completely up to you. Okay, great stuff. We're done with that example as well. So let's go ahead and commit this code as we usually do at the end of every example. So git status, git add all, and git commit, and then we say step 9. Then we say git tag step 9 as well. So if you look at our tags, we have all 1 to 9, and then the log as well. We have 7, 6, 7, 8, 9, and all the other ones from before. Great stuff. So we're done really with this example as well. With that example out the way, let's go ahead and work on yet another example just before we jump into creating a full-fledged application with Firebase and RxDart. In this particular example, we're going to talk about concatenation. And that's also a very important operator in Rx. As I've mentioned before, Rx is really just a series of operators that work on streams and pipes. So for me, it always helps to think in terms of Git branches. So Git branches being your streams or pipes of data, and your commits being the values in those streams. So when you're merging branches, it's the same thing when you're doing an RxDart, for instance, when you're merging 2 streams or more. Or if you're concatenating, it's kind of like rebasing, and so on and so forth. So we're going to look at concatenation in this particular example. And I've touched upon concat before, but what concat essentially does is that it takes one stream, think now a branch with some commits on it. Once that stream is finished and it's done its job successfully, it concatenates and adds the second stream to the end of the first stream. So the second stream starts where the first stream ends, and so on and so forth. So you can concatenate as many streams of data as you want. Let's have a look now at the marbles for concat. So I'm going to bring up a Safari window here, and let's go ahead in RxMarbles, and let's see if we can find concat. It's right there. So as you can see in here, we have 2 streams, just like pretty much every other RxMarbles example. The first stream produces the values 1, 1, 1. They're color coded, so they hopefully can help even for those who are colorblind. Depending on what kind of color blindness you have, hopefully you can see at least the differences in the colors. And here we have 111 produced, and then the first stream ends here, which you can actually control by moving this to the right and to the left. You can see, even though stream 2 is producing its values right at the same time that the first stream is producing its values. However, stream 2 is being concatenated to the first stream, meaning that then the results will be produced so that stream 1 completely produces all its items and then completes. And then stream 2's items will be appended or concatenated to the values or the items produced by the first stream. So this is how concat works. So you can move these to the right and left as well, you can see. So the distance between the two elements produced by the second stream are going to be kept even after the concatenation. So if I move these two items close to each other, you can see that the result will actually be the same. And if you look, the distance between the start of the second stream to the production of the first value in the second stream is also kept, so that in the result, so that the last item produced by the first stream has that distance to the first item produced by the second stream. You can see one ends here. However, the distance from this first element in the second stream to the start of the second stream is kept intact, so that the last item produced, or the last element produced by the first stream, is that far away from the first item produced by the second stream. So you can go ahead. I mean, I'm saying these things because they make sense to me. However, I believe that it is very important that you go into RxMarbles and you play with these marbles and actually get a good understanding of what is happening. Have a look at the distances, have a look at the time these elements were produced, and play with the end of each stream. So kind of like move it around and see how that affects the result. And even you can move items on top of each other and see, okay, what happens in that case. So it's, for me, RxMarbles is a great way of learning how Rx operators work. What we're going to do in here is to create a simple application in Flutter that reads the contents of two text files from our resources and then concatenates the results to each other, okay? For that, what we need is to go ahead and create some resource files. So let's go ahead to Explorer here. We have some APIs which are there, but we don't need them, and that's kind of fine. We can just keep them for now. As you can see at the bottom of the screen, we're going to create a folder called Assets. In Assets, we're going to create a folder called Texts, and in Text, we're going to create a file called Cats. So I already have that prepared. So what I'm going to do is I'm going to just drag and drop that entire folder here. Add folder to workspace, copy folder. I think copy folder would probably be more suitable for what we're trying to do in here. So we have assets, as you can see in here. Under there's texts, and then cats, and then dogs as well. So we have two text files in here, and they simply look like this. So they're two text files with three names in each of them. And here we have three cat names, and here we have three dog names. So you can see they're line separated from each other, and that's really it. So there's no new line at the end of this file either. So place three names of your choice in the texts, cats text, and then dogs txt. Okay, so we should be done with that. Then what we need to do is to go into our pop spec and add those assets to our application. So let's go to pop spec here, pop spec YAML. And then we have here almost at the end here, we have this Flutter folder, use material design. And then we have these assets in here. So let's uncomment this and then uncomment this and this as well. And then I'm going to say assets / texts / cats txt. I'll copy that and I'll paste it here as well. Dogs txt. And I'm going to save this file, which will then do basically insert these elements into our application bundle. Okay. Then what I like to do is just to stop the execution of the program and then close those files. Then what we'll do is to rerun our application so we trigger a new build because we just added some new resources to our application. Okay, so it's just a safer way of doing this. As you can see at the bottom of the screen, we're going to go ahead now and remove the existing content from this file, okay? So, and then we're going to add a simple scaffold to our application. So let's go ahead and do that now. So Flutter scaffold application, as you can see, okay, which is a code snippet that I've added already to my Visual Studio Code. And if you don't have that, you can just go ahead and create an app stateless widget and a homepage stateless widget in here, okay? Error launching application, okay, that's fine. I'm going to save this file again, and then let's run the app now and see if it's going to be successful this time on, oh, iPad Pro. That's not what I want. So let's go ahead and say select device, and then I'm going to say iPhone 13 Pro, and then run the application. And I can see here's our iPhone 13 Pro. So really the build should be successful. We didn't do anything out the ordinary. So let's see if that is successful. Let's go now inside our main file in here and create, and I can see now the application is running. And let's close the widget inspector, go back to what we were doing. As you can see at the bottom of the screen, we're going to go ahead and create a file that, given a file path, it can go ahead and read the contents of that file and return a stream of strings to us. So above homepage in here, I'm going to go ahead and say we have a function that returns a stream of string, and then it's going to say get names, as you can see at the bottom of the screen, and a required string parameter, and it's going to say file path. Okay. Given this, we're going to say final names is, and we're going to say we're going to use root bundle and load string. Okay. And we're going to take the file path in here. Then we're going to say, because you see names at the moment, it is a future of string, but what we need to do in here is to basically separate every line of this string and then return this as a stream. So, and the reason behind, I mean, to be honest with you, we could return this as a future. However, we're going to concatenate these futures to each other. It's always easier than to work with streams, because if we're using RxDart works a lot better with streams than just futures. So, and to be honest with you, that's a little bit also my opinion as well. So, so let's go ahead and import RxDart in here. Okay. If you're if you're a little bit brave, you could go ahead and also just use a future, but we're going to use a stream in this example. So let's say names. So we're going to say stream from future and names, okay? And then we're going to transform this guy with a line separator. So const line splitter, okay? And that's it really. So, and we're going to return this guy, because if we say final result is now a stream of string, okay? And if we didn't do the stream from future, then we'd have to transform that on our own. But it's just so much easier to use streams in this case. So this is really our get names function. It's very simple, reads the file from the given path, and it just returns a stream, okay? So let's go ahead and create another function that calls this function, and first of all, calls it for the cats, for instance, and then calls it for the dogs, and then concatenates the results of these two streams, okay? This function is going to be called get all names. So let's say stream of string, like this, get all names, okay? And then we're going to say get this, the result of this function is get names from assets / cats dot txt or texts cats txt, okay? And then this is the first stream. Okay, we could just return it. However, we also want the dogs. So as soon as cats file is read, then we want to append the results of dogs to that as well. So let's say then we want to concatenate that. Concat with, you see, it's an IEEE of stream. So we put an IEEE in here, but we're going to only have one element in here. So we're going to say cats and then dogs. Okay. As you can see in here, we can close the statement and the code looks like this. So we have get names for cats and then get concatenates with get names for dogs. All right. Beautiful stuff. So let's go ahead now and program the home page in here. So for the body of the scaffold, so let's put a body in here. Okay, so, and then for the body, we're just going to say future builder. And actually, let's see, because the result of this function really, it shouldn't be a future builder. It should actually be a stream builder, right? So we're not using a future builder. So let's go ahead in here and say a stream builder, and we're using a string. And then what we're going to do is we're going to say the stream itself is get all names, like this. And in here, if you say toList, this actually returns a future of list of strings. So we could perhaps use a future builder, even though get all names is a stream. So let's go ahead and change this to a future builder. Okay? Even though we're working with a stream, you can see here, what happens really is that what we want to do is to get the stream of string in here, right? And display all the items in the stream inside a list view. However, if we use a stream builder, since this guy returns every line in all those files, every line of them as an element. So imagine a stream, just one stream, and every element in that stream is going to be a name. First 3 elements for the cat names, and then 3 elements for the dog names. If we do that, if we use a stream builder, then internally inside our homepage, we need to have a buffer and put all those elements inside some sort of a list, inside some sort of an iterable. And every time the stream builder triggers, every time the stream triggers a new element, we have to put that element inside the buffer and then reload our list view. However, there is a really powerful function on stream that is called toList, which basically syncs all the values inside the stream, inside a buffer itself, and then returns instead a future to us with all the values when the stream finishes its work. So if you go to this toList, you can see it says collects all elements of the stream in a list. So it has its own internal sync for that. So this is very powerful, and that's why we're going to use a future builder. Okay, so the future is going to be get all names toList. And here we're going to say this is a list of string. Okay, good. And then we're going to go ahead and program the builder function in here. So this gives us the context and then the snapshot. And then we're going to say a switch snapshot connection state, as we usually do. And then let's add all the missing case clauses. Okay, so in case of none, waiting, and pretty much every case, I would say in here. So except for done. So let's take all of these cases in here and fall through. So let's say in case of none, waiting, and active, we're just going to return a const center. And then we're going to say the child is a circular progress indicator. Okay, so that's basically we're displaying a loading screen. This is not always the right thing to do, though, because if the connection state is, for instance, none, you may not want to display something, or you may want to display some sort of a text instead of displaying a circular progress indicator. So this is completely up to you. But since we're just developing a simple application, that doesn't matter so much. For the connection state done, let's go ahead and create our list view then. Okay, so let's say final names is snapshot require data, and this is, you can see it gives us the list of strings. And then we're going to say we return a list view. And here, what I'm going to do is I'm just going to copy paste the code for list view because it's not so relevant. And I'll just explain to you what we did. So we have a list view separated. It has separators. Okay, as you can see in here, it creates a divider. The item count is the number of elements inside names, and the item builder simply creates a list tile for the title of every tile. Then we have a text widget that grabs the name at a given index. It's very simple. Okay, so let's just save this file and then hot restart the application. And now when we open our app, you can see that it looks like this: Mittens, Floofers, Lucky, Biscuit, Captain, and Hodson. So this is our list view separated, and the 3 first elements are cat names, and then the second 3 are dog names. And you can play with this because you can go ahead, for instance, since this is happening so fast. So if I bring the simulator here and then I do a hot restart, You can see it happens really fast, but you could play with this and, for instance, go in here and basically say throttle or delay. Okay, and then say const duration seconds 3. So you can delay the entire result by 3 seconds and then hot restart the application. And you see here, we have a loading screen for 3 seconds, and then the values come in here. So this is what I mean by Rx is just a series of operators, and that shouldn't be scary to developers because you know that you're just playing with elements inside streams and futures. So it's a fun game as long as you can understand what each one of these operators does by having a look at RxMarbles, perhaps. Okay. So we've now looked at how it works, and it's a list view, so you can scroll up and down, and then you can display as many items in this as you want. Let's commit and tag our code. So let's go to the terminal and say git status and git add all. And we can say git commit, and then we're going to say step 10, I believe. And let's tag it as well as step 10. So all our tags are available in here, and all the commits are also available in here. Okay. So with that said, this was the last simple example in this chapter. And now we're going to go and do a massive effort of creating, actually not just massive, but also a fun effort to create a fully fledged application that uses RxDart as the state management solution to create an application that talks with Firebase, and it allows you to create, first register your user, sign in, sign out, delete your account if you want to. It also allows you, once you're signed into the application, to store your contacts. So you can store contacts with first name, last name, and telephone number, and those values will let me stored in your personal folder inside our Firebase storage. So it's a lot of stuff to do. We will go through all of that. We will create quite a lot of blocks actually with RxDart and put them together. So this is, to me, is going to be a very fun application. So let's have a look at how we can achieve that. Let's go ahead and start building the structures for this application. Before we get started, let's have a look at how this application is going to look like. Because for me, usually when I'm working on a solution, whether it's on backend or frontend, or whether it's an abstract solution, it usually helps me to kind of see what I need to develop. So here we have an application. As you can see, when the user lands on this application for the first time, he or she is going to see a login screen. Then there is a button here that says not registered yet, register here. And then you tap on it, which goes to the register screens. It's pretty much a copy paste of the login screen. However, it has a register button in here and a register title on the nav bar. Then clicking this icon or tapping that icon brings you back to the login screen. Upon pressing login, then we see a little login dialog. Or a loading dialog, excuse me. And then after a successful login, we land on this page that says contacts list, which at the moment is empty. Pressing this button, we can log out and delete account. And then there is a floating action button at the bottom of the screen, which is right here, pressing which will start basically or display the create a new contact screen for the user. So we have some information here, the first name, last name, and a phone number. Save contact, then creates that contact on the list. So we can save as many contacts as we want to. And then we also have a delete account, a delete button in here. So we can delete these contacts that we've created, okay? So we also have a logout and a delete account button. So logging out simply just logs you out of the application. And then we have a delete account upon pressing which we should be then sent back to the login page. So that's something that we're going to develop in this application. So let's just log out in here. And then if I try to log in here, then it comes here. So we just need to make sure that we implement the delete account. Let's go here. Yes, that's not implemented at the moment. So we just need to implement that. So let's not forget that. So this is the application that we're going to create. It's going to work with Firebase authentication, and it is also going to work with Firebase storage, So every contact that we create in here is kind of like saved inside Firebase storage. And we're going to set up also some rules for our Firebase storage, that bucket. So every user is only going to have access to his or her contact in that bucket. So when you log in with a user A, that user A is going to get their own container in which we can store their contacts. So that's how the application is going to look like, and we have a lot of work to do. I'm going to walk you through every step of the creation of this application, so we're not going to jump over any piece of code. We are going to kind of like write the code in the same way that we write it, for instance, for other chapters inside the Flutter State Management course here on YouTube. So there's going to be a lot of similarities in how we do that. For instance, the login page, the register page, the loading view, the alerts. For instance, if I write an invalid email in here and say login, then there is an alert displayed to the user. We've done these, pretty much all of these, in some of the other chapters in the Flutter State Management course here on YouTube. For instance, we did these for MobX. We did these for Bloc chapter as well. And I've jumped into details. For instance, when we developed this loading screen or these dialogues, the first time we did that, it was in the Bloc chapter. And in the Bloc chapter, then we went through all those details and wrote everything from scratch. When it came to the MobX chapter, to save some time, I basically reused those pieces of code and just went over them quickly without re-implementing them. But I think it is very fitting if we actually re-implement everything from beginning in this chapter. So this chapter is self-contained. So the reason being, I want you to be able to start this chapter from beginning and watch it to the end without having to jump into any other chapters, even though they may be quite relevant. So that's our goal for this example. It's going to take some time to develop this example, but I hope that you can stick with me throughout it so that we can come out of this having implemented this entire application, including the delete account part. Okay. So the first step in creating this application is to go ahead and have a look at the documentations for Flutter Fire and basically setting up our application. Okay. So the documentation is, as you can see at the bottom of the screen, if you go to Flutter Fire. So I'm going to bring up Safari in here. So let's say Flutter Fire. And then here we have some documentation. Add Firebase to your application. This is not really the one I wanted. So let's say Flutter Fire. Flutter Fire, Flutter. And then, oh, we land here. Maybe this is fine as well. But this is really not that page that I was looking for. So if I just type Flutter Fire, that's the first link. That's interesting. Firebase Flutter Dev. Maybe it's just changed. Maybe that's the reason, because I remember Flutter Fire Dev. That's not it. It's perhaps just changed. That's completely fine. So let's close this window, and we're just going to follow the instructions in here, basically, to get started with creating our application on Firebase as well. Okay. So the first thing that we need to do is to, as you can see in the documentation, if you haven't installed Firebase and the CLIs, you need to follow this page thoroughly. And I can actually type this URL at the bottom of the screen, Firebase. Let's do that. HTTPS firebase.flutter.dev docs overview. Okay, yeah, and we end up actually here. So they've just changed the URL. Sorry, changed the page. So if you haven't done this before, if you haven't installed the Firebase CLI and the Flutter Fire CLI, I suggest that you go through this entire documentation and do your Firebase login, etc. However, I've already done that. I've already done the Flutter Fire config, as you can see in here. Okay, so these steps are things that I've already done. So sorry, the Firebase login is something I've already done. But if you haven't set these up, please just go through this documentation and read how to set up the CLI. So what we will do, we will start at this stage of adding Firebase core, which is here, Flutter pub add Firebase core. Okay, so this is the step 3 that we're gonna continue from here. So I'm gonna copy this guy. Let's see, copy, and then I have already opened terminal right here. Okay, and which is in that folder where we have our application currently. Okay. So let's issue that command in here. copy it, and paste it in here, okay? So this is going to add Firebase core to our application. So if we go to popspec YAML, then we can see, get rid of that. Let's see in here, we should now have Firebase core added to our application alongside RxDart, which we have from before, okay? So that's really good. That's the first step. And what we're gonna do in here is to go ahead and say Flutterfire configure as it is stated in here. Okay, so I'm just gonna copy this code and then go in here and say Flutterfire configure. Invalid kernel binary format version. Okay, we're just gonna say that we didn't actually, we're gonna assume that we didn't see that. And here we're given a list of projects that I've already created, for instance, for my applications. And then we're also given a choice to create a new one. So if you look in here, what we're gonna do is to say testing RxDart.course. Let's see if we've already created testing RxDart before. mobx push, and we haven't done that. And I can see here there's an Rx Contacts app, and I believe that the Rx Contacts app is this application that I just demonstrated to you. So that's the one, okay? But since that's not the one that we're gonna use in this example, I'm gonna go ahead and create a new one. So let me just scroll this so you see the entire screen better, because we have a caption at the bottom of the screen. Like this is better. So I'm going to go here and say create a new project, and you probably also have to do the same. So create a new project, okay? Then it says enter a project ID for your new Firebase project. In here, I'm going to say testing RxDart course. So let's say that this is the identifier for my project, and you're more than welcome to add an identifier of your choice as well in here, okay? So it says testing RxDart course is being created in here. And let's see if this step is successful. It may take some time. I'm also on a 1,000 connections, so this really maybe doesn't have anything to do with my internet connection. It's mainly that, yeah, Firebase could take some time to do this because it's actually creating the project for us. So in here, it asks us to create an Android, iOS, and web application by default, and I'm going to uncheck web by pressing space on it, and because we're just going to create an Android and iOS application, and then press enter in here, okay? It's now going to ask us what we're going to use as a bundle identifier for our iOS application. And in here, so for Android, we're good to go already. But for iOS, we need to specify a bundle identifier. And that's going to appear soon, hopefully. Oh, it just registered it. Okay, so it says the file's Android bundle will be updated to apply Firebase configuration and plugins. Do you want to continue? Yes. Okay, it just created the application for us. So I didn't actually have to configure anything with the bundle identifier for iOS, and that's also really good. So let's have a look in here what it actually did for us. So if we go to Visual Studio Code and open up Terminal and have a look at Git status, you can see there's actually a lot of stuff that's being created here for us. It added the Flutter debug XC configs, Xcode configurations, popspec, and it has iOS pod file now, and so we now have a Cocoa pod added to our iOS application as well. And then we have the Firebase options as well in here. So these are the keys basically to creating a successful Firebase application. So that's really good. Then what I'm going to do in here, before we continue, we're going to say Flutter clean. Okay, so this is going to clean all the residues from the previous builds. And then we're going to say Flutter pop get. Okay. Fantastic. So if you look at our application, we shouldn't have any errors in here except for test. And to be honest with you, we can delete that file for now because we don't need it. Okay. Good stuff. So we're good to go up to this point. Let's go ahead inside our Firebase console now and enable email and password logging in, because Firebase allows you to have many different authentication providers, for instance, Facebook, Google, email, etc. And for this example, for this application, we're going to use email signing in. So we need to go ahead and enable that provider in Firebase console. And you do that by going to Firebase console. So if you just type console. So here we ended up in this console, which is for my correct account. So I'm going to close this documentation in here. And the project that we created was called, I believe, something to do with contacts or something like that. Let's see if we can find it. I have quite a few. So here's the project, testing RxDart course. Okay, so let's click there. And then we're going to go ahead and into authentication tab. And then we're going to say get started. Pressing get started will then bring us the list of providers. Then we're going to click on email and password and simply just enable it and save it. As you can see now, inside sign-in methods, we have a sign-in provider of email and password. And that's really all that we have to do for this one. After this step, we need to go ahead and add Firebase authentication as a dependency. And usually I go to PubDev, and I say Firebase auth. In here, then you can go ahead to installing. As you'll see, the version number that is recommended to install is actually 3.3.18. At the bottom of the screen, I've said 3.3.16, but these versions are moving targets, so they're always being added to. They're always being updated. So you don't necessarily have to look at a caption on the bottom of the screen. Always go to pub.dev and look for that package that you're trying to install and install the latest version if you can. So I'm going to go in here and literally just say flutter pub add Firebase. I'm just going to copy this from here. And let's go inside our Visual Studio Code, bring up terminal, and paste this in. And what we can do is to have a look at our pub/spec YAML and see which version was actually installed. And it's 3.3.18, which I believe is exactly the same thing that was recommended here on the web. Okay. What we're going to do in here is, in this example, we're also going to use Flutter hooks. And Flutter hooks, we're only going to use it for the text editing controllers. So you saw in the example that we're developing, we have two text fields in here, which require their own controllers. On the register screen, also we have 2, so there's 4 total at the moment. And when we log in and try to create new contacts with this floating action button in here, then we have 3 in here as well. So 4 and 3, we have 7 total text editing controllers in this application. And this could get a little bit cumbersome if you're trying to manage all these text editing controllers manually with stateful widgets. And that's why in this example, we're gonna use Flutter hooks. So let's go ahead and into terminal in our application and say flutter pub add Flutter hooks, okay? Should install the latest version of Flutter hooks in our pub/spec YAML, all right? Okay, we also need to add Firebase storage to our application, because with the storage, we're actually storing all the contacts per logged in user. So as you can see at the bottom of the screen, it says Flutter pub add cloud Firestore. So let's add that to our application as well. Okay, and then we're also going to use the UUID package. So let's say Flutter pub add UUID. Okay, I'll bring that up as well at the bottom of the screen. So there are a few packages that we had to install, but not too many, nothing crazy. Okay, since all of this has updated our pod file, so if we go in here and look for pod file for iOS, for instance, then we can see quite a lot of stuff in here. However, there's a problem with pod files in that the default pod file that Flutter application generates for you is that it doesn't have a platform set, and a lot of the pods that we are adding here, for instance, Firebase, they require a minimum platform target of iOS 13. So you need to go into your pod file in here, okay, and update it. So go into, open your pod file, as you can see in here. Find this line that says platform iOS 9. It's commented out. So let's remove the comment in here. And in here, let's change this to iOS 13 and save this file in here, okay? So then what we need to do is to basically do a clean. So I'm going to say Flutter. Actually, let's go ahead and into the iOS folder. And then what we could say in here is say pod d integrate first. Integrate, pod d integrate, yes. And then we're going to say pod install repo update. Okay. And this is going to go ahead and install all the pods required for our application. So it could take some time depending on the state of CocoaPods on your computer. You may not have all the latest pods, and this could possibly then take longer time than it did right now. Okay. This is all great stuff. So what we need to do then is let's do a select device, and then I'm going to say iPhone 13 Pro, and in the main Dart file, let's just go ahead and say Flutter scaffold application. So we just have a simple scaffold. And then I'm going to go ahead and stop the execution of the program because we've done quite a lot inside the pod file. And we've also, actually not a lot, but the effects of what we've done are quite big, because we've added quite a lot of pods to the application, like Firebase and storage authentication. So what we could do in here is just to install our application afresh. So it basically compiles the app completely fresh, and then we can see if this process is successful or not. So as you can see, it's at the step of running pod install. And in my experience, sometimes depending on the application that you're creating, this step could actually take a long time. But in this step, I could see that it really just took 3 to 4 seconds. But recently, when I had to run the same application that I just demonstrated to you, the entire process of pod install and running the Xcode build took about 3.5 minutes almost. So it could be a lengthy process. So let's just wait for this Xcode build process to finish, and then we should be at least safe in that we know that all our dependencies are injected into the application correctly, and we should be able to then build the rest of the app based on that. This process could take a long time, actually. On some computers, it could take a few minutes. And depending on the speed of your computer and like the state of your CocoaPods, this could take anything between perhaps a few seconds to a few minutes. So there's no concrete answer to how long it could take, but the result should really be that you have a simple scaffold application here. For instance, that's this homepage. So it's a homepage stateless widget and an app stateless widget. So there's not much more to it. So if you got into this state and you have all your dependencies set up, then you're good to go. Let's go ahead and start writing our Cloud Firestore rules. You see, we're going to use Cloud Firestore. So we're going to have to go into Firebase console and enable Cloud Firestore. And that's where we're going to store all the contacts informations. Then what we're going to do is for every user that logs into our application, we're going to create a folder. That folder's name is going to be the user identifier. And every user will then have access only to his or hers folder. And what we're going to do is to create some rules. This is a basic rule, actually. Given a specific collection at the root of Firebase Firestore, and we're going to ensure that it is equal, its name is equal to the user's identifier. If it is, then the user has access to do exactly whatever they want in that folder. Create documents, edit documents, delete and update documents. So kind of like CRUD operations. However, if it is not, then we're not going to allow the user to access that folder. Okay. So let's go ahead and enable those rules. So let's have a look here. If I'll bring up the Safari window, so you can use whatever you want. You may want to use Chrome, for instance. So let's go in here in our application. You see in here we have testing RxDart course, as you can see in here. And what we need is to go into Firestore database on the left-hand side. Sometimes it could be that you don't actually see these texts to the left-hand side. You may see icons. And that is simply because if I go here, let's see if I can resize this window. If I go here, it could simply be that, can I see the icons perhaps? Here, depending on the sizing of your window or maybe even your settings, if you, for instance, have clicked on this particular button at the bottom of the screen, you can see that there is a button in here. This will show and hide the labels for you. So if you tap on that, it will show all the labels for you. And if you tap again on that, it will hide all the labels and only show the icons. So don't worry if you don't see those. It's just the matter of resizing your windows so it becomes apparent in which one's which. Then what we need to do in here is go to Firebase and database in here. sorry, Firestore database. And as you can see, we haven't enabled that before, so we need to do that now. Then tap on create database, please, in here. And the screen layout is a little bit messed up, and that's just because I've enlarged the window so much. But what I recommend here, usually to whoever I'm talking about like Firestore databases, is to start the database rules in production mode always. I know it is like tempting to start it in test mode because then everyone has access to everything, and it is like a good way. I shouldn't say good way. It is a simple way to start. However, it is very easy that you start with test mode and then you start developing your application, everything works fine, and you completely forget about excuse me, forget about going into production mode, or you just get lazy and be like, it kind of works, let's just leave it there. Test mode is, as its name indicates, only for test mode. And I'm kind of like against the fact that we even have test mode, because it doesn't encourage critical thinking from the beginning, because databases they need to be kind of protected from the absolute beginning. So I suggest that you don't ever use test mode if you can. Always go into production mode and try to really set up your rules correctly. Okay, so let's go to production mode, and then I'm going to say next in here. Press the next button, and I just noticed that you perhaps can't see the next button because it is hidden behind my face. So I'll bring this here, and if you look, the next button is available right here. So I'm just going to press next. This is your location settings where your Cloud Firestore data will be stored. So let's just pick a location that is close to me, for instance. And I'm in Europe, so I'm in Sweden. Let's see if we have something that is close to me. And it doesn't really matter so much. So in here, I'm just going to use Europe Central. Okay, let's see if we can then press the enable button. And here it says provisioning Cloud Firestore. And I believe that this usually goes by really fast, so we don't have to wait so long. And while this is happening, perhaps I could show you how we're going to set up the rules for this project. This is an exact same project that I've set up when I demonstrated the application for you on how the rules have to look like. And you can see this is the default rule or the matching statement that Firebase writes for us. It says databases, database documents. And then in here, we have this match statement that says we want to get the root folder of our database as a variable called collection. And then in there, we want to match all documents, okay? The reason we do this match in here is simply because we want to be able to have access to this collection as its name. And then what we do in here, we say allow create, read, update, and write if is collection owner collection. So here's a function that I've written in here. You can see is collection owner, and then it says user ID, and then we're passing the name of the collection as the user's ID in here. So we're basically making sure that the requests auth user ID is equal to this user ID that is passed in here. So we could perhaps change this in here and say collection ID like this. And then in here, we could say the user auth UID should be equal to collection ID. That could also work. So it will actually be more explicit than in here. It's not the user ID being passed, but it is actually the collection ID. Okay, let's go back to our database now. And I can see now that the Cloud Firestore has been created for us. So we have some problems with the styling of this, basically because I've increased the size on the screen so much, but that's also fine. Let's go into rules in here then inside your Cloud Firestore, and that's where we're going to edit the rules. You can see by default there is a match statement in here, which is matching all documents. Okay, but we want to in here match collection. So we're going to say we need a collection variable in here. Okay. And then in here, let's go ahead and write a function. So let's say function is collection owner. And then we're going to say collection ID. In here, we have access to requests. So we're going to say if request.auth shouldn't be null, meaning that the user should not, or the user should actually be authenticated and shouldn't be anonymous. And if you look here, we actually start the statement with a return. So let's just say return. The request auth shouldn't be null. And also request auth user ID should be equal to collection ID. Okay, so that's the function. I always believe, I mean, what you can see in here, there are two errors being displayed. You can see it's actually marking it as errors in here. Invalid variable name request. So in here, let's see, we have request auth, you can see, and request auth UID. These are actually fine. There's nothing wrong with the rules that we're writing in here. However, Firebase is kind of confused because we're not actually using this function at the moment. So ignore these errors that are being displayed in here and just go ahead and write your function. So we're going to say create, read, update, write. So let's say allow create, read, update, write. And we're going to say if is collection owner. And in here, we're going to pass the name of the collection. Let's say collection ID in here, and then collection ID in here as well. Okay. So now you can see, now that we're using that function, the errors have disappeared. And this is what I really don't like about this particular editor. I mean, I really appreciate the Firebase team putting time and effort into creating this editor. So that's without question. It could be made a little bit better though, because as you're writing your rules, you would probably appreciate not getting fake errors. Like if I comment this code out, all of a sudden you'll see 2 errors displayed in here. I would accept the first one. It says unused function. That is completely fine. You shouldn't have unused functions here. But the second error says invalid variable name request. And that's not good, because then you'd be going around scratching your head. What's wrong with my code? There is nothing wrong with your code. The only thing that is the problem is that you're not using the function, which is the first error, not the second one. The second one makes no sense. So just know that. Don't be discouraged if you see errors like that. It's simply because you're not using that function. So I hope that it makes sense what we're doing here so that it's not too abstract. But have a look at this, this code that we've written in here and ensure that you're doing a publish. What I'm going to then show you is to go to data in here, to the data tab. In here, what we're going to do, as you can see, this is our database in here. And then we're going to start a collection. Let's say user ID 1. User ID 1. Okay, let's start the collection and then add a document in here with an auto ID and say blah is the blah. Okay, can we actually add this? Do we have to have another field? I don't understand why we don't have the save button in here, to be honest with you. So if I say number 1, oh, for some reason I can't even generate a document in there. That's okay. We're going to do that through code. But what you need to know, collections failed to load. So, okay, let's see if it works. Reload. That's fine too. What you need to know in here is that we're going to create a folder or a collection, as Firebase calls it, per user. So when I sign up, let's say that my user ID is UID1. Then as soon as I sign up and start creating documents, then we're going to store those documents inside a collection called user ID1 or UID1, which is my user identifier. And all my documents are going to be created under that folder. And that's why we have that rule set up. Okay, so these rules, as you can see in here, the collection ID should match the user ID. All right, so I will have only access to that collection and all the documents in that collection. If a user deletes their account, then we're actually going to delete that folder, entire folder and all its contents as well. Okay. If the user is editing something inside that collection, that's fine as well, because our rules allow that. We also allow deletions. So if you go in here into our rules, you can see we have create, read, update, and that's what update includes. Update includes deletion as well, if you read the Firebase documentations, okay? So it seems like we've actually set up our rules correctly. And what you could do really is just to ensure that you run your application, just make sure that everything is working fine. It's something that we've done before. So if you've done that before, you don't have to worry about anything, okay? So now that we've done the rules for our Firebase Firestore database, and then we've set up our dependencies in the project, it is time that we start talking about some of the utility codes that we're going to need in this project. As I mentioned before, we need a few things such as loading screen, and then authentication errors, authentication dialogues, logout dialogues, deletion dialogues. So there's pretty much, I mean, there's a lot of like independent reusable components that we need in this project. I've already done these components before in both the MobX and the Bloc chapter. In the MobX chapter, I decided just to copy paste them and kind of explain them quite fast. But in the Bloc chapter, we wrote it from scratch. So I think it would be really good if in this chapter, again, we write them from scratch, but kind of try to do it in a fast way so that it's not repetitive, okay? So let's go ahead and start writing our loading screen. If I bring back our application, the finished application in here, right? And if I, for instance, log out of the app and then I try to log in again, then you'll see a loading screen appear. So Do you see this? That little loading screen? So I'll go here and do it again. There. So it dims the entire screen and it displays a loading indicator, a loading text, and a circular progress indicator. That is a loading screen that we're going to do. And it's not a simple screen, it's actually an overlay. So it is a good practice to work with this loading screen because it allows you to also learn about overlays in Flutter. So let's go ahead and start implementing these. So the loading screen is in two parts. One is the loading screen itself, and the other part is the loading screen controller. So the way it works is that we have a loading screen, which our application is going to use. So in the Flutter application, we're just going to say loading screen, and it's going to be a singleton, and we're going to say show yourself, okay, or hide yourself. Let's say that you show the loading screen and you say loading. And then immediately after that, while the loading screen is displayed on the screen, you want to say, oh, now I want to show another loading screen that says something else, like the text is going to be updated, for instance. So first says is loading, and then maybe right after that, you want to update the text and say, oh, all of a sudden, I want to say loading your account contents. Upon doing that, we shouldn't hide the loading screen and show it again, except if the loading screen is already presented to the user, we have to update its contents. So for that, we have this loading screen controller. It's just going to be an object that is going to have a reference to the loading screen, and it's going to allow us to call a function on that controller to update the contents of the loading screen instead of hiding it and showing it. So it will be a lot more clear to you once we actually do the implementation, but I just thought to lead the conversation by telling you what this controller actually is. Okay. So as you can see at the bottom of the screen, we're going to go ahead and create the lib loading and then loading screen controller. So inside lib, let's say new file, and then we're going to say loading, and then we're going to say loading screen controller Dart. And inside this loading screen controller, what we're going to do is to just define the controller object itself. The first two things that we need to do in this file or in this Dart class that we're going to create are two type definitions. One is for closing the dialog and the other one is for updating the dialog. Okay, so let's go ahead and first actually create our type defs. So we're going to say type def close loading screen. So this is just a function callback in here. So we're going to say it's going to return a Boolean and it's going to indicate whether it was successful or not, for instance. And then we're going to say type def update loading screen. Okay. And this one's also going to return a Boolean. It's a function and it just takes a string in here. Okay. So I forgot the equal sign in here. So let's go ahead and say immutable class loading screen controller. Right? Immutable comes from foundation. So let's import foundation. So show immutable. All right. Ignore these errors in here. Sometimes these happen with Flutter 3, and that's fine. In here, what we need is just to take two references to these close loading screen and then update loading screen function references. So we're going to hold into two functions. As soon as the loading screen implementation itself, which we haven't done yet, it creates a loading screen and it displays it to the user, is going to return an instance of this loading screen controller to us. And then next time the user displays the loading screen, if we already have a reference to a loading screen controller, we say, oh, then the loading screen is already displayed to the user. Use its update function in order to update the text on the loading screen itself. If we don't have a controller, then we're just going to say, oh, there is no loading screen on that is displayed to the user. So we create a new one. And if the loading screen is also displayed to the user and the user said, and then the programmer, we says, close the loading screen, then we're going to use this close function on this controller in order to close the loading screen. So basically the loading screen controller is really, as its name indicates, it's just a controller. It has a reference kind of to the updating and the closing of the loading screen. Okay, so in here, let's say final close loading screen, and this is close. Final update loading screen, and this is update. So two function references. Let's add these as inside the constructor as well. So this is going to be a constant constructor, a comma in here, curly brackets, okay, because these are going to be required parameters, and then put required in here, required. like this, okay? So it's performing hot reload. It's not so successful in this because we're not inside our application. So let's go in here. Now hot reload is working as expected. So this is the simple implementation of loading screen controller for us, okay? So let's go ahead now as well. I mean, we have already, I can see that I created a separate caption at the bottom of the screen for implementing this, but we've already implemented it, so it's a little bit too late. That's fine. Let's go ahead and create the loading screen file as well. So this is going to be the main implementation of our loading screen. So right inside the lib loading, let's say new file, and then we're going to say loading underscore screen.dart. Okay. So this is the creation of the file itself. So let's go in here and create the loading screen itself. So I'm going to close loading screen controller, and I'm going to close the main file. So the only file we have open is loading screen in here. So let's say class loading screen. Okay, this is going to be the main implementation of our loading screen. So let's create a loading screen shared instance in here. So loading screen dot underscore shared instance. Okay, this is going to be a private shared instance of our loading screen because we're going to create our loading screen as a singleton. Okay, so let's say static late final loading screen shared is loading screen shared instance. So we created a late or like a lazy loading screen variable in here, which is static. And then we're going to create a factory constructor for our loading screen in here, okay, dot instance, and that is equal to shared, just like this. So this creates a singleton. So inside our application, we can just say loading screen dot instance, and this will give us this shared instance, which in turn has called already the shared instance, or it calls the shared instance private initializer or constructor upon it being used for the first time. And then the second time is already initialized since it's a static late final variable, then it doesn't need to call shared instance again. So this is kind of like a weird way that Dart has chosen to do singletons. In many other languages like Swift and Rust, it is a lot easier to create a singleton. So, but that's the way we do it in Dart. So let's just roll with it. As I mentioned, this loading screen guy is going to hold on to a reference to our loading screen controller while the loading screen is displayed to the user. So let's say loading screen controller as an optional in here. Then we're going to say controller because it may be null. If there is no loading screen displayed to the user, then we're going to set this property to null. And using that variable, then we know, oh, the loading screen is either displayed or not. If it's not displayed to the user and set the controller to a valid instance of the loading screen controller. If it is displayed to the user, meaning that this is not null, then using the controller, we can update the loading screen or close it, okay? So let's go ahead in here and then start the show function in here. So let's say, actually, we should probably first implement the show overlay function because that's like the meatiest part of our implementation. So let's go ahead and create a function in here, and we're going to call it show overlay. Okay, so, and this returns a loading screen controller in here. Okay, and then we call it show overlay, something like this. And this is a private function because someone from the outside shouldn't be able to call this, okay? Then we're going to say required build context, and this is our context, and then required string, this is going to be our text, okay? So in here, we have a little error here because we haven't yet displayed the loading screen controller. In this, the most important thing, I mean, what we need to really do in this function is to actually construct the entire overlay. So this is the most important function in this entire class, okay? And the text changes to the loading screen. You see this, I'm trying to stress this quite a few times. If the loading screen is displayed already to the user, and then the programmer says, okay, display the loading screen again with this text, we're not gonna hide and show the loading screen again. What we're going to do is to say, okay, you want new text to be displayed. We'll just update the text of the same dialog or of the same overlay. So we need some sort of a stream controller that holds on to the text that you want us to display. Okay, so let's start with that. Let's say we have a text in here, which is equal to a stream controller of string in here. Okay, and then we need to import async, I believe. Let's see, import library Dart async. That's great. Okay. And what we do, the first time you call this function, you already want a string to be displayed for the loading screen. So let's just add the string in here, the text you can see. Okay. And what we need is a few variables in here that will give us information about the build context and how much of a space visually we have in order to display our loading screen, because our loading screen is not going to take the entire available space. What it's actually going to do is to display itself and take, for instance, X% of the available width of the screen, and then it's going to display itself with a minimum height, with a specific minimum height. And then if the text is so large that it doesn't fit into this minimum height, then it's going to increase its size. So we're going to use some constraints. That's what I'm trying to say, okay? So we need a render box. This render box is going to give us the available size to us. So let's first, in order to get this render box, let's just say state is overlay of context. So we have a build context. Then we're going to say render box is context, which is the parameter passed to us. Find render object, okay, in here. And then we're going to say as render box. And then we're going to say the available size for us is the render box.size. Okay, so this state is going to be used separately from the render box and size. So I separate them here. You'll soon see how we're going to use state, okay, and size, of course. So let's go ahead and create our overlay. If you haven't done overlays before, this will be completely new to you. But if you've done overlays before, then you know that it's a very simple process, really. It's just we create a material object, and then it will be available freely to be displayed on the overlay stack. Overlay, if you haven't done overlays before, I'll just quickly explain to you what they do and how they work. Overlays work separately from your widget tree. So your widget tree is kind of like as its name indicates, is a tree of widgets that are having like relations to each other. So if you have a material widget and then inside there you display X and Y and Z, they're kind of compact and put into each other. And then when your widget is displayed, for instance, your stateless widget as a scaffold or something is displayed to the user, it has some properties that define to it that, hey, I take the entire screen and then you can push other screens on top of me, etc., etc. However, if you're using overlays, they're a lot more like free in that they're just displayed nilly-willy. So you can just display them wherever you want and they will be displayed on top of everything else. So think of them kind of as modals in the iOS world, or dialogues like in Android, like Toast, so they can be displayed on top of anything, okay? And that's why we're using overlays, because we don't want to affect the widget tree. We only want a visual representation of a loading to be displayed to the user on top of everything else, all right? So let's go in here and say final overlay is overlay entry in here, okay? And then we have a builder in here. So let's in builder, go ahead. And I can see our builder. Let's see how it looks like. Overlay entry. It has a builder, which is a function that gets a build context. So we get a context and then we have to return something in here. Let's have a look at, again, at it. We have to return a widget, okay? So in here, let's just say return material for now, like this, all right? And we're going to have to fix this. So fix me, this is not done yet. All right. But at least we have an overlay entry. And that's actually our overlay. OK. So we're going to fix the implementation for this. But let's go ahead. Let's just say that we have already created our overlay. OK. What we could do is to take this state in here and move it down. So let's move the state variable down. OK. And using this state, then we can add our overlay on top of every other overlay in the application. So let's just say state, since it's an optional variable, we have to say, you see, it's optional, it says here, overlay state. It has a function called insert, and then we put our overlay in there. So we insert our overlay that we created right there inside the overlay state in here. All right, so this display the overlay. And then what we need to do is, since we have our overlay and then we have our stream controller, we somehow need to really return the result of this function, which is loading screen controller. So let's go in here and say return loading screen controller. And it says, okay, what functions do you want to return in this controller for the update and close? So for close, let's say we have a function in here, okay? What we need to do is we first have to close the text stream controller. So let's just close that. And then we have to remove our overlay from the screen. So let's say overlay, and then we should remove it from the screen. And then the function itself returns true, okay? And then for the updating is very similar. So the updates also, let's see if we can get help from Visual Studio Code, and we can't. So this guy takes in a new text. Then if someone calls the update function on our loading screen controller, we have to send that text to our stream controller, like this, okay? And then we return true in here as well, like that. And you may be wondering, okay, why do we have this return true, etc. in here? The reason behind it is that, as you'll soon see, when we then call the public APIs of our loading screen for displaying it or hiding it, then we're gonna conditionally call the update function or the close functions. Actually, update is more important. Let's say that someone says, let's go in here. Let me just demonstrate this to you. Let's say void show, and then someone says texts in here. So this is the public or the public facing API for our loading screen. Then what we're going to do, we're going to say if controller is optional. Remember, if controller update with this text is true, then we know that we have a loading screen on the screen displayed to the user, and we could update its text. Then we just return. Otherwise, we'd be like, okay, then we don't have a loading screen controller. We have to create a new one. So create or display the overlay, which is show overlay, right? So that is the reason our function is returning a Boolean, both functions actually in here. So if we don't have the loading screen controller instance, then we are kind of like gonna get false from the execution of that optional function because it doesn't exist, all right? Okay, we have the logic for the overlay entry, and also we have the logic for loading screen controller. However, we haven't implemented the overlay itself. So let's go ahead and do that now. So we're returning a material in here, okay? And then let's, for the color, use colors black with alpha of 150. And the reason behind this is if you go back to this application and log out, log back in, if you look very quickly, when we display the loading screen, it dims the entire screen. So look, did you see that dimming? That's that black color that we placed inside material, okay? This thing. Then what we're gonna do, it has a child property in here, and the child is gonna be center with another child, excuse me. And then we're going to create a container in here. So let's just put all the commas so we get the formatting correct. And then we have some constraints. So let's say constraints is going to be box constraints, okay? For the maximum width of our overlay, excuse me again. We're going to take the available size. So let's just change this size actually to available size. Okay, so we're going to take the entire screen's available size width, okay, and then we're going to take at most 80% of the available size, okay? So let's put comma in there, so that's max width. We're going to have minimum width, so we also have to have a minimum width because if the user just displays a loading screen with a text of hello, then the container that we're creating here, which actually contains our entire loading screen's contents, it's going to be very small. It's just going to be tiny on the screen. It's not going to look good. So we need to define a minimum width as well. And the minimum width is going to be available size width times 0.5, meaning that we're at least going to take always at least half of the screen's width, okay? Then for the maximum height, so let's just say max height in here, we're going to say the available size height times 0.8, meaning that minimum, we have no minimum height, but the maximum height, at most, we're going to take 80% of the height of the entire screen, because a loading screen that takes the entire height of the available real estate, it's going to look a bit weird. You always want some margins from right, left, top, and bottom, and that's why we have these box constraints in here, okay? So let's also go and add a border radius in here. So let's go and have a look at, we need some decoration in here. So let's say decoration is a box decoration, okay? And inside this decoration, we're going to say, first of all, we want white borders around the loading screen. So let's just say that the color is colors white. And then the border radius is going to be a border radius, circular of 10. That should be fine. Okay, so that's our decoration. Then we're going to add some padding in here. So let's say body, sorry, a child. Remember, this is a child of the container. So the container is the entire loading screen in the middle of the screen. But inside there, you know what actually we could do? Well, we could go in here and take a screenshot. So I just took a screenshot of this. Let's see if we can bring it up. Can I? Somehow? Okay, I brought it up. So let's see if we can dismiss this and have a look at our loading screen. It should look like this. This is good reference. You can see. So this is our loading screen. So what we need is to have some internal padding. You can see this is the content that we're going to display. Okay, and then the circular progress indicator, size box to create some spacing between these. And also then we're going to have a label or text in here. Okay, so there are a few components, but first we need to do some padding in here. You can see there's padding at the bottom as well. So let's say padding. All right. The padding itself is going to be 16 const edge insets all 16. All right. Good. Let's go back to our application in here. So hot reload starts working again, or hot, yes, let's see, context list. Here's our application. So hot reload works now. And the child of this padding is going to be a single child scroll view, because you could potentially display a very long text in the loading screen. And for that, we need proper scroll view in here. Okay, so a single child scroll view. I know this is very nested, but that's what it takes to create this kind of loading screen. And a single child scroll view. And in here, the child of this guy is going to be a column, which we're going to place all the components of our loading screen. Okay, so in this column, we're going to have a few properties. So main axis size, this size is going to be main axis size of minimum. So we're going to take the minimum amount of space. Otherwise, column always tries to stretch itself out to the entire available space. And the entire available space is 80% of the screen width and height. Remember from our constraints? So we don't want the column to expand itself vertically to take 80% of the screen width. We actually want it to take as much space as it needs to display all its components without taking too much space, okay? And also we want it to center its components horizontally. So if you go back to the simulator, you can see that the components are centered horizontally, okay? So there's padding from right and left. So let's say then main axis alignment is main axis alignment center, and a comma to get that right as well. I think we're missing a few commas, so let's put a comma here and a comma there. Your code should now look like this. You have the padding and then a child of single child scroll view in here. Okay. So for the children, then this is basically the meatiest part of this implementation. For the child in here, the first child is going to be a little bit of a padding on top in here. Okay, so let's just say a size box of height of 10. Okay. And what we're going to do is to add a circular progress indicator. So let's say const circular progress indicator. That's our loading screen. And then 10 more points of padding between the progress indicator and the text. And then for the text, remember, the text is added into a stream controller. So we need a stream builder in here. So let's say a stream builder, which is going to work with a string. Okay. Its stream is our text in here. string. And then we need a builder function. So let's go in here and say, then we have the builder, which is going to take the context, and then it's going to take a snapshot as well. So, okay, snapshot, like this. And we say if snapshot has data, then we know that there's some text in there, but we're always sure actually there is some text in there because we always start the stream controller with the given text. You can see it here, but it's always safer to use the APIs correctly for stream builder or for async snapshot in this case. So then we say we return a text in here. Okay. The text is going to say snapshot, require data. All right. And then we have a text alignment, and we're going to say text align center. Right. So that's in case we have data. Otherwise, we're going to go in here, then we're going to say if we don't have data, just for now, return a container. Okay. So let's save this and go back to our application so that hot reload starts working again. Great stuff. And this is really all we had to do. So there's quite a lot of nesting in here. I understand that, but if you really look at the code, it's not that much. And also this code looks like a lot of code, but it's because I have a gigantic font on the screen so that we can see so that you can actually easier see the code, even if you're on a mobile device. But usually my code is 3 times, I mean, the size of my code is 3 times less than what it is on the screen right now. So I mean, the gigantic font is contributing to this code looking like a lot more than it actually is. Okay, so we're done with the loading screen. So we can now move on to the next component. So I'm just going to close this file and we can move on to the next component. With that out the way, let's go ahead and implement the next part of our application. If you go here to what I had already prepared from before, not this picture, but the actual implementation of the application. Let's see if you can find it, which is somewhere here, I believe. And if we go to this floating action button at the bottom of the screen, you can see that when we start when we are running the application in debug mode, then these text fields are already populated. And if I log out, for instance, from here and then try to log back in, then you can see that my username and actual password, which is a dummy password, are already pre-populated in these text fields or text editing controllers to start with. So this is a habit I have if I'm debugging an application. I kind of want to pre-populate my text fields because I find it quite cumbersome to go ahead and write all these emails and passwords over and over again as I'm testing the application, because once you're hot restarting your application, then these text fields are going to lose their value. So this is something that I recommend also to other people. When you're debugging your application, you could pre-populate your text fields with some predefined values. And just make sure that you're not pre-populating with actual email, with your actual credentials, which is your email and password combinations. You never know if you're going to make a mistake and these things are going to be somehow sent. This code is going to be sent to someone or shared with someone. You never want anyone to actually get hold of your actual credentials. Okay. So let's go ahead and write a little component in here. I'll bring it up here that is going to allow us to determine whether our application is being debugged or not. Okay, because only in debug mode we want to display these kind of text in our text field, in our text editing controllers. So inside lib, let's go ahead and create a folder, and I'm going to say new file, actually helpers, and then if debugging.dart. Okay. So using this if debugging, we're going to then determine whether we're in a debug state or not. So let's say extension if debugging. I'm going to remove the Explorer from here on the string. And then we're going to say string get if debugging. So then we're going to import foundation in here. So let's say import foundation. And then there is a constant in here. Let's say show k debug mode. As you can see in here. Okay, let's go back to our application, which is here. Hot reload and hot restart are going to work again. So this k debug mode, if you click on it, you can see here is a constant that is set to a value, which is release mode and profile mode. So not release mode and not profile mode. Okay, so if we're not releasing the application, or even if we're not profiling the application, then we're in debug mode. Okay, so let's say if k debug mode is true, then we return this instance. Otherwise, we return null. And the point for this is, like, if I put a test function in here, I can say hello world if debugging. The result of this, we can see, is an optional string, as you can see here, which will be null if we're not debugging, and it will be hello world if we are debugging, meaning that we can set any string that we want on text editing controllers, and we say, okay, the text of this text editing controller is XYZ as long as we're debugging the application. So now you know how we're going to use this component. We have quite a few dialogues in our application as well. So if I, for instance, go to the implementation in here, let's say I change the credentials in here to remove the M from .com, and I say login, you can see it says user not found, okay? And if I go to register screen and try to register the same user that's been registered before, and I click the register in here, it says email already in use. So this is another dialogue. Then if we go back to login and in here, try to log out, then here's another dialogue. And you can see all of them have things in common in that they have titles. They can have titles, they can have content, and then they can have various buttons displayed. Okay, so some dialogues have one button, other dialogues have two buttons or more, and these buttons can actually be intercepted to do specific things. So for instance, in the logout dialogues case, then I can see that you can't see this dialog completely. In this case, the cancel button removes the dialog, but the logout button actually logs you out and removes the dialog. So the buttons basically can have their own logic. So what we are going to do, as you can see at the bottom of the screen now, we're going to go ahead and create a generic dialog for our application, which is going to be reused quite a lot. So let's go into lib. As you can see at the bottom of the screen, we're going to say dialogs/generic dialog.dart. Okay, so this generic dialog then is going to allow us to create a dialog that we're going to reuse in many other places. And this generic dialog is going to, excuse me, is going to allow you to create one or more buttons. And these buttons then can have various values. So when the user presses any of these buttons, then a generic value that you provide will be provided back to you, so you know what to do by the user pressing that button. So we need some sort of an option builder, which is like the buttons builder, which gives us a map of string. And also for every of these button titles, it will give us a generic value. So we know on the call site what we should do when the user presses that button. So let's type def that. So we say type def dialog option builder, and option is just buttons builder basically, okay? And it's generic, and it returns, it's basically a map of string and an optional value, and it is a function, okay? So let's see, it's a T function, and it's a map of string T. And this looks fine to me. So expected to find, it says, a string T function, and yeah, this is fine. Let's just put material in here as well. So import material. Okay, material. Let's see if you can find Flutter material. And I can see that we have, I mean, a map of string T, and then a function that doesn't do anything. That's fine to me. I mean, I don't understand really what the problem is with this. A function body must be provided. Try adding a function body. Oh, I see. So this should say function, and that was a typo, and that was my fault. So in here, it should just say function. So now that we have that type def, let's go and actually implement this dialog. So let's say it returns a future with an optional value of T, show generic dialog, and then we're going to say this generic dialog works with T because values of this T need to be provided to the buttons, okay? The curly brackets in here, and then we're going to have a few required parameters. So first we need a required build context, which is going to be our context on which we're going to display our dialog. We need a string title, and we also need content. So let's say content. And then we need also the option builder. So let's say dialog option builder of type, yeah, the T is basically, yeah, we don't have to type that because we already know that we're in a generic context in here. So option builder, options builder, okay. And then what we are going to do in here in the function body itself, we need to return the future of the presentation of that dialog. Okay, so let's say final options. is that we're going to call the options builder, and this is going to then return to us our map of string and dynamic, okay? But we could actually type this as well in here. Now it's going to say options of map of string and optional t, so that's fine as well. Then let's just return show dialog in here, and this is going to be a value of t. It's going to be working with t, and then we have the builder in here. Let's see if you can get help from Visual Studio Code, and we couldn't. So the builder, it just gives us a context, and we need to return our dialog in here. Okay, so let's return the alert dialog. Alert dialog, as you can see here, the title of our alert dialog is provided to us in here is a title. As you can see, it should say text title. And the content should be a text of content. All right. And what else do we have to provide in here? And then we have our actions. So when we go back to our application, so hot reload works. Then for actions, you can see it's a list of widgets. So what we need to do in here is to take our options and then map them. Okay, sorry, the keys, because the keys of our options, you can see, are strings, and they're the titles of our buttons. So let's say options, keys, and then we map them, and then we say option title in here, okay? And then for every one of these, we also have to say toList at the end, because the result of mapping an iterable or a list is an iterable. So then in here, we need to return our buttons. So let's say the final value is from our options, read the value from the option title. So then return a text button. You can see it here, okay? A text button. Then we're going to say onPressed for now is empty. And then the button also has a child. It's going to be a text of the option title. Create the button basically in here, and then we are going to implement the onPress. So let's say that if the value is not null, then we're going to return that value. So we're going to say navigator of the context, then we're going to pop it with the value. Otherwise, we're going to pop without a value. So pop without a value in here. Okay. That's really all we had to do in here. So this is our generic dialog. So if I save it, then we're good to go. Fantastic. That's the generic dialog. Let's go ahead then and implement the auth error dialogs. Remember, we have authentication in our application. So if there is an authentication error, let's say log out, and then I'm going to provide the incorrect credentials in here. Then we get login, and then we say user not found. You see, this is an authentication error dialog. So what we need is to go ahead and implement auth error dialog. So let's go ahead and take care of that right now. So I'm going to close the generic dialog. As you can see on the bottom of the screen, it says dialogs, auth error dialog. So right click, new file, auth error dialog.dart. Okay. And let's go in here and say that we are going to use our generic dialog now. Okay. And this is something that we haven't done yet, but we're going to go ahead and write something called an auth error, which we haven't done yet. But this auth error is going to have some title and some description. It's just any authentication related error that happens in our application is going to be inside a specific class, which we're going to soon implement. We haven't done that yet, but the purpose of this auth error dialog is to work with that auth error and display that to the user using our generic dialog that we just implemented. Okay. Since this auth error dialog is very much dependent on the definition and the implementation of an auth error itself, it's best that we go ahead and implement auth error first. So let's go ahead inside the lib folder here. At the moment we have dialogs. Let's go ahead and create a new file for our auth error itself. So define what an auth error actually is. Here we have, where did it go? We have lib. So I'm going to say new file. And then in here, we're going to go ahead and say blocs / auth block. And then in here, we're going to create an auth error.dart file. Okay, like that. So it should look like this for you as well. So you have your lib folder, blocks, and auth block. Under there, you should have auth error.dart file. And in here, we're then going to implement our auth error. Okay. So for that, we need to basically define a mapping between our authentication errors that come back from Firebase and also the various classes that represent those authentication errors. You see, what we need to do is have our auth errors that come back from Firebase, and for each of those, then we're going to define an instance of auth, which is called here, I can see it's called auth error class. And this auth error class is going to have two very important properties, which is a dialog title and a dialog message or a dialog text. And then we're going to have subclasses of this abstract auth error class for every error that our application can handle. Then we're going to have a mapping between Firebase error messages and instances of these classes. So when a new auth error is raised, then we're going to go inside this mapping. It's going to be like, okay, what is the text or what is the code for this auth error? I'm going to go inside this mapping and extract the correct class that represents that authentication error for you so that we can display it inside our auth error dialog. So let's go ahead and first define our auth error abstract class in here. So let's say immutable. And then I'm going to say abstract class auth error. Okay. Immutable is in foundation. We should know that by now. So let's say show immutable. Okay. Some errors from Flutter 3, but that's completely fine. Then we're going to have dialog title and dialog text properties in here. So let's say dialog title, dialog, and we're going to say dialog text, and then we can go in here and say required string or final string. Okay, so we have our two properties. Let's go ahead and define a constructor for this guy. This is a constant constructor, so curly brackets here, here, and then let's separate these and make both of these properties required. Okay, so that's really good. And what we're going to do is to create an auth mapping in here. So let's go ahead and say we have a const here, which is a map from auth errors of type string. So these are the authentication errors. Then we're going to have an instance of auth error in this mapping. And we're going to call it auth error mapping. And for now, it's just going to be an empty map in here. Okay, but we're going to add more to this or add its contents soon as we have concrete instances of this auth error. Okay. Let's go inside auth error abstract class and create a function that takes in a Firebase authentication error. And for that authentication error, then it creates an instance from this map. Basically, it extracts an instance of auth error from this map. But first, we need to go ahead and create an auth error unknown class in here. We're creating this auth error unknown so that, because you see there's going to be a lot of authentication errors that can happen in Firebase, and we're only going to handle a handful of them. And so if the error that is passed to us as an authentication error is not implemented by us, then we are just going to create an instance of this generic error or unknown error. So let's go ahead and create an unknown error in here. So let's just say immutable, and we're going to say auth error unknown, and then we're going to extend auth error in here. Okay, and then we're going to say const. It has just a constant constructor like this. Okay, and in here we're just going to call super with a dialog title, and we're going to say authentication error. Okay, like this, and then we're going to say dialog text, and then we're going to say unknown authentication error. Okay, and a comma there and semicolon. So you see, this is how we're going to implement these concrete instances of authentication or auth error. Okay, and this is just one of them. So I can see hot reload isn't working. Perhaps we should just go to our application if I can find it. Bring the simulator here. You can see now hot reload is working as expected. Let's go ahead and add a factory constructor to auth error. So let's say then we have a factory auth error like this. The goal here is really just to be able to accept a Firebase authentication error in here. So we're going to say auth error from, and then we're going to say Firebase auth exception, which is going to auto import Firebase auth for us. Okay. And in here, we're going to say exception. And if you're very pedantic in here, you could just say show Firebase auth exception, because we don't need the entire auth package in here. We just need Firebase auth exception, okay? In here, what we're going to do then is to go ahead and say, given this exceptions text, as you'll soon see, we're going to go inside our author mapping and grab that exception code. You see the code is a string, okay? 2 lowercase, and then we're also going to trim it. If we can't find that particular authentication error code inside our author mapping, then we're just going to say return an auth error unknown. Okay, so it's very simple. You can see this factory is very simple. So we can just call that author from Firebase auth exception, and then we get a proper instance of auth error. Okay, great stuff. So that was for unknown. First, we did the unknown. Let's go ahead and say auth no user, no current user. So let's go ahead and implement this guy, auth no current user. So we're going to say immutable. So let me just copy paste this actually. Author unknown. So let's go handle this particular case in here. So author, and we're going to call it no current user, and copy paste it inside the constructor as well. And the error title or the dialog title is said no current user. And the text is also going to say no current user with this information was found. Something like this. Okay, so that's no current user. Good. Let's go ahead and implement requires recent login. And this is a special error. I know that this happens, for instance, it has happened a few times to me where I had a user was logged into the application, and I started the application, let's say after a few days. Then while I was logged into the application, then I tried to delete my account. And then I actually got an error from Firebase saying requires recent login, as if Firebase kind of requires elevated access to or elevated authentication when you're trying to do specific operations such as deleting your account. It just detects that, oh, you haven't logged in recently. You may not even have a valid token or valid authentication credentials. Then it doesn't allow you to perform specific operations. So you have to log out and log back in order to be able to do specific things such as deleting your account, which is kind of like a very serious operation. So that's what requires a recent login representing in here. So since this is kind of like a copy paste of the other auth errors, I'm just going to copy it from the project that I've already prepared so we don't have to type all of these by hand. So you can see in here we have auth error requires recent login. And this is an instance of author. The same way that we did the author no current user, we're doing the same thing in here with a constant constructor and no parameters. It just says requires recent login. You need to log out and log back in again in order to perform this operation. Okay, so that's really good. Let's go ahead and implement operation not allowed. And this is another error that can happen during authentication. I'll paste in here. The code for it is auth/operation not allowed. And we are doing the same exact thing. It's just a different dialog title and a different dialog text. You can see it says operation not allowed. You cannot register using this method at this moment. This happens. It's actually one of the most important auth errors, in my opinion, to handle, because during the setting up of Firebase, you may actually forget to enable, for instance, email and password authentication providers in your Firebase console. If you forget to do that, and then you try to log in with or register even a user with an email and password, excuse me, you will get this error from Firebase saying that this operation is not allowed because, for instance, you were trying to register with email and password and that authentication provider is not enabled. This is not limited to email and password. You can get this as well, for instance, if you're trying to register with your Google account or Facebook, if those providers are not enabled in your Firebase console. Okay. So let's go ahead and implement user not found. And this one is kind of self-explanatory. It's you trying to log in with some credentials that don't exist. Excuse me again. User not found, here we have, and then the dialog title says user not found, the given user was not found on the server. Okay. Let's go ahead and implement weak password now. So we're going to go in here and say auth weak password. And then we have the dialog title of weak password, and then please choose a stronger password consisting of more characters. So again, all of these are kind of explanatory, and you kind of get the idea of why we're doing this. Is every error that can mean something to our application, that is meaningful to our application, is being represented by its own class, and these classes that we're creating in here in their super class, which is auth error, they can contain two properties, the dialog title and dialog text. Then we're going to send these auth errors to that auth error dialog and ask it to be displayed to the user. Okay. Let's implement invalid email. So I'm just going to paste that code in here. It says auth error invalid email and is extending auth error. Okay, invalid email, please double check your email and try again. Then we're going to implement the last error, which is email already in use. And that happens when you're trying to register with a user, which has already been occupied. So that email address has already been registered in the system. Okay, auth error email already in use. Great stuff. Now that we have all of these, we need to go inside our auth mapping in here and basically register these concrete implementations based on their errors. Okay, so what we're going to do in here is to say, okay, for instance, user not found error, and this is something that Firebase has already registered. Like you can find in all of these, like if I open Safari and if I say user not found, like this, and then Firebase, this error is documented somewhere, but it's just very vague sometimes, like how Firebase actually documents these. You can see it's here, right here, it says auth user not found. So inside authentication, the auth / is not going to be passed in the code, except you're just going to get user not found. Okay, so that's what we need to handle. So we say for user not found, we're going to have auth error user not found, like this. And we don't have to define these as const because the entire map is defined as const. Okay, so this is how we're going to do the mapping code and then the class representing that error. So I'm not going to waste our time now and write all of these. I'm just going to paste them. These are all the errors that we're going to handle. You can see user not found, weak password, invalid email, operation not allowed, email already in use, requires recent login, and no current user. And for all of these, we're just going to create an instance of our classes representing those errors. Okay. So these are all our auth error mappings. Excuse me. So now that we're done with this, I don't see actually anything else that we have to implement in here. So it looks good to me. Let's go ahead and go back to our auth error dialog. And in here, we're just going to create a function that can take an auth error and display it to the user. So let's say we have a future void, and we're going to call it show auth error. And this guy requires a few parameters in here. So we're going to say required, or let's say auth error. And this is our auth error. And then we need as well a build context. And we call it context, for instance, in this case. And then let's make both of these required parameters. And let's go and fix all of these. So the auth error needs to come from our auth block auth error. And then we need build context, which should come from material. Okay. And if you're pedantic, again, you may want to go ahead and like say show build context, but I don't recommend this because we're actually going to do some more stuff in here, which requires material as a whole package. All right. Good stuff. Let's go in here and we say, okay, this function returns the result of return show generic dialog, which is going to be auto imported as well, I believe, somewhere. Show generic, no, not show general, show generic dialog. And it's going to be auto imported here. And let's see, dialogs, generic dialog. Okay. The context is already there. And then the title is going to come from auth error.dialog title. And then the content is going to be auth error.dialog text. All right. And then for the options, we're only going to have an OK button in there. So let's go ahead and create the function that returns the options. And in here, we're just going to say OK, returns true in here. OK. So that's really it. It's kind of straightforward in here. And then let's put a trailing comma in there as well to get that to work with the formatting. So show generic dialog, title, content, and then the options builder is very simple. It just has an OK button in here. All right. That's it really for our auth error dialog. So there was not much more to it. It's actually most of the implementation was hidden inside the auth error file itself, because here we have the generic dialog and we have the auth error title and the text. It's just a matter of displaying it to the user. And if you want, you can actually change this function to an error function as well, if you want to. So we can just return show generic dialog like this as well. That's also fine, I would say. Let's go ahead and implement the delete account dialog. So when you're trying to delete your account, we actually display a message to the user saying that, yeah, are you sure you want to delete your account? So let's go ahead and define that as well. It's going to be in lib dialogs, and then we're going to call it delete account dialog. So new file, delete account dialog.dart. Okay. So let's go ahead and say in here that we have a future of bool, and this boolean is going to indicate whether you actually want to delete your account or not. Because if you remember in the original application, a dialog is going to be appearing on the screen saying, are you sure you want to delete your account? And you're going to have a cancel button, which then returns the value of false from this future. And then you're going to have a delete account button, which returns the true value. Then on call site, we're going to grab this true or false value. And if it's true, then we're going to proceed to deleting the user account. So let's say show delete account dialog. And this only needs a build context. All right. Build context like this. Required build context. Great stuff. And it's interesting. Oh, material was already imported. That was really good, actually. Okay. So in here, let's say then we're show generic dialog, auto imported. The context is already there. Okay, so we don't have to pass that. Then let's bring these into separate lines so we get the formatting done a little bit better. For title, we're going to say delete account. The content is going to say, are you sure you want to delete your account? Okay. And then we will just warn them that this is a one-way street. So you cannot undo this operation with an exclamation mark, okay? And for the options builder, we're going to create the function that returns the mapping for it. So we're just going to say cancel, returns false. And then we're going to say delete account, just returns true. All right. Now we're getting this whole thing is like marked as being problematic simply because we're saying that we're returning a future of bool, but if you look at this show generic dialog, it just returns a future of optional of the value in here. So if I say final foo is an optional boolean in here, because remember with dialogues, the user can always dismiss them by tapping outside of that dialog. And on an Android phone where you have these hardware buttons for back, for instance, then you can actually tap on the back button and completely ignore the dialog that's been, excuse me, that's been displayed to the user. So you always have to handle, that is the reason that this function actually returns an optional value, because it cannot guarantee that the user actually taps on any of those action buttons in here. Okay, so let's trail this with a then statement. So when we get the value, we're going to say, okay, we either take the value that is returned from the dialog by the user pressing each one of those or one of those buttons, or we take the value of false. Okay, and that's it really. So there's not much more to it. So that's our show delete account dialog. And for consistency, we can just put a trailing comma in there to get the formatting right. Okay, good stuff. Let's go ahead and now implement the delete contact dialog. And this delete contact dialog is where you have your contacts on the screen and the user presses the delete button on one of the contacts. Since that's also a terminal operation in that you're going to delete the contact permanently if the user actually decides to press the delete button on the dialog itself, then we're going to basically display an alert to the user saying, hey, are you sure you want to delete this user? This is not, you can't undo this operation. As you can see at the bottom of the screen, it's going to be in lib dialogs, delete contact dialog. So let's go in here and say delete contact dialog.dart. And this is very similar to the delete account dialog. So I'm just going to copy and paste the code because we've just written that, to be honest with you. So I'm just going to import this. And as you can see, it says show delete contact dialog. And let's make this actually a required property with the context. Okay. Actually, we don't have to make these required. Let's go back to the show to the delete account dialog as well and remove this required from here. So it just passed the build context directly without it having to have a named required parameter. So here we also get the build context, and then it's passed. As you can see, it just returns a show generic dialog. And in here, it says delete contact this time. Are you sure you want to delete this contact? You cannot undo this operation. Then you have a cancel and then a delete contact. And also we're trailing it with a then so that we can actually return a proper Boolean value in here. All right. After this, let's go ahead and implement the logout dialog. So that is also going to be inside our dialogues. So I'm going to save this file and let's go to our Explorer inside dialogues, lib dialogues. Then we're going to say new file. And in here, we're going to say logout dialog.dart. Go ahead and implement this guy as well. This is a future of bool. So we already have future of bool dialog. I'm going to copy the delete contact dialog and just paste it in here. Okay. Inside the logout dialog as well. So we're going to rename this to show logout dialog. Then the title is going to say log out. Are you sure you want to log out? Are you sure you want to log out? And then the first button in here is going to say cancel, as it was. I don't know why I retyped that. And then we have a log out as well. Okay. And the rest is the same. So log out is going to return true. Cancel is going to return false. And the entire thing is guarded with a guaranteed value of a Boolean, basically. All right. So let's save this guy as well. Okay, now that we've done that, I think we're pretty much done with all our dialogues. So we have plenty in here. We have 1, 2, 3, 4, 5. And one of those is actually a generic dialogue. So we actually have 1, 2, 3, and 4 real dialogues in here. The other one is a utility dialogue that other dialogues are referring to, okay? Let's go ahead now and move on to the next stage in here, which is a little bit more exciting than handling dialogues. And in here, we're going to go ahead and talk about models. As you can see at the bottom of the screen, we're going to talk about the contact model in here. So let's go ahead and implement our contact model. And this contact model is quite a key part of our application because it represents the actual data that the user sees. So there's some logic in it, but not so much. There's pretty much no business logic, really. It's just some logic for instance, when you're creating a contact, then how do we do that? Like when you create a contact, you basically may want to assign a generic ID to it because you haven't even sent it to Firebase for a creation. And when you then read your contacts from Firebase, then those IDs need to be populated inside of your contact. So let's go ahead and do that now. Let's go in lib. We have dialogues helpers, but we don't have models. So right click in here. Then we're going to say inside lib, we have models /contact.dart. Okay. And in here, then let's go ahead and implement or import UUID, meaning that, as you'll soon see. And also we need immutable, but let's just first write immutable. And then we're going to say immutable class contact. And we're going to get an error in here asking us to import foundation. And we're going to show only immutable from foundation. Okay. So that's our contact class. We have a few properties in here. So they're all string. And we need to basically just write them in here. This is what I usually do. I say ID, first name, last name, last name. And then I go and I say phone number. Then in here, I go in here and I basically do a multi-line editing in here. And then I say final string. And then I put the semicolon at the end of all of them at the same time. Okay. And in here, let's go ahead and create the constructor for this guy. So we say a constant constructor, const like this, and put curly brackets and a colon at the end to get the formatting right. And then let's change all of these to required parameters, as you can see in here. All right. So that's for the constant constructor for our contact class. After creating the constant constructor, we can go ahead and create another constructor for our contact class, which allows us to create a contact with an ID that comes from a UUID, yet be able to send this contact to our contacts block, which we haven't developed yet. And we're just going to send this as a signal to our contacts block and say, hey, here's a contact that the user wants to generate. Go ahead and generate this on Firebase. You see, we don't want this task of creating a contact to be a blocking task. Every contact needs an identifier, and that identifier is going to be used in order to allow the user to delete that contact. So if we create a contact we need to always have an identifier for it. But we don't want also to block the user from interacting with the application while we're creating a contact for the information that the user has entered. So during this transition period, we're going to create a contact with an identifier that comes from a UUID. Do you remember that we added the UUID package to our application? And then after this contact has been sent to our contacts block, which we're going to develop soon, the contacts block is going to take this contact, going to go ahead and create it on Firebase. And then it's going to replace that contact in the application with an actual contact with proper ID from Firebase. So for that, we need a constructor here. So let's go ahead and say contact, and then we're going to call this constructor without ID. Okay, so go ahead in here and say we have 3 parameters that are required. So first name, last name, and then we're going to take in also the phone number. Okay, they're all string properties. So let's say required this dot. Okay. And in here, what we need to do, you can see that it says, oops, I think I messed up something in here. So here, we're not initializing yet the ID of the contact. So let's go in here in the initialization list and say ID is equal to const UUID. And then we're going to say v4, just like that. So this is going to create the contact with a UUID as its identifier for us. Okay. The next piece of puzzle that we have to solve is how we basically initialize a contact from data that comes back from Firebase. So let's go in here and create our keys, how we're going to do the mapping between, you see we have 4 properties in here. This one we don't have to save on Firebase because Firebase is always going to give us an identifier for the object that we create. Then what we need to do is to say, we need the first name, last name, and phone number. These need to somehow be saved into Firebase, and we need keys for these values. So let's go ahead in here and create an immutable private class in here. So we're going to call it keys. Okay. And then we're just going to say keys has a private initializer as well. So nobody can initialize it really. So we're going to say keys has a private initializer like this. We're going to create 3 keys in here for our first name, last name, and the phone number. So let's just say static const first name key is first name. Okay. I'm going to copy this and let's paste it in here, and let's say last name and change this to last name. We also have the phone number key. So phone number key, and we're going to say phone number. We have these in place. Let's then go ahead and create the constructor for our contact class that can initialize the contact from an object that comes back from Firebase. And that object is going to be a map of string and dynamic. So let's say a contact that comes from JSON. And then in here, we're going to say required. Actually, this is the JSON itself. So let's say map of string and dynamic. And we're going to call it JSON. And also, we need the ID of this contact, because you see the ID is not going to be placed inside this JSON. The ID is separate. So then we're going to say we also need a required parameter for the ID. Okay. And in here, we're going to say the first name comes from the JSON using the key of keys, first name key as a string. And we're going to do the same thing for the last name. So let's go ahead and say last name comes from there as well. And then in here, we say last name. Phone number does the same thing. So copy and paste. So we say phone number is JSON keys last name. And here, don't forget to change this to phone number. Very important. And we shouldn't really forget to set the key. And in here, I can see that we're saying required string ID, but sorry, I said set the key. I meant set the identifier. So in here, we should instead set this.id. Okay. And this allows us to have the ID for our contact as well in the initializer, in the constructor. Okay. Let's go ahead and create the toString method for our contact as well, in case we're going to log them to the debug console. So in here, I'm just going to say toString. Let's turn this into an arrow function. So let's say that in here, we're going to say $ first name and then $ last name. All right. That's great. What we could also do is that every time we have a contact, so when we have a contact created, we also may want to turn it into JSON. The reason behind this is that when the user creates a contact in the UI, so let's go in here and see how that actually looks like. So in this screen right here, when we log in, oh, it should say .com. When we log in and then go and create a contact right here, when we enter the information, first name, last name, and phone number, and save this contact, this information will then be, we will create then on the UI a contact without an ID. So we will call this function basically. And we will send this contact to our contacts block, which we haven't implemented yet. When the contacts block receives this information, it wants to store that information in Firebase. And in order to do that, it needs a map of string and dynamic for all the keys and values that we want to store in Firebase. Either the contacts block is going to have to do that, or we could let the contact class itself take care of that. So the contact class can be initialized from a map of string dynamic, and it can represent its contents as a map of string and dynamic as well. So it's a two-way street. So let's go ahead and say extension data on contact. And then we say we return a map of string and dynamic. Okay. And then it's a getter called data, and it's a map, as you can see in here. Then we say for the keys of first name, then we return our first name in here. For the keys of last name, then we return the last name property, okay? And we say for the keys of phone number, we return the phone number property here. So this is basically, let's go also back to our application. So hot reload starts working again. So this is really just a two-way conversion, converting, as you can see in here, a map of string dynamic to a contact, and also converting a contact back to a map of string and dynamic. Okay. With this in place, we're done with the contact class in here. And look, I completely understand that in this, excuse me, in this example, in this chapter, we are going to do a lot of work without actually testing this. And the reason behind this is during the implementation of an application like this, we would need to bring up the simulator and test. And a lot of the times we have to implement our application in a very specific way. For instance, we wouldn't be able to just completely write the contact class. We would probably have to start very small, create some properties for it, and then go into some block, add some stuff to the block, then go to the UI, hook the UI to the block, press a button, see what happens. It's a lot of trial and error. And if I wanted to present this example in this chapter in that way, which is more intuitive, and it is usually the way that we as developers actually develop applications, this example would stretch out in time very, very much, maybe 3-4 times more than it actually needs to be. So given that I've already implemented this application, what I'm going to do is to go ahead and implement every class fully and explain to you where those functions and methods and variables are going to be used, so that at least you're not in the dark about that. So just know that this way that we're implementing our application right now is not the way that you would usually go and implement an application. However, the way that we're doing it right now is more fitting for a tutorial video, which is what we're doing right now. And I hope I can bridge the gaps and explain everything that we're writing, but you will need to go ahead and write applications yourself as well using RxDart to completely understand all the logic that we're doing in this chapter, and particularly in this example, okay? After we've created the contact class, it is time to actually start writing some of our blocks. And I've mentioned blocks before in this chapter, and we've actually done a few blocks. However, don't be confused with what I'm saying as blocks with the block package. The block package is something that Felix Angelov has created, and I've done a chapter actually about block. However, it's its own package, but block, as I'm referring to here, is just business logic. So we're going to go ahead and create some block classes, but all they do really is that they're using RxDart to take care of our business logic. So don't think that we're going to drag in at the block library, because we're not going to do that, okay? Let's go ahead now and take care of our auth block. This is going to be the first block that we're going to do in here. And to be honest with you, it's actually a very exciting block, because it's going to take in some signals from the UI saying that I want to log in, for instance, with this user, or I want to register this user, or I want to log out, etc., etc. So to me, this is actually an exciting and a good place to start writing our blocks, okay? If you look at the bottom of the screen, we're going to create this auth block inside the auth block folder. So lib blocks auth block, and let's right click on there and then say auth block.dart, okay? Okay, really good. So to begin with, inside the auth block file, we need some status for our UI to know whether the user is logged in or logged out. So let's go ahead and create an abstract class in here. Let's say an immutable abstract class auth status, okay? And let's create a constant constructor for it. And we're going to import foundation in here. So let's say immutable. Okay, we're going to get some errors from Flutter 3, but that's okay. We're going to ignore those. Great. After we have the auth status, we have two different statuses, basically. One is going to be logged out. The other one is going to be logged in. So let's say immutable, okay, class auth status logged out. And this one extends. Actually, this one's going to implements auth status, because it doesn't really need to extend. And in here, let's go ahead and create a constant constructor for it as well. So a constant constructor for when you're logged out. Then we're going to have a similar one for when you're logged in. So logged in, okay? Good stuff. Now, we're going to also have two commands being sent to our auth block. If you look here, we have, if I go back to this application, we have logout, which is one function, but it's not a command really. And in here, we have a login command for logging in, and then, an auth command for logging in, and another auth command for registering. And both of these have a payload of an email and a password, okay? So email and password need to be packaged together inside a command. And for that, we're going to create a superclass. So let's go ahead and create that as an auth command abstract class in here. So let's say immutable class auth command. Okay, and then this needs a payload. So it's the email and a password. So let's say final string email, and then final string password. Let's create a constant constructor for this guy, const, and it has required properties. Required, and then required here as well. Okay, and then comma to get that to work. Go back to our applications so that hot reload works as well. Now that we have our auth command abstract class, actually we need to turn this into an abstract class because it's not its own concrete implementation. After the abstract class auth command is ready, let's go ahead and create a login command, which is a subclass of this command auth command class. So let's say an immutable. I hope immutable buffer wasn't imported, so let's remove that. So an immutable class login command, and this one extends auth command, okay? Like this. And what we're going to do is to say const login command in here, okay? And we need two parameters, which is the email and password. So we could say required super email and required super password. And I'm just testing this super parameters language feature to be enabled because we're on Flutter 3. So let's go ahead. It says pop spec needs to be updated to 217 or higher. So I'm going to go ahead into our pop spec file, and let's go to our version. In here, you can see it's 216.2. So let's say 217.0. I'm going to save this. And it says pop get running. Good stuff. And then let's close this. We can now see actually the super initializer in here is working really well. So our login command is taking parameters and setting them on the super. And for this, you need Flutter 3. So just remember that this is very important to have. Otherwise, if you are not going to do this, then you can say string email string password, and then you would say super email is email and password is password. This is also fine, to be honest with you. But now that we have Flutter 3 with the super initializers, then we don't have to do all of that code. All right. Login command is in place. Let's create another command for register. So I'm just going to copy the login command and then go in here and then say register command, okay? And then register command. So now we have two separate concrete implementations of auth command, each of which indicates what the command actually is doing. One is doing a login and the other one is doing a registration, all right? Good stuff. Now that those are in place, we need to go ahead and actually create a utility on a stream. So what we need really is, what we're going to do is, you see, we're going to have a global loading indicator inside our application. It's kind of difficult to explain right now, but just imagine that we're going to have an authentication block, and then we're also going to have a contacts block, for instance, okay? And these both blocks could set the application inside a loading state. They could set the application so that it starts to load some content. So you could either, for instance, be deleting a contact, and that could start a loading indicator, or you could start logging in, that could start a loading indicator, or register, that could start a loading indicator. So even though login and register are part of authentication, and the contacts part is part of the contacts block, which we haven't implemented yet, both of these blocks are going to have some sort of a loading stream. So a stream of Boolean that indicates to the application that, oh, hey, I'm loading something. So what we need here is a utility for our auth block that upon any stream firing an event, we need to set a loading on a sync of bool. So as a stream produces a value, let's say it produces a value 1 or 2 or 3, upon the value of 1 being produced, for instance, we may want to set a behavior subject of Boolean to true, saying that, hey, I'm loading now. And then the second value is produced. And upon that, we may want to set this behavior subject of Boolean, indicating whether we're loading or not, to false. So this is a little bit abstract. I completely understand, but let's go and implement it. So we're just going to say extension loading, and we're going to work on some sort of a generic element on a stream of that element, okay? And then we'll return a new stream of the same type, and we're saying set loading to bool is loading. So we take a Boolean value. And in here, we need a required sync of bool, sync of Boolean, I believe, required sync, and sync needs to be imported as well. So let's see if we can ignore. Okay, that's okay. We just say sync of bool, and we say unsync. Okay, so then in here, what we need to do is, let's break this as well into 2 lines. Let's see if we can clean this up a little bit. Dart formatter is not really happy right now because the code doesn't compile really, but that's fine as well. So what we need to do is to say do on each. Okay, and do on each is a function that is on RxDart. So let's go and import RxDart. So since our extension is on a stream, then there is a handy function that RxDart provides to us, which is called do on each. So every time the current stream produces a value, then our do on each is going to be called, okay? We're going to ignore the incoming notification in here, and in there instead say on sync, and then we're going to add is loading, okay? Just like that. So great stuff. And put a colon in there so we get the formatting right. So you can see basically do on each, you can get the documentation for it, and it says invokes the given callback function when the stream emits data. So it's very easy. So as long as this stream that we're working on right now, we're creating our extension on, produces, as soon as it produces value, then if we've added this set loading to upon that stream, then we can set a sync to a specific value. So let's have a look at an example. So if I here go and say test, and then I create a stream. So let's say this is a stream of periodic const duration seconds 1. So this is our stream, okay? Then I can say result is a stream, and then we can say set loading to true on a sync. So let's say controller stream controller of Boolean. We just create it like this, and let's import Dart async for now. Then in here, I can say controller sync. So this means that, and you can see the result is actually a stream of dynamic, exactly as this stream. So the data type didn't change. So if this guy was a stream like this, so it was actually a stream of integer, then result would also be a stream of integer. So our set loading to, all it's doing really is, as soon as this stream, and every time this stream produces a value, it's setting the value of true on this particular sync. Okay, so hopefully this example clears up a little bit of a confusion maybe about this extension function. And look, I completely understand this is combining two very scary subjects for some developers. It's combining generics and asynchronous programming. But to be honest with you, if we look at it, it's just a simple function. It's not doing so much. It's reusing an existing function, and in there, it's just adding the given value to the given sync. So if you pause the video here and think about it, this is really not scary, okay? But I know that it could be perceived as scary if you haven't worked with this type of function before. So that's completely understandable. Let's go in here and start working on our actual auth block in here, okay? So exciting stuff, complicated stuff sometimes, but I will try to, I really do my best to explain everything as much as I can, okay? So let's create an immutable class in here, and we're gonna call it auth block, all right? And make sure that, I don't think we need Dart async import, so our imports are gonna be foundation show immutable and RxDart up to this point at least, okay? But we may need to import more stuff in here as we go on. Okay, so what is the purpose of our auth block? So this auth block really, what it needs to do is needs to hold on to a few things, a few states, and it also needs to expose some syncs to the UI so that the UI can communicate with the auth block, all right? So the first thing is the auth status, whether we're logged in or logged out. And remember, here we created our auth statuses, as you can see in here, auth status, okay? Auth status logged out, auth status logged in. So let's expose an auth status to our user interface. So we're gonna say final stream of auth status, excuse me, and this is gonna be our auth status. So that's the first property. Then we need to expose an error to our user interface. So remember, if we go here to the user interface, which we'd created before, if I try to register the same user that I'd registered before, press this button, I will get an error. So this is an auth error that is produced by our auth block, and we're going to put it inside a stream. However, this auth error could be null, so or nil if you're a Swift developer, for instance. So we say final stream auth error. So this is going to auto import auth error for us. So and as an optional, and then we say author. Okay, so this indicates whether an auth error has happened or not. Let's go ahead and implement then, or add the property for is loading. Okay, so when we're logging in, let's go here. You see we start loading. That's the auth block indicating to the UI that, hey, I'm loading something in here. So let's say a stream of Boolean, which is called is loading in here. Okay. What we also want to do is to expose a user ID stream. So if you're logged in, then you're going to have a user identifier. So let's say a stream of string optional, and this is a user ID. Then we're going to expose, so these are like the read-only properties. So let's say read-only properties. And then we're going to have write-only properties, so that the UI or our application is going to interact with our auth block using these write-only properties. So write-only properties, which are using Rx, they need to be syncs. Okay, so a sync property. So let's go in here. The first property that we're going to expose is for logging in. So let's just call it login. Somehow the user should be able to log in. Somehow also the user should be able to register. Okay, and also the user should be able to log out. So let's go ahead and think about the data types for login. So final sync, we know it should be a sync. Okay, so let's make all of these syncs. But what is this login a sync of? What property, what data is the UI going to have to send to us for the auth block to understand that, hey, you want to log in? And that is right here. we said that we have an auth command, which is a login command. Okay, and then we have a register command. So let's go for login and say this is a login command. And for register, we say this is a register command. For log out, there is no payload. So this is going to be void. All right, so let's put our semicolons in there. And this is good to go. Now that that is done, let's go back to our application so hot reload starts working. What we need to do is to create a constructor for this class. So I'm just going to get Visual Studio Code to create this constructor for me. And I'm going to make this a private constructor because we don't want the UI to construct an instance of our auth block like that. We are going to use a factory for that. Okay, so this is a very common pattern when you're doing RxDart in that you have a private constructor and then you have a factory constructor that takes in some parameters and then creates an instance of your auth block, because the UI is not going to be able to create an auth block and provide all these sync properties to our auth block. It's the job of the auth block itself to provide those things using a factory constructor, okay? So let's put curly brackets in here and another curly bracket right there. And like this, and let's turn all these properties to required properties, okay? So let's go here and say required and make this constructor as well a constant constructor. Good stuff. So that's for the constant constructor of our auth block. After the constant constructor of auth block, let's go ahead and implement the factory constructor for auth block. In this factory constructor, we're going to do a lot of work. And really, what you need to know when you're doing these factory constructor for your auth blocks, when you're using RxDart, is that you need to calculate these properties. So you always have to think about, okay, auth status, what is this? It can either be logged out or logged in. So how do we calculate that? So you need to produce either an instance of auth status logged out or auth status logged in. And Firebase authentication has good properties and methods for calculating these things internally. So let's go ahead and import Firebase auth in here. So let's say Firebase auth, okay. And let's go inside the factory constructor for our auth block in here. And this factory constructor is not going to take any parameters. So let's just say factory auth block. It's just an empty factory constructor for now. Okay. The first property that we're going to define is a behavior subject of Boolean, which indicates whether this auth block is loading or not. Okay. And that is right here, is loading, which is a stream of bool. Okay. So let's go in here and say that we have a final is loading property in here, which is a behavior subject because we want to read from it and write to it. Okay, so it's the behavior subject of Boolean like that. Now let's go ahead and say calculate auth status. Okay, so then we say we have a stream of auth status, which we have to calculate, which is right here, you see, auth status. And this is equal to, let's call it auth status changes, actually, auth status changes. All right, and this is equal to Firebase auth instance, and then there is a function called auth state changes, which already it basically exposes a stream of user. So as the authentication status of a user inside your application changes with Firebase, so when a user logs in or registers or logs out, etc., this stream sends new events, and in here you can see the properties or the element of the stream is an optional user. So if there is a user in that stream, it means that you have logged in. If there is no user in that stream, it means you are not logged in. So let's take that auth state changes, and we need to map the result of this, which is an optional user, to an auth status. So let's just say map, and in here we say user. Let's turn this into a curly bracket function in here, and let's say if user is null, all right, or actually if it's not null, then we return auth status logged in, or what do we call it? Logged in, all right, which is a const as well. Otherwise, we return auth status logged out. So very simple. So we are mapping an existing stream to a new stream. And this is really like one of the pillars of RxDart or Rx in general. You're just playing with data types. Here's a stream of some data. We're mapping it to another data. This is just like a game. It's you take something and you output something else. So it's quite simple, to be honest with you. at least in my opinion. And I think it will be very simple for you with more practice as well. Good. We have the auth status changes in here. I'm going to remove that comma. It looks better with this formatting than this formatting, in my opinion. Let's now get the user identifier. Okay, so let's go ahead and say we need the user ID because we need to expose it in here. If you look at the one of the properties of our auth block, which is a stream of user ID. Okay, and we're going to get that actually from the same stream, which is auth state changes. So let's go ahead and say get the user ID. Okay, and then we're going to say final stream of string. And this is going to be our user ID. Use Firebase auth instance as well. Okay, so let's say instance, and then we're going to say auth state changes. And then we're going to map that. So given a user, remember this is an optional user, so it looks like this. It's data type. Okay, then we say user dot UID, which is the user identifier. And the result of this is actually already an optional string. Okay, you can see it's not complaining about anything in here, and we could remove this data type. However, what we also want, remember the auth state changes, as its name indicates, it sends an event in the stream when the auth state changes. So let's say that you were logged into the app previously, and then you completely kill the app. So you remove it from the task manager on your Android phone or your iOS. So, and then next time you open it again, then there is no auth state change because you are already logged in and you will stay logged in. So this stream is not going to produce a new element. However, we're interested in the current user ID and all changes to the user ID in the future, meaning that we need to kickstart this entire stream with the current user identifier. So let's go in here and right after that, say start the entire stream with, this is an operator, remember start with, we're going to say started with Firebase auth instance current user as an optional user ID, UID. Okay, so this looks a lot better basically. So it looks at all the changes in the auth state and then grabs the user ID based on those changes and starts the entire stream with a current user ID. Okay. Okay, let's go ahead now and take care of logging in and error handling. So let's say login and error handling, or plus error handling. So for login, we're going to have, you see in here, we have a sync for login. And we know that for us to be able to expose a sync, we need kind of like a behavior subject. Okay, so let's go ahead and create a behavior subject in here. So we say login is a behavior subject of logging command. Okay, so we expect logging commands to be sent to our auth block. And if we get a login command sent to us, we need to also expose the login errors. So let's see, we have an auth error in here, you see? So let's go ahead in here and say we also want to get final stream of auth error. So this is going to be our login error. Okay. What we're going to do is first we're going to wait for the user or for our UI to send a command to the sync of this login. Remember, we're going to send this login as it because it has its own sync, right? It's read and write. So login sync, right? We're going to send the sync of this login to this sync right here. And when the UI sends a message to this, then we're going to get an element sent to this. So it's kind of like you're passing a write-only version of your login behavior subject to your UI. The UI writes to it, and then you get that element right here in your block. Okay, so let's say we get this command in here. As soon as the user or the user interface in this case says that I want to log in, what do we have to do? We have to start loading. So let's go ahead and say set loading to true on our is loading. Okay, great stuff. So that's the first part. Is loading is also sync, but you could also write sync in here, but I think if you just say is loading is fine as well. And what we need to do is upon getting this a login, let's actually remove the data type for this for now so that we don't get so many errors. Okay. Upon the login command being sent to us, we have to do some asynchronous work. So you get an element on a stream and you want to do some asynchronous work, then you have to use your switch map in here. Or let's actually see, switch map is going to return a stream, but we want a future. So let's say async map. Okay. So you can see in here, we take a login command in, and then we have to return a future. Since logging in Firebase is handled with a future, then we're going to use async map actually in this case. So let's say async map. And in here, we have our login command. Okay. And what we're going to return at the end of this is an auth error. Okay. Let's go into a function in here and say this is an actually async function. Okay. So we create a try block in here and we say on Firebase auth exception. And then in here, we catch E in here, right there, okay? Then what we'll do is we will actually return an auth error from our exception, okay? And then we'll also do a generic catch in here. And we'll say return const auth error unknown, right? Because remember, this is an async map. Its only job is to return an auth error. However, internally, is actually going to, inside the try statement, is going to try to log you in. So to me, this is the beauty of Rx, because you're basically making some API calls in here. You're logging the user in. However, you want to return an auth error based on your logging the user in. So you're playing with data again. Remember this, Rx is nothing more than just you taking in some commands and then, or receiving some elements and converting those elements to something else, or maybe either synchronously to something else or asynchronously to something else, all right? So let's await on Firebase auth instance, and then we want to sign in with email and password, okay? And then we have the login command email, and we also have the login command .password. Okay, let's put these in here, and let's see how this guy looks like. And in the case of this, in the case of us awaiting for signing in, if there is no error, then we're going to go to the next line and then return null. So you see what we did in here. We said if signing in is successful and we're not going into any of these exception blocks in here, then we'll return null, meaning that there was no auth error. Okay. After all of this is done, we also have to turn off the loading indicator. So let's go ahead and say set loading to false on R is loading. All right, great stuff. So I'm going to remove now this commented out code right there so that we know the data type for login errors is in fact stream of auth error. Okay. And you don't have to write this, to be honest with you. You could just remove it. But in these cases where we have a lot of stuff, complicated pieces of code, Rx code, I prefer sometimes to have my data types indicated before my variable names or these final properties. It just gives me a little bit more peace of mind, because let's say that we remove this from here and we don't have that there. It's very easy then for someone to go and change this and in here return hello and then another empty string in here. Everything just works. Everything looks fine. Okay. However, this is not what you want. You don't want to stream a string as an optional. So it helps to specify the data type you require for your variable. And so that if someone goes ahead and messes something up in here, like returns 1, then they're going to get an error saying that, hey, 1 is not compatible with an optional auth error. So it's a preference, but also I want to tell you the reason behind that preference. It just makes the code sometimes a bit more readable. Okay. So, excuse me, we did the login, and the register is very similar, except that instead of taking a login command, it takes a register command. So I'm going to copy this entire login block, including its comment, like that. And I'm going to go here and paste it. So instead of saying login plus error handling, let's just say register plus error handling, and then change this to register. Excuse me. We take in a register command. And after taking the register command, let's go ahead in here and change this from login error to register. Okay. Then we take register in here and set loading to true, async map auth error. And then instead of saying login command, let's change this to register command. Okay. And in here, instead of saying sign in with email and password, we're going to say create user with email and password. And to be honest with you, everything else stays the same. So all of a sudden we have our register and login created for us. So including the behavior subjects, which are going to be used for the sync. Okay. Let's go ahead and implement logout now. And logout is very similar also to login and register. So let's go ahead and copy this register from here. Boom. And I'm going to copy this part as well. Okay. So I'm going to paste it here and let's just call it logout. And let's say logout behavior subject a void in this case, because logout is just a void command. It has no payload. In the register, instead of register error, we're just going to say logout error. Okay. And what we're going to do, we're setting the loading to true, and then we're async mapping. Instead of register command, we're just going to say logout command. Okay. But we know that logout command is already a void. So actually, let's see why is it saying register? Here it should say logout, right? Logout. This is void, so we don't need to really read it. You could just completely ignore it if you want to. Okay. And in here, what we're going to do inside the try, we're just going to say await Firebase auth instance sign out. Okay, which is a future of void. All right. And then we're returning null in here. And then if we get any exception, then we're going to return as auth error as well. So you can see the code is very similar in all three cases: login, register, and logout. All right. If you want to be creative, you could go ahead and make this even more generic so that the skeleton, which is this part, this part, this part, and then this part, this part, this part, is reused between them. So the only difference really between these is that there are two differences between these three pieces of blocks that we've written: login, register, and logout. The difference is that the two differences is that they start from a separate stream. So this one starts with logout, this one starts with register, this one starts with login. And the second difference is these pieces of code in the try statement. All right. So here we're signing in. Here we're creating a user. Excuse me. And here we're logging out. So we're signing out in this case. So if you want to, go ahead, please, and maybe create something more creative in here. Good. Now you can see we have three streams of auth errors. So this one indicates any possible auth errors during logging out. This one indicates any possible errors during registering, and then this one for during the login. So if you look then at the properties that we have in our auth block, we just have one auth error. So how do we do that? How do we take three auth error streams and put them together? So we say anytime any of these streams sends a value, I want to collect that in an output. Again, think in terms of Git. Let's say you have three branches, and then what you want is any commit that is produced on any of these branches, you want to get that in your branch. Well, the answer is that you merge them. So you have three branches, you want to merge all the commits in those branches into one branch, and the result is a merge, is a simple merge. It's not a rebase, it's a merge. So let's go ahead in here and calculate our auth errors, okay? So let's say auth error, let's put a comment in here and say auth error is equal to login error plus register error plus logout error, okay? So we say final stream of auth error, which is an optional, and we say auth error is rx.merge. And in here, we have a list of, or iterable of auth errors, which is login error, and then register error, and logout error. Okay. So you see, we created a merge of our authentication errors and put them in author, and this is the value that we're going to pass to our constant constructor. You may be surprised, but we're pretty much done with the authentication block. So what we need in here is just to return an instance of our auth block. So let's say auth block, we want to return this. Put a comma at the end to get these properly set. So auth status, as you can see in here, we need to pass that to our constructor. But we have something up here which is called auth status changes. So that's the stream of auth status. So we could actually call this auth status as well, like this. And it gets passed here, auth status. And auth error is coming from here, you see. Let's put a comma here to get the formatting right as well. Auth error is loading, it's coming from here. User ID is coming from, I believe, here. You see as a stream of optional string. And you can see it was just plug and play. I didn't have to change anything. The only thing we had to change was just auth status changes. We just changed it to auth status. And the rest is just really plug and play, you see. So it's great stuff. And we could pretty much say that we're done with the auth block. That was it, okay? With the auth block out the way, we can move on to the next component of our application. Let's go ahead and bring up the next caption, which is for current view. And in here, you see when our application is moving from view to view, it is not actually the UI that is making that decision. It is going to be one of these blocks that we're going to implement, which decides then based on the current conditions of the application, which view should the user be in. And for that, first we need to define the different views that are present in our application. And that's what the caption at the bottom of the screen says as well. As you can see, we're going to go into lib blocks, and then we're going to create a new file under blocks. So I'm just going to right click on blocks itself, and I'm going to say this new file is going to be placed inside a folder called views block. And in there, we're going to have a current view.dart. In current view, we're going to just define an enumeration. So this is the current view.dart file. It defines the various views our application can be in. So let's just say enum current view, login, register, and then we're going to have contact list, and then we have create contact. Okay, so these are the various screens that we can be in. So let's go in here into our application so that hot reload works as well. So if you put a trailing comma in here and then save the file, then we can see Dart formatter formatting this enumeration a little bit more nicely. Okay, that's our current view.dart file. Once we have the current view.dart file, we can go ahead and start working on the block, which is for our views. So it decides, this block is going to decide which view the user has to see. And we're going to call it just convening a views block. Okay, so I'm going to save this file and close it. Let's go back to the Explorer. And as you can see at the bottom of the screen, we're going to create a views block right here in this views block folder. So new file, views block, if I can spell, art. And in this views file, in this views block, we're just going to go ahead and immediately start creating our views block class in here. So an immutable class, and let's call it views block like this. Let's import a foundation for this immutable in here, show immutable. Okay, some errors from Flutter 3, that's fine. Good. And in here, what we want is a two-way communication. So the UI should be able to, the application block soon, as you'll soon see, the application block, which is going to be a block that we haven't implemented yet, which is going to wrap around the auth block, the views block, and the contacts block, is going to then have some logic in which it's going to decide which view the user has to be in, not the UI itself. The UI is not going to make that decision. So this umbrella app block, which we're going to develop soon, needs some way of telling the views block which view it has to go to. So we need a sync for that. Remember, sync is write only, so it's like a communication channel into the block. And also, likewise, the UI needs to know which view it has to display. So we need a stream, a read-only copy of the same sync, kind of. So inside this views block, we're going to have a behavior subject that drives both the sync and the stream. So let's go and implement that right now. So we have a sync in here, which is our current view. Okay. And let's also import the current view. And this is go to view. So this is a command coming in. As mentioned before, sync is write only. So there's a channel for anybody from outside the views block to dictate to the views block what it has to do or which view it has to go to. And then we're going to have a stream that indicates which screen we're actually in. So stream of current view. And this just says current view. Okay. Whenever you have a sync, we need to ensure that we're actually closing these syncs. And it's important that we actually go to our auth block as well and ensure that we've implemented the dispose function on it. So because in here, as you can see, we also have a few syncs. So we have a sync login, register, logout. And I don't actually see any dispose function in here right now. So let's go in our auth block and implement the dispose function before we forget, okay? Wherever we have syncs, we have to close those syncs. So let's create a void function in here, call it dispose, and we just say login and close. You need to basically close all your syncs. Register, close, okay, and then logout.close. So this is a little bit of a curveball that came in, but I just thought about it and I thought, okay, maybe the auth block also has some syncs which we have to close, and that was exactly the case. So it doesn't have a dispose function. It didn't have a dispose function. Now we've written that, okay? So now let's close auth block and go back to our views block. And before we create the constructor for this, let's just go and do the dispose function in here. And inside dispose, we're just going to have to close all the syncs, which in this case is only one. So go to view needs to be closed in here, okay? Excuse me. Let's go and create the constructor for this guy. So I'm just going to say a constant constructor, put curly brackets here and here, and a comma, save this, and then we're going to say both of these are required parameters. Good stuff. Now, the constructor for this views block is there, but as we've mentioned before, we need to ensure that all these constructors, which are created for our blocks, which have syncs and streams, that they're private, and we're going to actually create instances of these blocks using factory constructors. So let's turn this constructor into a private constant constructor instead, okay? Then we're going to go and create a factory in here. So we're going to say a views block, okay? Just like this, it doesn't have any parameters, okay? So let's then go in here and say that we want to basically have a behavior subject that dictates, okay, which view we have to go to, and then also it returns the same view back to the user, okay? So in here, let's go ahead and start defining that behavior subject. And the implementation of this factory constructor is going to be really easy in here. So let's just go ahead and define our behavior subject. So we're going to say final go to view subject, and this is going to be a behavior subject of current view, behavior subject of current view, okay, like this. And then what we're going to do is just to return an instance of our views block in here with the private constructor, and the go-to view, which is the sync in here, you see, is going to be this guy, go-to view subject. And if you're pedantic, you can just say sync in here, but a behavior subject itself is a sync, so you don't have to convert this. And then the current view is going to be very interesting because a behavior subject here, as you can see by default, it doesn't have any default values in here. So if we return this in here, you may think that, well, it works, but we don't then have any current view when the application lands on, for instance, when the application gets started for the first time. So you need to add some value somehow to this go-to view subject. So you could either say this guy sync add, and you can add a current view, for instance. You can say, oh, we always start with the login screen. Or you could say, well, the current view, which is the read-only version of our behavior subject, which is here, that should have a value. So you could say this guy, if you go in here, go to view subject, and then in here, we then say start with. And since start with is in RxDart, we have to import that. So if we say start with, and then we say current view.login. All right. So you can see what's happening in here, and that we have our views block, a behavior subject, a read-only copy of it for, a write-only copy of it, so that our app block, which we're going to write later, is going to tell the views block which view to go to. And here we're only having a read-only version of the same subject, and it always starts with the login view. Okay, so that was really it. There is not much more to write in our views block, and in here we can remove the subjects in here. It was auto imported when we worked with this behavior subject right there, okay? Okay, now that the views block is done, we can go and move on to the next component, which is our contacts block. And this is actually a very exciting part of our application. So let's go ahead and start implementing this guy, because it is actually quite quite a lot of code. It's not complex, but it is going to be quite a meaty piece of code. And by that, I mean that we're going to actually do quite a lot of Rx in there. And to me, that is actually exciting. So let's go ahead and start implementing this guy. So in lib blocks, and we're going to create a new block in here, which is called contacts block. Okay. So in here, we have the views block and auth block folders, and they're folders because there's more than one file in them. But the contacts block is just going to be one file. So let's right click in here, and we're going to say contacts block.dart. Okay. Good stuff. Now that we have our contacts block in here, let's go ahead and import a few things in here. We need Dart async, so import. Then we need to import Flutter Foundation. We also need to import Cloud Firestore, because that's how we're going to actually store our contacts inside Firestore using Cloud Firestore. We need RxDart, okay, of course. And last but not least, we actually need a contact model, which is contact, let's see. And I can see we actually haven't, or have we created the contact model? We probably have. Let's go into our models, and I can see there's a contact Dart in here. So let's see if we can import that contact.dart. It's interesting that it's not recognizing that. So if I say in here models, and we can say perhaps contact Dart. Okay. After the importing of these packages, we need to go ahead and do two type definitions. And these two type definitions, actually, they're not so essential to the working of our contacts block. Is that they're just going to help us write a bit cleaner code. Sometimes it is, and this is kind of like a preference, if the data types that I'm using in my applications are quite long to express, like there's maybe more than 20 characters to write for a data type, then I can create a simple type definition for that, especially if those data types are using generic types inside them. So then I can refer to those generic parameters and their data type with a simple data type that has no generics in it. And in this example, in this context block, we're going to do two type definitions. One is for a document snapshot, which comes from Firebase, and which is like a snapshot of a series of documents. And then we also have a document itself, which is going to be a document reference. Okay, so let's go in here inside our context block after these import statements, say type def a snapshot, a private snapshot, and that's why we have this underscore in here, snapshots, is a query snapshot, okay, of a map of string and dynamic. So this is so basically a query snapshot of a map of string dynamic is like a series of documents, basically. So snapshots, that's why it says snapshots as plural. Let's then go ahead and define every document on its own as well. So we're going to say every single document is actually a document reference, and it's a map of string dynamic, okay? Like that. Good. After the definition of these two type definitions, after the creation of these two type definitions, perhaps we could say, we need an extension on stream. And I'm so used to other Rx implementations as well, like RxJava and RxSwift. So for instance, RxSwift, you can have an extension on stream that allows you to unwrap it. And what that means really is that if you have a stream of optional values, let's say that you have a final stream of int optional in my stream, okay, like this. And in here, you can see that this stream can carry with it optional integers. So it can carry with it the value of 1, 2, 1000, and can sometimes also carry with it the values of null. So let's say that this stream produces these values, so 10, 20, 100, 1, 2, and then all of a sudden null, and then 3, 5, or 3, 5 null. And if you want to convert this stream instead to a stream of integer so that it doesn't contain any nulls, then it would turn into a stream that just doesn't have null values in it, like this. So we need an extension on a stream that carries with it optional values so that we can get rid of all those optional values, okay? So we're going to use this on wrapping in 3 different places inside this file. So let's go ahead and implement it first. So extension unwrap, and we're going to say we're going to work with a data type of T, and this is on streams that carry that data type but as an optional. Okay, our return value is the same data type, however not as an optional, and we're just going to call it unwrap. Okay, and what we're going to do in here is very interesting, because we're going to use the switch map operator, which, as you can see, it returns a stream for any values that the current stream actually produces. So let's go into the switch map, and let's say this is optional value, and let's turn this function into an async function itself, so it can return a stream using yield. Okay, and we go in here and we say if the optional value is not null, then yield that optional value, as you can see in here. Okay, very, very easy, basically. So using yield, we're producing a new value inside a new stream, and since switch map is turning every element in the current stream into a new stream, then we're basically doing as I mentioned in the little diagram that I showed you just now. So you can see the result is also a stream of T. So you can pause this video and have a look at this code. I know it's a little bit strange. I mean, it's strange looking, but it makes perfect sense, because yeah, we're creating an asynchronous generator whose result basically is a stream. Because you see, you can actually create async generators like this as well. You can say a stream of int and my stream, and then you can see that this is an asynchronous generator, and then you can say yield 1, yield 2, etc. Okay, so now that that is done, let's go ahead and actually start working on our contacts block. So I'm going to say an immutable class contacts block. Okay, so this is going to be a meaty class, so there's going to be quite a lot of stuff in here, but that's fine as well. We're going to go through it one step at a time. So the first thing that we need in the context block is for a way to from the outside of the context block to get to know whether we have a user ID or not. Okay, so let's say a sync of an optional string, which is for our user ID. So someone has to tell us what the current user ID is, and that's not the job of the context block. That's the job of the auth block. Okay, and we'll soon get to that part where we actually glue the auth block to the context block through a third block, which we're going to call an app block or something like that. Okay. Then from outside the context block, we need a way to tell the context block that, hey, create a contact now. Okay. So from the, we have this screen where the user can create a new contact. So let's go in here and let's go in here and log in. Then we go to the creation of a contact with the floating button in here. So this screen somehow needs to save a contact. So it needs to send a signal to the contacts block and say, hey, go ahead and create a new contact. Okay. So let's say we need a sync of a contact, and we're going to call this guy a create contact. This is a signal someone sends us and say, hey, go ahead and create this contact. Similar to this one, we need a delete signal. If we already have a contact in the list, this delete contact button needs to send a signal to us and say delete that contact. So let's just say we have another sync in here, which is called delete contact. Okay. Then we also need to return a series of contacts. So let's go in here and say we need a stream of iterable of contacts in here, because inside this list, I mean, that's what is going to drive this list. So a stream of an iterable of a contact. So anytime you create a new contact or delete a contact, this stream is then going to reflect that change. So the UI is just going to read this stream, okay, and display the list of contacts in here. So let's call this stream contacts, okay? What we also need is, as the user tells us that, hey, you need to go ahead and create a new contact, or you need to go and delete a new contact, we need a way to actually perform that work. You see, in Rx, you have this concept of hot or cold observables. I'm not going to go too much into details about that, but you just need to know that a cold observable is an observable that starts producing values, for instance, as soon as you subscribe to it. And then you have Actually, I shouldn't say observables, but streams rather. RxDart has chosen not to use the word observable. However, a lot of other Rx implementations, such as RxSwift, they use observable, which in the RxDart world is a stream. And stream is actually a word that, or in the world of Flutter and Dart, stream is an observable. So we keep that word inside RxDart as well, instead of just inventing a whole new observable object, okay? So let's just say a cold stream is a stream that starts producing values as soon as you start listening to it, or as soon as you subscribe to it. However, a hot observable produces values, or hot stream produces values even if no one is listening to it, okay? So what we need in here, since we have a create contact signal and a delete contact signal coming to us, we need someone to listen to these signals and say, hey, I know that you want to create a new contact, and I know that you want to delete a contact. I'm going to start listening to these commands and do as you say, all right? Since no one from outside the contacts block is going to listen to these signals, it's actually the contacts block itself that's going to start listening to these signals, we have to have subscriptions based on these two. So for every one of these things, like these two things, we need to have stream subscriptions. So let's go ahead and say we have a final stream subscription in here of a contact, okay? And in here, the stream subscription of contact, we're going to call it create contact subscription, okay? And then we're going to have another stream subscription, and this is going to be a void this time, and we're going to say delete contact subscription, okay? So this is for deleting a contact. At the moment, we're just keep it void. We don't have to have it as a contact, and you'll soon see why. So just remember, your stream subscriptions is a way for you, I mean, as their name indicates, you're subscribing to values that come from a stream, okay? I know it's a little bit strange, but maybe if I just showed you a value, an example in here, you would see what I mean. So let's create a tested function. You don't have to do this at home. So I'm just gonna show you something in here. So let's just say we have a stream, final my stream, and that is equal to stream, and we're gonna say periodic, okay, and the period is a const duration seconds 1 and seconds. And this is just going to produce integers, okay? So let's just produce integers. So you can see now my stream is actually a stream of int, all right? Now, if I say final my subscription is my stream, and then we're going to say listen, okay? And in here, we're just going to close it. Now you'll see that my subscription is actually a stream subscription of integer, okay? So that's what we're doing in here. So we're listening to events that come from a stream. And here we're going to do the same thing. So there's going to be some sort of a stream of contact that's going to back this sync in here. And then we're going to say, okay, as soon as that stream sends a new value, we're actually going to listen to that and do something with it, okay? And then we're going to save that something inside this stream subscription. So if you see the stream subscription, just know that we're going to do some work for events that are being sent in some stream. Just that for now is enough to know, okay? Good. Let's go and create the private constructor in here, all right? So in here, I'm just going to go ahead and get Visual Studio Code to create the constructor for us. And let's change this into a constant constructor and a private one for that, okay? And then curly brackets in there. Great stuff, and a comma, okay? Let's turn all these parameters into required, and then we're gonna have a little bit of a problem, excuse me, with these two particular properties because they're with underscore. So what we're gonna do is to say, okay, we have these as separate parameters like this, and another stream subscription void in here for this, boom. And then it says all final variables must be initialized. So let's go ahead and initialize them with an initializer list in here. So we're going to say our private create is equal to this parameter that comes in, and our private delete is equal to this parameter that comes in, and then the error is going to go away, okay? So that's for our constructor. You also know that the value of the field create isn't used. All right, that's fine. We're going to use that. I don't know why it's picking on these two particularly. All right. Wherever we have sinks, remember, we have 3 sinks in here. We need to ensure that we're actually disposing of them. So let's go inside dispose function in here, or we're going to create a dispose function because this is not like overriding a dispose function. Okay, let's say user ID close. Okay, and then create contact, close. And then you could say delete contact dot close, like that. All right. Good stuff. So now that we've done the dispose, we're actually going to go and do the meatiest part of our contacts block implementation, and that's the factory constructor. So right after the private constant constructor, let's go ahead and create a factory constructor. Let's say factory contacts block. And in this contacts block, we're going to refer to Firebase Firestore quite a lot. So let's add it as our backend in here. So we're going to say Firebase Firestore instance. So this is our backend. So instead of everywhere referring to Firebase Firestore instance, we're just going to say backend dot. All right. So that's a little bit of a handy little variable, we could say. Okay. So now with our user ID, let's go ahead and say that we have a behavior subject for our user ID. And remember, our user ID behavior subject is going to be the backing behavior subject for the sync. So from the outside, we could actually get this. We can send a user ID into our contacts block, and then the contacts block is going to save that inside a behavior subject. So let's say user ID, and we'll say final user ID is a behavior subject of an optional string, okay? Because we may not have a user ID. Okay, and what we need to do then is to start calculating upon the changes to our user ID. Then we're going to retrieve our contacts, okay? So let's say upon changes to user ID, retrieve our contacts. So now that we have a stream of user ID in here, for every user ID that is produced inside this stream, we need to go ahead and grab the contacts, okay? So let's say in here, the result of this guy, so we're going to say a stream of iterable of contact in here, okay? It's going to be our contacts, which is going to be equal to user ID. Every time user ID produces a new value, we're going to switch map it. So in here, let's just call this user ID. And remember, when you switch map user ID stream, your user ID is going to be the optional value, which is what your behavior subject is carrying in here. Okay, so user ID is optional, which when you switch map is also optional in here. Okay. So the switch map is then going to produce our snapshots in here, okay, like there. And snapshots, as you remember in here, is our type definition. So all we're going to do in here is if there is a user ID, we're going to go to our backend, which is right here, and say, hey, read all the contacts or read all the document snapshots for this particular user, okay? So let's go in here then and then start a proper function. And then let's say if user ID is not null, or actually let's just do null first. If the user ID is null, then we're going to return a stream of our snapshots, okay? And we're going to say empty. So you see, it's just going to be an empty stream. It's not going to have any values at all, all right? So that's our way of saying that, hey, if the user hasn't logged in, if there is no user ID, then we don't have any contacts to display to the user. And this empty is really, really useful for that. So what empty operator does in here, let's go in here. It's actually a factory constructor for a stream. You can see in here that it is a stream that never produces any values. It's just empty, all right? Otherwise, if we do have a user ID, then what we need to do is just to go to a collection inside Firebase Firestore with our user ID as the name of the collection, and then grab all the snapshots out of there. So let's say then we say our backend with the collection of this user ID, then we're going to say, give us all the snapshots. All right. And all of these, I mean, this is giving us a lot of problem right now. And I believe that's because here we have type this. So you can see if you remove that typing from up there, then it's not going to give us problems. So let's for now comment this out so we don't have to worry about it. Okay. Boom, boom. So this context at the moment is a stream of our snapshots. You see, it's the snapshots, but it's not the actual copies of our contacts. It's just the documents that refer to those contacts, but we haven't parsed them. So what do we do if we have a stream that contains this value and we want to convert it to our contacts? We're just going to go ahead and say map, and here we have our event. Okay, so we could call it snapshots, and in here we're going to say our this map function is actually a synchronous generator. Okay, so let's go in here and say for final documents in snapshots docs. You can see it gives us a list of query document snapshots. Okay, then we're going to say yield a person contact from JSON, and our JSON is going to be the doc data. All right, and its ID is going to be the doc ID right there. Okay, so have a look at what is happening here. Just like we have asynchronous generators, we also have synchronous generators in Dart. So let me give you an example if you're not familiar with that. Let's say 1, 2, 3. So if we want to count the values of 1 to 3 and return them, let's say that this is a stream of integer. Mark this function as sync. You can see it's a synchronous generator. Okay. Okay, let's see. 1, 2, 3 is a super tough iterable. Sorry about that. It can't be a stream. It needs to be an iterable because it's synchronously producing some values. And then in here, you can say that yield 1, yield 2, and yield 3. Okay, so now we have a function that returns an iterable with sync asterisk in here. So these are called synchronous generators, and functions that are marked with as async return a stream, and they are called asynchronous generators in Dart. Okay. In here, we have a synchronous generator, meaning that it is actually returning an iterable of our contacts. So in here, we could literally say this is mapping our values to an iterable of contact, as you can see in here. And Dart is happy about that, meaning that this entire stream then, as you can see, is going to be a stream of iterable of contacts. If I move my mouse over it, it's now all of a sudden a stream of iterable of contact. And that means that we can return that, or we can return to the previous state where we had actually written the data type for our contact stream in here. Okay. So that's how we're getting our contacts. And this is the stream that we're then going to pass to our contacts block right here. Okay. So we've created that stream now. So that part is done. Okay. Let's go ahead and talk about creating a contact. So let's see, this parenthesis is for the entire factory. Okay, so let's go ahead in here and say now we're going to take care of creating new contacts. Okay, create contacts. For the creation of contacts, what we need to do is to listen for a signal that comes from our UI, and that signal is right here, which is our sync. So here we have the create contact, which we know that will give us a contact, and then we're going to go and create this contact on Firebase storage. And this is the input signal, and this is basically our subscription for creating that contact, which means we are going to have a stream somewhere, and that stream is going to give us a signal saying that, hey, go ahead and create this contact. That stream is going to be the backing store for this create contact sync as well. So when you have a sync and then you also want a stream, which is a read-only version of that sync, then we can simply go ahead and use a behaviors object, which is read and write. So let's go and think of how we're going to do that. So let's go ahead and first create the create contact subject in here. And we're going to say this is a behaviors object. The input signal and the output to it as well is actually a contact. So what we need then is to say create contact subscription. So we're going to listen to some sort of a signal and then subscribe to it using the listen function. If you create a stream, which we've already had a look at this before, so I don't have to show it again. But if you want to listen to a stream, you do it with the listen function in there. Then you have a callback, which gives you the incoming values in the stream. And the result of the listen function is a stream subscription. And that's exactly what we're going to do in here. We're going to hook ourselves into a stream and then subscribe to it so that when we have this subscription, then the stream is active. It means it becomes kind of like a hot stream, okay, or hot observable. So let's go ahead and listen for changes that come into this create contact behaviors object. All right. Then we're going to do a switch map, because in here, we're going to have a look at the user's identifier. So since the user ID itself is a stream, you can see that we have the user ID somewhere around here. Then we have a behavior subject, which is a stream itself. So if you're already on a stream and then you want to get the value of another stream, whenever the first string produces a value, then you want to use switch map. All right, so let's go ahead in here and say switch map. I mean, actually not necessarily, because sometimes you may want to use async map because the result of this is a future. And sometimes if you change a stream into a future, then you will also be needing, this map, async map, right? So if you need a future to come out of every element that a stream produces, use async map. Otherwise, you're going to use switch map, okay? So here we have the contact to create, all right? And let's go ahead in here and start programming the stream that actually creates the contact for us. So before we create the contact, we need to have the user ID. The reason we need to have the user ID is that we need to create this contact under a collection on Firebase Firestore that has the same name as the user's identifier. Okay, so let's get the user ID. If you remember, this is a stream of an optional string, but we really just want the current user ID right now, and we want to unwrap it. So when we say we want a current user ID and we want to unwrap it, by saying current, I mean that I don't want all the values that will happen in the future on this user ID, all the values and elements that are produced on the stream of user ID in the future. Whenever the create contact signal is received by our contacts block, we want to grab a snapshot of the user ID stream right now. And to do that, you can use the take one operator in here, meaning that I just want to get the current value right now. Okay, just take one of the elements, the last one. After doing that, we also want to get rid of all the null values. We're not interested in null values in here. And that's why we're going to use our own unwrap function in here. Okay. Then for this user ID, we want to go ahead and create a document on Firebase Firestore. And that is a future. Since this is currently a stream of just a string, and you can confirm that by creating a function in here. If I go here and then put this inside a variable and I say foo, and then if you have a look at the data type for foo is a stream of string, okay, which is the user ID. If we take that, then we can say async map, all right, because we're going to issue a future and return a future for this user ID. So let's say user ID. In here, we're going to use our Firebase Firestore backend .collection, which is under the user ID, okay? And then we're going to create a contact in here. The add function requires a map of string and dynamic. However, our contact is an instance of contact in here, okay? So let's in here and say this is a contact. So what we need to do is to turn the contact into a map of string and dynamic. And if you remember from the implementation that we've already done, we have a function in here that says contact, and sorry, not a function. It's actually a read-only property here, which says data. So let's get here in here and say, let's see what's happening here. Boom, boom. And we say contact to create. Contact to create, and then it's data. Okay, and after doing that, you can see now if I move my mouse over this create contact subscription, it should give us the data type. You would expect this to be a stream subscription, but it is not. I mean, the reason behind that is that if you look at all the functions that we've written in here, you can see that we have, actually, let's see if I can get a little bit better formatting in here with some commas and a comma here perhaps as well. What happens if I put a comma pretty much in all of these, and take one would also have a comma? I mean, it will be quite long, but I think it's more readable, at least, because user ID, then take one, unwrap, async map, so you at least see all the functions one at a time, okay? So what's going to happen in here, whenever I want to decide on whether I understand a data type for all these streams, is I start from the absolute beginning. So I'm like, okay, this is a stream of contact. Then I'm switch mapping it, meaning that I'm turning it into another stream. Then I look inside this entire switch map and I'm like, what am I actually turning this into? And then I go into the absolute innermost function in here, which is add. And this add is returning a document reference of map string dynamic. So if I move my mouse over this, you can see it's actually a stream of that inner function, okay? So as long as you understand how these functions work, what does switch map actually do, and And as long as you're a little bit more comfortable with, or as long as you're comfortable with generics, then you'll be able to crack this code, because in here you can see that you're getting a switch map function, which gives you a stream, and then you return a stream of another type, which is exactly what we're doing in here. We're returning a stream of this document snapshot, or was it document reference? Okay. So that's what I mean by all of this, is that we wanted this to be a stream subscription, but it is not. It's actually a stream. So what we need to do is to issue the listen command at the very end of this, and we just close it like this. And now if I move my mouse over this, we can see it's actually a stream subscription of document reference map string dynamic. Okay. So that's completely fine, and we don't have to do anything. But what we kind of could do in here to clean this up is to say this is a stream subscription of void, because we're not actually interested in the document that comes out of this. Okay. So, and this create contact subscription is then going to be fed into our contacts blocks constant initializer in here. As you can see, it is right here, stream subscription. And I can see we've written a stream subscription of contact, but we can turn this into a stream subscription of void right there, and also right here. Okay. The stream subscription is having an empty listen function. So no one's really listening for the values that are coming in inside the listen function. Okay. So it might as well just be a stream subscription of void. That is great. What we need to do, now we've taken care of the creation of contact, let's go ahead and take care of the deletion of contact. So I'm just going to copy this entire piece of code, including its comments. So create contact, and I'm going to go all the way here and then copy that. Okay. Then create some empty lines in here and just paste this. So let's say this is now delete contact. Okay. And it is a behavior subject of contact because it actually receives a contact in here. Okay. And let's call it delete contact subscription. Then let's go in here. Instead of saying contact to create, we're going to say contact to delete. All right. And we're going to do exactly the same thing. We're going to take the user ID, take one, unwrap, and in here we're going to do async map, okay? And then we're going to take that collection with the user ID, and then we're going to say doc. So we're going to get a reference to that document. And we're going to say contact to delete ID, because the doc works with the document identifier. Okay, if you read the documentation for it, actually says this is basically the path. And since we are already on that collection with the user ID, then the path will actually just be the document identifier in here. Okay. Then after this, we're just going to do a delete, which is a future of void. So right there, we just put delete in there and a comma to get the formatting right. And you can see all of a sudden the delete contact subscription is also in place. Okay. Now that we've done all of this, I mean, it looks like a lot of code, but also notice that I have a humongous font here. I've zoomed in, I think, about 300% from my normal zoom size, because this is, I believe, the usual size that I use on my monitor. So if you really look at it, it's not that much code, this entire contacts block. So when we do this, of course, it's going to look a lot bigger. But I think it's quite important to actually have this big font, since you might be watching this video on a mobile device. All right. So now that we have all of these, let's go ahead and say create contacts block. All right. So let's return a contacts block in here using this private constructor. And if I put a comma at the end of it, which you can't see right now, but I'll show you. So let's also switch to our application so that hot reload works. You can see pretty much everything was just plug and play in here, because we have the user ID, create contact, which is a behavior subject, which then turns into a stream, sorry, a sync. Delete contacts also a sync, and contacts is a stream. You can see it here. And then we have the create contact subscription and delete contact subscription. So you just plug and play. All right. So that was all really we had to do for the contacts block. Let's save this file, and we're going to close it then. Let's go ahead and start writing our app block. So the app block is going to be a piece of block that, or basically a class, which we're calling an app block. And it is going to be the interface between our user, our UI, and our various blocks, because we have right now 3 blocks. And if you have a look at them, if you go into the blocks folder, you'll see we have the auth block, we have the views block, and the contacts block. Now, this is kind of like a preference, but I usually prefer not to expose all these blocks to my UI. And this is something that you will also perhaps get into the more you work with Rx and the more you work with your business logics, and that if you have multiple blocks, it is kind of advantageous to sometimes not expose all of these blocks to your user interface first, because if you do that, then you're pretty much exposing the internals of all your blocks. And these blocks may or may not have things that your UI needs. So if you don't want to expose the blocks directly, you can wrap them inside another block, which we're going to call app block, as you can see at the bottom of the screen, and then use that app block with our UI. And it kind of, I mean, another reason that you may want to just expose one block is that it's just so much easier to pass that block around than passing 3 or 4 blocks around, okay? So that's what we're going to do now. We're going to go ahead and create a block, which we're going to call an app block, which wraps itself around the auth block, the views block, and the contacts block. And then we're just going to use that app block everywhere in our application, okay? So let's go ahead inside the blocks folder in here. As you can see at the bottom of the screen, we're going to create a new block called app block, so new file. And I'm going to say app block.dart. Okay. So let's have a look at the implementation of this app block. So I'm just going to say immutable class app block. All right. And there are many things that this app block actually needs. So some of those things are private and the other things are public to the UI. So let's start with the private properties of this app block. The first one is that it needs an auth block, a views block, and a contacts block. So these 3 properties are going to be private to the app block. Okay. So let's say final auth block, which is going to be auto imported. And then I'm going to say we need the views block. All right. Views block. And again, this is auto imported for me, so I didn't have to import it. But if you're getting a lot of errors in here, that's probably because your editor didn't auto import the block as you typed it. Okay. We also need the, what else do we need in there? Contacts block. So let's say contacts block, and that's contacts block. Okay. Then we have to expose 4 different properties from our app block to our UI in order to have the UI functioning. The first property is the current view. So let's say final stream current view, because you remember the view, the current view, the stream of current view is in the views block, but we don't want to expose the views block to the UI. So we're going to say we have a stream of current view in here, and we're going to call it current view. And I believe current view was also imported, auto imported in here as I typed it. Okay. That's for the current view. Then let's go ahead and expose a Boolean of is loading to our UI as well. And this is loading is going to be calculated here inside our app block by doing some merge, as I can see in here. Okay. At the moment, it's only the auth block that has is loading. So if you go to our auth block in here, then there is a function in here, or a property here is a stream of Boolean, which says is loading. And we're going to actually expose an is loading here in our app block as well. As I said, it's going to be merging streams of is loading, and that's just to guard ourselves against future implementations. Maybe you want to go inside, for instance, the context block and also add an is loading property. And then if you create an Rx merge in your app block for is loading, then it allows you to gather the is loading property of more than one block, and then you will have a global loading status in your entire application, okay? Independent of which block is loading currently. So we have the current view. Let's go ahead and implement the is loading property in here. So let's say final stream of bool is loading. Okay, so this is going to be a merge. Then we have an author. So let's say a stream of author, which is going to be auto imported as well in here. And it's optional. And we're going to say author, because it doesn't necessarily have to contain an error. And then we're going to also have user ID change notification. So a stream subscription to user ID. Okay, so if the user then logs out, and then we're going to send that user automatically to the login view. All right. So let's go in here and say we have a string subscription of an optional string, which is the user ID, and then we're going to call it user ID changes. All right. Good. So what we're going to do in here is to start implementing the various functions for our app block. And these functions are going to be the functions that our user interface is going to use to go through the app block into the various blocks that it manages. All right. So the first function is for deleting a contact. So let's just say we want to expose a delete contact function in here, and the contact is passed in here. Really, the only thing that this function does is calls the contacts block and just says delete contact, all right, which is a sync, and it just adds that contact right here, okay? So that's our delete contact function. Let's import contact in here from our models, all right? The next function that we have to implement is the create contact, which is also going to be used by our UI. So let's go ahead and say void, and we're going to say create contact. And in here, we have various properties. We have first name, last name, and phone number. So let's say first name, like this, last name, and phone number. All right. And let's go ahead and say that all these properties are required. String, first name, last name. Okay. That should be fine. All right. You could either do the required properties like I've done in here, or you could just say that these are not required. So you just remove the curly brackets. I mean, this is fine by me, but maybe we could just actually remove these and see what happens. Let's just use this, okay, this format. Okay, so we have to create contact. Let's go ahead and delegate this function to our contacts block. So we're going to say contacts block. Create contact, you see this is a sync. So let's just add a message to it. We need to pass a contact in here. So let's say that we want to create a contact in here, okay? And you can see in here, if we want to create a contact, then we also have to pass an ID to it, but we don't have an ID. We don't really know what to provide for an ID. But if you remember from when we developed the contact class, then we had a little initializer in here, which is called without ID. And this is going to use a UUID. All right, so let's just use that one. A comma in there, a comma in here, and then semicolon. So your create contact function should kind of look like this now. And if I put a comma in here, your function should look like this, create contact, okay? Great. Let's work now on the logout function. So let's say avoid logout, all right? And in here, all we have to do is to go to our auth block and just say logout, which is a sync you see in here, okay? And we add, since you can't create in Dart a new instance of void like this, you could just pass null instead of the void. So this is a little trick that I've learned. So if you have a sync of void, you can pass null to it, okay? Let's now expose our contact. So in here, we want to have a stream that allows the outside, the UI, to grab a list of contacts, okay? So that it can display it in a list view. So let's say we have a stream of iterable of contact in here, and we're going to call it contacts, okay? It's a getter. And all we are going to do is to go to our contacts block and then say contacts like this, okay? The other function that we need in here is for registration. So if you're registering a new user, then you have an email and a password. So let's say register, and we have two properties in here, a string of email, and then we have a string of password as well, all right? All this function is going to do is to delegate its task to the our auth block, and then it's going to say register, and then add. You can see what we have to pass a register command in here. So let's say register command. Okay, email and password automatically pass in here, and the function just looks like this for registering, okay? Similar to this, we have to have a login function. So let's go ahead and create the login function, like that, and then we're gonna say login. We have email and password again, so let's go to the login sync, and then we say a login command, and then we're done with the login function as well. So now that we're doing all this, you may be thinking, but hey, wait a minute, we already have all of these functions inside, for instance, the auth block. We already have all of these things in the views block, etc. Why are we doing this? Well, I've already mentioned the main reason behind it, because we don't want to expose all our blocks to the UI. We want to have like an umbrella block, which is this app block. And this app block is going to hide the complexity of all these various different blocks. one of the complexities that this auth block is hiding is this whole logic of sync. Sync, it could be a little bit too low level for the UI. When you're at the UI level, you're kind of at a high, like almost the highest level you can be inside of your Flutter application. So you don't want to really be working with syncs, because with syncs, you have to call this add, and then you create a login command. It's just so much easier for the UI to call a function that says login with email and password, and not even have to await on it. So because this whole awaiting thing is kind of like the job of the stream builders. We don't have to await on any of these. They're not like async functions that you have to await on, okay? So that's another reason that we were creating this app block, to hide the complexity of our various blocks, okay? So there are a few functions, like utility functions, that we have to implement in this app block for going to different screens. Because if you remember, if we're here, let's go back to the application that was already ready. It is not registered yet button. If I press this, the UI is going to signal its intent to send the user to the register view. So we need a function for this. So boom, it goes to register view. Likewise, if you press this button, already registered, log in here from the register screen, the UI wants immediately the user to go to the login screen. So we need a function for that as well, okay? And then if we are logged in here, and I go and press this floating action button, the UI wants us to go to the create contact view, which then comes here, okay? How about this? If you press this X button, what does the UI want? The UI wants to go back to the contacts list. So we need another function for that, okay? So we need total 4 functions. So let's start with the last one I just talked about. So let's say go to contact list view. Okay, and what this guy is going to do is just going to delegate its message to the views block, and then it's going to say go to view, as you can see in here, go to view, and this is sync of current view. So let's say add, and then we're going to say current view dot contact list, just like that. All right, so it's a simple function, go to contact list, and it just tells the views block what it wants to do. So let's copy that guy. The next function is going to be go to create contact view. So go to create contact view, and the current view is going to be create contact. All right, let's copy this function as well. The next view is going to be going to register view, go to register view, and in here we're going to go to the register view and copy this function again for the last one, which is go to login view. So go to login view. All right, and in here we're going to say login as well. So those are our 4 go-to functions. So it's not more complicated than that. All right. So let's go ahead and do our do the constructor for our app block. So if I go in here, and actually we have to also import a foundation. So let's just do that right now. Let's see where it is. Show immutable. All right. So we have a few errors from Flutter 3, but that's okay. We can ignore them for now. Let's go ahead and get Visual Studio Code to create the constructor for our app block. And remember, all these blocks that we're using with Rx, they are going to have a constant constructor, which is private. And then we're always going to create them with a factory constructor. I mean, when I say always, it's not that black and white. It's kind of like you need to look at the situation of what type of class you have. If it has things and streams and subscriptions, the UI is not going to give you a subscription. So that's for sure. The UI isn't going to create your stream subscription for you. It is going to be your factory constructor that's going to take care of that. Okay, so let's go ahead and create the constant constructor by asking Visual Studio Code for us. So I'm going to go in here and say our app block, it has this constant constructor in here, okay, like this. And you can see in here, then we have our auth block, views block, contacts block, like that. And let's make this function, let's make this constructor private. Hot reload isn't working because we're not on our application right now. So let's say in here, make all of these properties or parameters required, and then we're going to get a few errors in here. And let's say all of them are required, if I can spell. Okay, then we're having some errors in here because these are private parameters or private properties, and they can't be written like this in Dart. So let's go ahead and say the auth block should be an auth block, views block should be views block, and contacts block should be contacts block. The user ID changes is a stream subscription of strings. So let's just copy that and place it here. Okay, so let's remove the this. And inside the initializer list for our constructor app block, we're going to go ahead and pass all of these values to their actual private property names. Okay, so the auth block, the private property, is going to be equal to auth block. The views block, the private one, is going to be equal to the incoming parameter, which is the views block. Then we have the contact block, contacts block, I can see in here, okay? That's equal to contacts block. And last but not least is our user ID changes. Let's go in here and say user ID changes, a private one, is equal to the incoming property. So you can see here now we've created our constant constructor for our app block, and really that was it. We don't have to do anything else with the constant constructor. After we're done with the constant constructor of app block, let's go ahead and take care of the dispose function. I mean, if you look here in our app block, we don't really have any sinks. However, various blocks that are embedded inside app block, they have sinks and they have their dispose function. So what we need to do in here is to go ahead and implement a dispose function for our app block. And in there, we're going to dispose of auth block, use block, and contacts block. Well, we have to do one more thing in the dispose function, and that is taking care of this user ID changes, okay? So the user ID changes is also stream subscription. Whenever you have a stream subscription, you also have to cancel those stream subscriptions when your app block or any other block that is implementing that stream subscription, or actually is creating that stream subscription, is basically that block that has a stream subscription has to make sure that it cancels the stream subscription. My sentence was so long, I kind of forgot the start of it, so I didn't know really how to finish it. But the point still stays the same, that if you have a stream subscription in your block, you need to cancel it when you're disposed of. Okay, so let's go ahead and create a dispose function in here, dispose, and let's go ahead and dispose of auth block, use block, and contacts block in here. So auth block, dispose, okay, views block, dispose, and then in here, we have to have the contacts block dispose. And since we have a stream subscription in here for user ID changes, let's go ahead and cancel that as well upon being disposed. Okay. Great stuff. That is for the dispose function. So what we need to do really, all we have to do actually inside our app block is to go ahead and implement the factory constructor. So let's go here, maybe somewhere on top here, and say factory app block, like this, and it literally has no parameters, okay? So the first thing that we have to do in here is to create these three blocks, auth block, views block, and contacts block. So let's say auth block is an instance of auth block. Final, what else do we have? Views block. Views block is an instance of views block, and also our, what else? The contacts block is an instance of contacts block. All right, so we have our three blocks in here. So let's go ahead and implement our user ID changes. And the reason we're going to do this is that if you look at our auth block, the auth block itself has this property in here, which is the user ID, which is a stream. What we want to do is to glue this user ID into our contacts block. So auth block has a user ID, which the contacts block needs. So if you go in here in the contacts block, you can see that we have a sync of user ID. Okay, so let's read the auth block's user ID, pass it to the contacts block, and that itself is going to be the user ID changes stream subscription. All right, so let's go in here and say inside this factory is to say, we're going to say pass user ID from auth block into the contacts block. All right, so let's say final user ID changes is equal to our our auth block in here. And then we're going to say user ID, and then we're going to listen to the changes that happen to the user ID. And in here, we say user ID. Let's just type it as well. Say this is an optional user ID. And we're listening to that. So let's go ahead and say it should be passed to the contacts block, user ID. All right. And then we add it to that same. So in here, we simply just say the user ID needs to be passed in here. And if you look at then the user ID changes, you can see this is a stream subscription stream. Okay, so that's exactly what we need to pass into this user ID changes property that we have in the constant constructor of our app block. Okay, which is right here, user ID changes. Okay, so that's going to be saved there for us for later. Okay. The next thing that we have to do is kind of like calculate the current view that the user has to be based on the various things that are happening inside our application. All right, so let's go ahead and first write a comment in here and say calculate the current view. All right, so let's say that we have a final stream of current view. All right, and we're going to call it current view based on auth status. So what we're going to do with this stream is that its only goal is to have a look at our auth status, which comes from the auth block. Let's have a look in here, auth block. It has this property, which is called auth status, and auth status can either be logged out or logged in. If the auth status changes to logged in, what we need to do is to set the current view to the contacts list. So as soon as you press the login button and then we were successfully logged in, the auth status is going to change to logged in. At that point in time, we need to immediately send you to the contacts list. When you press the logout button and then a dialog appears saying, are you sure you want to log out? And in that dialog, you say, yes, I'm sure. Then we're going to send you immediately, actually not immediately, after logging out, we're going to send you to the login screen. So this particular logic we have to take care of, and that logic depends on the user status, okay, which is inside our auth block. So let's start this entire stream by saying auth block dot user status, actually it's called auth status, okay? And then we're going to map it to the current view, all right? And let's say auth status in here. Go ahead and create this as a normal function, okay? Then we're going to say if auth status is auth status logged in. If you're already logged in, then we're going to say we have to return a current view contacts list. So if you've logged in, we go to contacts list. Otherwise, say current view login, okay? So that's calculating the current view based on auth status. However, we also have a current view stream inside our views block in here. So the views block also calculates the stream of current view, because remember, our app block exposes these functions, go to functions. Remember, let's go here, go to contact list. And all of these, which are adding values to the sync of go to view inside our views block, are also going to need their voices to be heard. So we have two streams in here. One is this stream, let's have a look here, which is a current view based on auth status. And the other stream of current view is actually inside the views block. So somehow we need to merge these. So let's say final stream of current view. And then we're going to actually call this guy current view. But what we need to do in here is just use merge, RxMerge. So let's import RxDart and say merge. And this takes in an iterable in here. So let's say current view based on auth status, and also our views block, current view. Okay, so you see now this is a stream that merges both of these together. All right. So let's now calculate is loading. So let's say this is for current view, and then we're going to add is loading in here. So let's say final stream of Boolean is loading, and we're going to use RxMerge as well in here. However, the only block at the moment inside our entire application that exposes an is loading property is our auth block. So it really is not needed to have is loading as an RxMerge of just one stream, because merging just one stream with itself is just going to expose that same stream. So, but I usually do this because in most applications that you'll develop with Rx, you will have more than one block that is doing asynchronous work, and those blocks themselves may have is loading properties. So it's a good practice to have RxMerge already built inside your app block for loading, in my opinion, at least. So if you want to just follow along with me, we could do this, but just know that at the moment we have only one block in here, which is exposing is loading, where we're doing merge in case we want to add more. Okay, so let's say our auth block is loading. It's going to be placed in here. Okay, so let's add a comment in here and say is loading. And after that, after we've done the is loading, really we're pretty much done with our app block. So let's just say we return an instance of our app block's private constructor, and let's go in here. Let's see here, add that. Great. So one thing that we need to do also in here is to calculate basically our errors. And let's have a look at how we can do that. So is loading. Also, we need to make sure that we're making a broadcast stream. So this is a thing that I need to mention, what a broadcast stream actually is. So if we put is loading as broadcast stream and read the documentation for it, it says returns a multi-subscription stream that produces the same event as this. The return stream will subscribe to this stream when its first subscriber is added, and it will stay subscribed until the stream ends or a callback cancels the subscription. So really all it means that if you create a broadcast stream, that your simple streams can be listened to from multiple places. Okay, so this is quite important, because if you don't, like if you're subscribing to various streams inside your application from multiple places, if you don't make those streams as broadcast streams, you will actually get errors because you cannot oversubscribe to a simple stream. So as soon as your stream has a subscriber and then the subscription ends, you cannot subscribe to that same stream again. So if you're working with your UI, with your widgets, and you know those widgets are going to be destroyed and created again, even if they're stateless widgets, then you need to ensure that the streams that you're working with, that you're subscribing to inside your UI components, are actually broadcast streams. As soon as your UI components die and you cancel the subscription to those streams, if those streams are not, if they're not broadcast streams, you cannot subscribe to them again. So that's the reason that these two properties, is loading and author, are going to be broadcast streams. Okay, so as broadcast stream, this one and this one. And auth error is actually coming from our auth block, auth error. Okay, and we're going to turn that into a broadcast stream as well. And then user ID changes is just a stream subscription, so it doesn't have to be a broadcast stream. Okay, so let's save this file as well. And I believe really after this, we're pretty much done with our with our app block. So that was it. So I'm just going to close that file. Okay, and after this, we could say that we are pretty much done with the blocks, almost, I think. We're also going to have to then implement, for instance, when you want to delete your account. So we're going to take care of that soon. Okay. So as you can see at the bottom of the screen, we need some type definitions. So let's go ahead and implement these type definitions. And maybe asking, okay, but what are type definitions? And that's a good question. Type definitions are the way I look at type definitions, particularly in Dart, is there are shortcuts to other types. So let's say that you have a widget, and that widget has 3 parameters for its constructor inside a stateless widget, for instance. And those parameters are all functions. Let's say that the first parameter is a function that returns a Boolean and has 4 properties or 4 parameters. The next parameter as well does the same thing. So if you don't want to repeat yourself over and over again and say, oh, this is a function that returns this and this, and it's better to go ahead and create some type definitions or type defs for those properties. And then you can reuse these type defs anywhere inside your application. That's exactly what we're going to do now. So as you can see at the bottom of the screen, we're going to go into the lib folder and right click in here. And then let's just go ahead and say we have a type. You can see it, type definitions.dart. Okay, so let's go ahead and implement these. So we want for the first one, we want a logout callback. So when your UI displays this particular dialog, let's go in here. I say logout. When you press this logout button, this dialog needs to, or this screen that displays this dialog needs to call a function, some function that says logout now. Okay, and if you look at our app block, that logout function is actually available here. So if we have a look at logout, you see it's just a void function, and we're going to just define this type inside type definition. So let's say type def logout callback is just a void callback, and this void callback is already defined. All right. So, and then we also need a go back function. So if we go in here and try to create a new contact by pressing this X button, we kind of want a go back callback. So this view should call a function indicating that it wants to go back. Okay, so let's define that and say go back callback. That is a void callback. All right. Now, you also want a callback for logging in. So if you look at the login function in here, let's see, we have login. It's just a void function that takes in an email and a password. So let's say type def. Login function is just a void function that takes in a string of email and a string of email and a string of password. Okay, just like that, a comma and a semicolon. And we need the same one for register. So let's say this is register. And remember, again, these at the moment are kind of like abstract. So I completely understand if you don't know really what we're going to do with these things, but I'll just give you a hint. We're going to soon go ahead and create these widgets. As you can see in here, for instance, the create contact widget. This widget internally then, actually not just internally, as this public interface, is going to expect a few callbacks. So inside this constructor, it's going to say, okay, give me a callback that I can use to go back from my screen to the previous one. So when you press this button, this particular widget is going to have a reference to some sort of a callback called a go back callback. And when you press this button, this widget is just going to call that function. It's a void callback. Then what's going to happen is that we are going to pass function references to these screens. So this screen is not going to have any idea or is not actually going to talk with the app block directly. All it's going to do is just call some functions. So we're going to do dependency injection, basically, of app blocks functionalities into various widgets without these widgets actually knowing what they're doing. Okay. Actually, they know what they're doing, but they don't know where the functionality is coming from. So they are not going to have hard references to the app block. That's what I'm trying to say, okay? That's for the login function and the register function as well we have in here. And I actually wonder if we need the register function, to be honest with you. We may need to, but let's just leave it here. Let's go ahead and create a function for creating contact. So if you look at our app block, I believe create contact has its own function in here. You can see is a first name, last name, phone number properties. So I'm just going to copy this guy from here, and I'm going to say type def create contact callback is equal to a void function. All right. Now let's put the semicolon at the end of it. So that's for create contact callback. And also we need a delete contact callback. Let's go back here. And all this function does really, if you look at app block and we say delete contact, it's a void function that takes in a contact. So let's say type def delete contact callback. It is a void function that takes in a contact. And this is going to be auto imported from contact model. Contact, semicolon in here and a colon. All right, actually colon first and a semicolon. Great stuff. That was really all we had to do for our type definition. So I'm going to close this file. And I'm going to also close the app block. As you can see at the bottom of the screen, we've pretty much written everything or all the logic that we need in order to be able to deliver what the UI has to do. There's one thing remaining really, and that is like deleting an account, but we're going to take care of that later. But let's just go ahead now and start using all the functionality that we've created in order to deliver our UI. Let's go first and develop the main pop-up buttons. And this main pop-up menu button is used right here. If I close this, when we press this particular button in the contacts list, there is going to be a pop-up that gets displayed, which is log out and delete account. And that's exactly what we're going to do right now and go ahead and implement that. Okay. So this Dart file is going to be created inside lib views, as I can see at the bottom of the screen. So let's see what we have in here. We have lib, blocks, dialogues, helpers, loading models, but we don't have views. So I'm going to right click on lib and say, create a new file, excuse me. And then I'm going to say views slash, excuse me again, main pop-up menu button Dart. Okay. So this main pop-up menu button has two actions. One is for logging out and the other one is for delete account. So let's define these actions first. So let's say menu action. It has log out and then it has delete account. All right, good stuff. Let's create a stateless widget that defines basically the pop-up itself. So we're going to call it main pop-up menu button. I can see in here, okay? And then this function is, at the moment, it needs two callbacks, basically. One is for the delete account, and the other one is for logout. So let's go into our type definitions, and let's go ahead and say that we have a callback for delete contact. Actually, that's not it. We have a logout callback, but we also need a callback for deleting your account. So let's just say type def delete account callback, which is going to be a void callback as well in here, okay? So let's say that this is a void callback like this. So we have both of them defined. Then let's go back to our app, okay? And in here, this main pop-up menu button needs two function references, one for logging out and the other one for deleting an account. But we don't want to hook this main pop-up menu button to our app block, because then we're creating a direct dependency between our main pop-up menu button to the app block. And it's usually not a good idea to embed your app block everywhere. And also, apart from that, how do we get a reference to our app block from the main pop-up menu button? We then have to inject the app block anyways into the main pop-up menu button. So we may as well cherry pick the functionalities that the main pop-up menu button needs from the app block, such as its logout and delete account. Actually, not just such as, only the logout and the delete account functionality. So let's go in here, and actually it was called delete account, right? Yes, delete account. So let's go ahead and add those properties here as final references. So we're going to say this is going to be a final logout callback, and we're going to call it logout. And we're also going to have a delete account callback, okay? And we're going to say delete account. These are function references. Remember that, okay? Then we're going to add those into our constructor. So right there, we have required properties, and the constructor is happy. I'm going to put a trailing comma in here to get the formatting right, okay? Good stuff. So let's go ahead inside the build function in here and return a pop-up menu button. So we're going to say pop-up menu button, and which is working on menu action, all right? Then we're going to develop the onSelected in here. So this is our value, and this is going to be async, all right? So that's that, and then we're going to have the builder, item builder as well. And item builder is right here, and the item builder takes a context, and it has to return a list. So it has to return a list of widgets that need to be displayed in there of type pop-up menu item. So let's say return this, and then we're going to say the first one is a const pop-up menu item. All right, it's going to be working with a menu action. Its value is menu action logout. All right, like that. And also it has a property called child, and its text is going to be, it was child, I believe, right? I actually don't know what the problem could be in here. It's because I haven't closed this. And its child is just a text const. Find const because we already have const in here. So it's text of log out. Comma to get the formatting right. Good. So that's the first button that gets displayed inside our pop-up menu button. So let's go ahead and define the second one. So in here we have delete account, and the text is just going to say delete account, just like that. All right. So we've created the widgets, but we haven't actually handled them. So let's go to onSelected, and this is an async function, as you can see in here. So let's just switch this value, which is of type menu action. We get Visual Studio Code to complete the missing clauses for us. On logout, what we're going to do, as you can see in the actual complete implementation, testing RxDart, if we say logout, we display this logout dialog first. So let's go ahead and say final should logout is await on show logout dialog, which is going to import the class for us. As you can see in here, we don't need this key, we don't need this framework. Here, the logout dialog was auto-imported, okay? So the result of the show logout dialog, you can see, is a future bool, and that boolean is true only if the user presses the logout button. Okay, so if the should logout is true, so we say if should logout is true, then we're going to log out. So how do we log out? We have a function reference to logout, you can see in here. So we're just going to call that function. So like this. So we just log out. We don't have to wait on anything. You see, the functionality, the asynchronous functionality of all these functions is built into RxDart because we have streams, stream subscriptions, and various components, various blocks in our application are talking to each other through the app block. So if you just say log out in here, we know that this is finally going to call the app blocks logout. So if you go then to app block and we have a look at a logout, you can see it's sending a logout message to the auth block, which in turn then, if you go in here, you can see that logout will do all of this. So first sets the loading to true, then it actually logs you out from Firebase, authentication, etc. And it even has handling of errors. So it produces auth errors if something goes wrong. So there's a lot going on behind the scenes. So that makes the UI simply beautiful because the UI doesn't have to care where all the logic is, what the logic is actually doing. It just says, give me a logout function. I'll call it if the user wants to log out. So in that way, the main pop-up menu button Dart file is so just connected away. It's like disconnected. Connected away is disconnected from the rest of the application's logic. Okay, so it just says, here's a logout function. I'm just going to call it. All right. In the same way, we're going to, in the delete account, we're going to say final should delete account. And we're going to say await show delete account dialog with the context. If should delete account, let's just, in here, we're just going to call the delete account function in here. Okay. Like that. And then a break. And again, remember, we haven't really implemented delete account yet, and that delete account is going to be inside our app block. So let's go into our app block, bring the application forward. So hot reload is going to work. So we have logout in here, and let's just go ahead and create another function in here and say delete account. And this for now is going to be to do. We haven't done the delete account yet. All right, so we just need to remember to do the delete account as well. Good stuff. We're done with the main pop-up menu button, so we can move on to the next component. After this main pop-up menu button is done, let's close this and also pretty much close all the other files that we have so we can focus on the next component that we have to develop. And that is going to be our new contact view. And that new contact view looks like this. If you remember from the application that we've already developed in here, so pressing the plus button, the new contact view comes in here. So it has 3 text fields and 3 text editing controllers, a simple button and a little button in here, which takes the user back to the contact list. So let's go ahead and implement this. So as you can see at the bottom of the screen, we're going to go into views and then create a new file which says new contact view. So new contact view.dart, okay? And this new contact view is going to be very similar in that we're going to inject, it's going to be similar to this main pop-up menu button is what I wanted to say, in that we're going to inject the functionality that this function this class needs into it using its constructor, and it doesn't have to have any hard connections to the app block, okay? So let's go ahead in here, new contact view, and create a hook widget. So I'm going to say STL for now, and I'm going to say new contact view, all right? Let's turn this guy into a hook widget because we're going to need 3 text editing controllers. So hook widget, all right, it's going to be auto imported, as you can see, from Flutter hooks. So I'm going to remove all of these, and key is going to be imported from material. So let's see, import material, okay. So this guy needs 2 functions in here, or function references. One is for going back, and the other one is for creating a new contact. So if you go in here and really look at this view, it's really doing 2 things. One is saving a contact, the other one is closing the screen. So let's take those functionalities as function references in here. So let's say final create contact callback, which is a callback or a type definition, which we've already created from before. So let's just say create contact. And also we have a go back callback, which is called go back in here. Let's import them. Sorry, and let's add them to our constructor. So that's not the way I want to add them. Final, and let's see if it can add them as required parameters. And it couldn't. That's okay. We're going to go ahead and add them as required parameters ourselves in here. Okay, like that. And let's say required and then another required right here, and a colon at the end to get the formatting right. Okay. So inside this, we need, since this is a hook widget, we need 3 text editing controllers. So I'm just going to start with the first name. So let's say first name controller is a used text editing controller, as you can see in here. And its text is, for now, we just say if debugging. And if debugging is something, if I go in here and say if debugging, we can import if debugging in here. So what this really does is that it creates a text editing controller for us that is pre-populated with the name of Vandad, which is my name. And you can just use your name in here only if we're debugging. If we're not debugging, this value is going to be null, because that's what if debugging does. It looks at the kdebug mode. If we're debugging, then it returns a current string. Otherwise, it returns null. Okay, so we have the first name controller. Let's go ahead and create the last name controller as well. So last name controller, and that's my last name. You can put your last name in there. And then let's go ahead and create the phone number controller. So let's say phone number controller. And then here I'm going to use +46, which is for Sweden. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, like that. Okay, so it's just an invalid phone number, but still something to put in the text editing controller, because we're not going to do any phone number validation really. All right. So what we're going to do in here is just to return a scaffold. All right. And in our scaffold, we are actually going to have an app bar that has a leading icon button, which is this guy. So let's say app bar, and we're going to have an app bar in here. And then we're going to say leading is as an icon button. All right. And onPressed of this guy is empty for now. I'm going to close it. All right. And its icon is going to be a const icon and icons close. Okay. Because close, that's how it looks like. Right. Great. So that's for close. Excuse me. And let's put some commas in here to get the formatting right, and a comma here as well. Let's go back to our application so that hot reload works. Okay, upon pressing this button, which is for going back, all we need to do really is just to call the go back function. So if you say go back in here, that's going to work. However, there's a neater way of doing that. It's just to passing the go back function reference to the onPressed, because it's going to invoke that call, function for us. Okay. Good stuff. And we can also, thanks to Visual Studio Code, see the icon right here for close. Okay. So that's really good. And we can now go on and work on the body of this scaffold. If you remember from where we looked at the UI for this particular view in the simulator, in the new contact view, let's actually go back there and have a look at it, how it should look like. We have 3 text fields in here, and there are they're followed by a little button in here. And this button is going to be a text button with an action and some text, of course. And we're going to place all of these 4 components in here inside a column. Then we're going to place the column inside a single child scroll view, which is a good thing actually to do if you have lots of components in your columns, in case those components don't fit in a smaller screen. Then we're going to place that single child scroll view inside padding. So the way I usually do this is I start by not creating the padding and single child and then a column. I actually start by creating one of the text field text editing controllers, or the text fields actually. Then I place that inside a column. Then I place that inside a single child scroll view, and then the padding. So let me show you how I usually do that. So if I just say body in here, and I say I want a text field first. Okay, so I just create the text field. Then I say I want to embed this inside a column. Once that is done, I say embed wrap it with a widget. I say single child scroll view. And then I embed the single child scroll view inside padding. So now I have at least the structure of this screen in place. Okay. Let's go back to our actual application in here. Let's see where we were here. We have 3 text fields, so let's go ahead and create these. And the first text field, and we're going to write it by hand in here. So that's going to be for our first name. So let's say the controller for this one is the first name controller. Then we have decoration, which is going to be a const input decoration, and the decoration we're creating because we're going to add some hint text in here. You see, if I remove this text, then there's a little hint that gets displayed to the user. Okay, so let's say input decoration, and for the hint text in here, we're going to say first name. dot, dot, dot. All right. For the decoration. Let's go and say the keyboard type then is a name. So we'll say text input type name. And also we have the keyboard appearance, and we're going to say brightness dot dark. All right. So that's our first text field. And it's for this one. So let's copy this guy actually and paste it instead of, and remove this second text field in here. And then in here, we're going to say this one is for last name. Last name. And in here we say last name. All right. And the keyboard type stays the same. It's going to be name. And I'm going to copy this one again and paste it in here. And the third text field is going to be for phone number. So let's say, just don't forget to change the controllers. Otherwise, you'll get really strange behaviors later when you try to extract the text from the controllers. Phone number controller. And in here, we say phone number. Okay. Perhaps dot, dot, dot as well. And for the keyboard type, we say this is phone. All right. Great. After creating these text fields, we need to create the text button. So let's go ahead and say text button. And I'm going to say unpressed. For now, it's going to be an empty function. Okay. But we're going to write the function later. It's child. Let's say child const text. And you can see the button should say save contact, like this. All right, comma, to get the formatting right. Let's go back to our application so that hot reload works as well. Great stuff. Now that that is there, let's go inside the unpressed of our text button and actually program it. So let's extract the text from our text editing controller. So we say final, first name is first name controller.text. Last name as well, okay, is we get it from the last name controller.text. And we say final phone number is, excuse me, phone number controller.text. All we have to do really is to call the create contact function on our app block, but we don't have the app block instance in here. However, we have a reference to the function that actually creates a contact for us, and that is right here. You see create contact, okay? So let's call the create contact, call back in here, sorry, the function itself. And this function requires 3 parameters. So let's say first name, last name, and then we're going to say phone number. And after creating a contact, we actually want to go back to the previous screen. So let's call the go back function as well. So you see create contact, and then we say go back. So it's quite simple. Good stuff. Now that we have those, we could just say that we're pretty much done with the new contact view in here, because we've created the text editing controllers, we've added the callbacks in here, or at least added the reference to the callbacks in here. And we've pre-populated the text editing controllers with some dummy text so that we don't have to populate those text editing controller or text fields every time we're in that view. And we're pretty much good to go on this view, and we can move on to the next one. The next view that we're going to work on is, as you can see, is the contacts list view. So let's go to the Explorer inside views, and I'm going to say contacts list view.dart. After we create the contacts list view, let's go ahead and start implementing the various functionalities that are in here. If you remember from how the application should look like, let's go back here. You can see that every contact is going to have their own tile in here, because we have a list view, and then we have list view tiles, okay? And every list view tile has a delete button upon pressing which you are going to see this dialog. And if you say cancel here, nothing's going to happen. But if you say delete contact, then that contact is going to be deleted. So let's go ahead and work on the tile first. So let's say that we have a stateless widget in here, and we're going to say contact list tile, okay? And this tile requires 2 parameters. One is the contact that it actually has to display. So let's say final contact, and this is going to be auto imported, and we're going to say contact. All right. And the other one is the callback for deletion of a contact. So let's say final delete contact callback, and this is delete contact. Okay. Let's go inside the constant constructor right here and add these parameters. So right there, and they're required parameters. Great. Put a comma to get the formatting right. Good. Inside the build function, let's go and return a list tile. All right. For the list style, its title is going to be a text of the contact dot, and we have the first name, last name, but we also have a property called full name. I can see here we haven't actually implemented full name yet, and we could go ahead and do that inside our contact. So let's go ahead in contact.dart, and we need a property for full name, and full name. It is, at the moment I can see we've implemented toString. However, in here, we could just change this and say string get full name. So we don't need a toString really, because we're not printing instances of this out or logging them to the debug console. Let's go ahead instead and use the full name, okay? Or let's change toString function to a full name getter, all right? We've done that now. I'm gonna go back to our application so that hot reload works, okay? Excuse me. Here we can just say contact.fullname. All right. So that is for the title of our list tile. Is trailing. Trailing, actually, we're in the list tile. Okay, trailing. And I can see list tile isn't defined. That's simply because material hasn't been imported. So let's go ahead and import material so that we get rid of all these errors. For the trailing, we need an icon button. If you remember, we have that little trash can, and let's say icon button. Okay, on pressed for now, we're going to say it's empty, and its icon is going to be icon const icon, and then we're going to say icons dot delete. All right, and a comma to get the formatting right as well. Good. So that's for the trailing. And in here, in the onPress of this trash can button, which is for delete, as you can see here at the left-hand side of the screen as well, we're going to turn this function into an async function because we have to display a little dialog to the user. So let's say should delete is, and we're going to say await on show delete contact dialog, all right, with this context. And we say if should delete, then we're going to say, we're going to call our delete contact callback and pass the contact in here, okay, like this. So we're going to let the delete contact function take care of all of this for us, all right? So as you can see, the tile doesn't really have any business logic. All it does is just displays a dialog, and if the user decides to delete the contact in that dialog by pressing the delete contact button, then we delegate that message to the delete contact function, all right? So we have that now. Let's go ahead inside our scaffold. Actually, we don't have a stateless widget in here. Let's go create that first. So we're going to call it contacts list view. All right. So STL for stateless, and we're say contacts list view. All right. This list view itself requires a few callbacks or function dependency injections, and two of those things, actually, one of the functions is going to be the delete contact. So since the contacts list view is the one that is going to create these tiles, we need to, from the outside, inject this delete contact callback into the list view, because from the outside, we're not going to work with the list tiles. It's only this class itself, the contacts list view, that's going to have references to contact list tile. So we need to make sure that these two properties are also passed to the contacts list view. All right. So let's go ahead in here and first start by passing the delete contact callback. So I'm going to copy this from here and put it in here. Okay, so that's for the delete contact. We also need a logout functionality in here, because the pop-up buttons that are displayed in here, you see this one, logout and delete account, they also need to be passed in here, because it's the contacts list view that is going to create this pop-up menu button on top of the screen. So let's go ahead and say final, excuse me, logout callback is for logout. And we need final delete account callback for delete account. All right. So we have these three callbacks in here. We also need a create new contact void callback. So when you press this floating action button at the bottom of the screen, this right here, we want to somehow tell our app block that, hey, we want to create a new contact. And then app block is going to be like, oh, you want to create a new contact? Then I'm going to tell the screen block, or did we call it views block, to go to this particular view, which is the create contact view. All right. So let's go ahead and add that in here as well. So let's say we want a create new contact. So final create new void callback, create new contact. Okay, so delete delete contact, delete account, log out, create new contact. They're all callbacks in here. And then we also need the contacts to display because we don't know where to get that from otherwise. So let's say we have an iterable, this will be a stream iterable contact in here, okay? And we're going to call it contacts like that. Let's go and add these properties to the constructor in here. So like that, they're all required. Great stuff. Put a colon at the end to get the formatting right. In the build function, let's go ahead and return a simple scaffold. Okay, so for now we say scaffold. Like this. Okay, inside the scaffold we need an app bar. So we say app bar like that. And the title of the app bar, let's go ahead and see, it should say contacts list. So we say it's a const text contact list like this, and put a colon to get the formatting right again. Okay, go back to our app to get hot reload working. And then let's go inside the app bar and we add some actions in there. So because we need to get this button right here, right? So let's say in the app bar, we have actions, and inside actions, we're going to say main pop-up menu button. For logout, we have the logout callback, and for delete account, we also have the delete account callback. So it's just really plug and play. All right. Good stuff. We have that. Let's go back to our app. Hot reload working. We have the title and the actions for the app bar. So we took care of that main pop-up button. We also need a floating action button. So right after the app bar, let's say floating action button. And let's say floating action button. Okay, right here. Have a look how it looks like. So if you have the floating action button and then floating action button right there, it's not so happy because we don't have the unpressed. And unpressed, all it should really do is just to go to the create new contact view. And for that, we have a callback in here. So we have this create new contact. Let me copy that and just bring it here. So we say when you press this floating action button, we should just go to create new contact. All right. Child, let's just say we have a const icon. We're going to say icons dot add. All right, so it's going to be the plus button basically. Great stuff. Good. For the body of this scaffold, we're going to create a stream builder because we have a stream of contacts, and whenever the stream emits a new iterable of contacts, we want to reload our list. So let's go in here and say that the body of our scaffold is going to be a stream builder. And this stream builder is actually going to work with an iterable of contacts. Okay, so like this. And then we're going to say the stream is contacts. And then we have a builder function in here. Let's see if Visual Studio Code can help us with that. Nope. And the two parameters are context and the snapshot, all right, which is an async snapshot. All right. So let's switch the snapshots different connection states. So snapshot connection states. All right. And we ask Visual Studio Code to complete these case clauses for us. In the case of none and waiting, we're just going to return a centered circular progress indicator. So let's say return, and we're going to say circular progress indicator, and then I'm going to center it. So wrap it in center, just like that, and we can just make this entire thing a const. All right, so that's for the states of none and waiting. However, if the stream is active, that's where we have to display our contacts, okay? So let's go ahead and say, in the case of active, we say final contacts is snapshot require data, because this is going to give us the iterable of contacts, okay? And then in here, we then return a list view, and then we say builder, we have item count, which is our contacts length, and we have the item builder, and in here we get a context and an index, and then we have to return our list tiles. So let's go ahead in here and say that we want to return. So we say final contact is contacts element at index, element at this index. So this is how we get the contact out of the list of contacts. And then we return the contact list tile, and the contact is there, and delete contact callback is also available. As you can see, your code should look like this basically. So In the case of active and done, we're actually going to do this. So let's remove the done case from there and put it right after active, as you can see in here. So active and done, they're both returning the same thing, okay? The stream should never really be done, to be honest with you, because our stream is never going to be closed. So this case is never going to be called, but at least we're going to put it in there because otherwise we have to make up something to display in the done case, okay? Good stuff. We're done with that now. Talking about done, we're done with the screen. So we can close this code that we have right here, and then we can close the contact Dart file as well. Let's go ahead and start working on the login view. So as you can see at the bottom of the screen, we're going to go into views and right click here and say new file. And then we're going to say login view.dart. And then we should start basically working on our login view. And the login view, both the login view and the register view are very similar. So what we're going to do is to, excuse me, we're going to create the login view and write its logic and do all the UI components, etc. in it. And then we're just going to copy paste it into the register view. So once we've done one of these views, which in this case is the login view first, the next one is going to be so much simpler to do. Okay. So let's go ahead in here and say we want a stateless widget, and we're going to call it login view. And I can see foundation is imported and widgets framework is imported. Let's just import material in here instead. Okay. So import material. That's good now. Now this login view, it needs to do, it of course has some logic. First of all, it needs to be able to log in with a username and with an email and password, but also needs to have a callback for it going to the register view. If you remember, we have a little button in here. And if I go and log out, in the login screen, we have this functionality here, of course, with email and password. And then we also have another button that says, not registered yet, register here, which sends you to the register screen. So we have two callbacks in here, which we need from the app block, okay? One is final void callback, which is go to register view. That's that button. And before that, we also have to have a login function, which is imported from our type definitions, as you can see in here, and we're going to say login. Okay, so let's go ahead and final login function. Let's go ahead and add these properties here. Add formal properties, login, and go to register view are added to our constructor. Okay, semicolon there as well to get the formatting right. Good. In the build function, we need some text editing controllers. So let's turn this guy into a hook widget, which is going to also import Flutter hooks for us. Okay. We need an email and password text editing controller. So I'm just going to copy paste those in here because they're quite boring. Okay. As you can see, the email controller is just a use text editing controller with my email, and then a password controller with just some dummy password. Okay. If debugging, we need to import that. So let's do that. Okay. Then what we need in here is to create a simple scaffold. So we say return scaffold, and app bar is going to be a simple app bar. So we say app bar, and title is going to be a const text, and let's just say log in. All right. Let's close these off with some columns to get the formatting right. Go back to our application to get hot reload working as well. And as you saw in here, you see we have two text editing controllers or text fields. And the trick that I usually do, as I mentioned before, we know that these are going to be inside a column, but I don't create the column and the padding first. I actually create the innermost components first, at least one of them, and then wrap the innermost components inside a widget, inside the column, and then wrap the column inside padding. So let's go ahead and add the body in here, and we say we have a text field. Okay. And I say wrap this guy inside a column, and then wrap the column inside padding. Okay, like that. The first one, the first text field is going to be for your email. And I'm going to copy paste code in here so you can see we just created a text field, because these are just boring stuff, to be honest with you. They don't have so much to do with Rx. So in here, you can see it has a decoration, keyword type is email address, keyword appearance is dark, and then its controller is email controller. Okay, the next one is going to be for password. So I'm going to copy paste the password text field in here as well so we can save some time. You can see the text field for password is using password controller, and it says enter your password here. The only thing special about this is that it has an obscuring character that is one of my favorite characters for password obscuring, which is kind of like a circle with an outer circle around it as well. Okay, and of course you need to ensure that your text field for password has obscure text set to true. Okay. The next component in here in the login view, let's go back to the login view, is the login button itself. So let's go ahead and add it after. So we say text button, okay. OnPressed is empty at the moment, and as child is going to be a simple text in here. So let's say const text, and we say log in like that, and a colon right there, okay, and another colon at the end to get the formatting right. Go back to our application to get hot reload working. Now inside this text button for login, we're of course going to have the login logic in here. So let's say final email is email controller.text. So let's grab those informations that we have to send to our app block. We say password is password controller pass, if I can spell, text. Then we're going to say just call the login function with the email and the password. As simple as that. Okay. For our text button for logging in. Of course, we're going to have another text button for sending you to the register view, which you saw here. Not registered yet, register here. So I'm going to copy and paste this particular button in here because it's not so difficult to create it. So I just paste it in here. You can see it's a text button. It has an on pressed, and all it does is says go to register view, and we can actually pass this go to register view here instead. Okay. And its child is const text, not registered yet, and it says register here. Okay, so we save this as well, and we are pretty much good to go on the login view. There was not much more that we had to do. Okay, as I mentioned before, login view and register view are so similar to each other. So let's go ahead into our views folder and create another file, and we call register view.dart. Go ahead to your login view, which is right here, and we're going to copy this guy and go to the register view and just paste it right there. So the login view is very similar to the register view, okay? So we have this login function in here, but let's go ahead and see if we have a register one as well. Yes, we have register function, okay? So let's change this inside register view. First, change the widget itself to register view, like this. Then we say instead of login function, we have a register function, okay? And the property itself should be called register. Good. Let's see what else we have to control in here. So we have the email and the password. And if you go to the register view, you can see it's very similar. You can there's almost no difference between them. It's just the title and actually what they do that's different. So let's go ahead and change the title of our app bar in the register view to register, as you saw. Okay. Then it says enter your email. That's great. Everything's great. The text button, instead of log in, on the register view should say register. Let's change this guy, register. And you can see in here, we're actually calling the register function already because I renamed this from register function, and then I actually renamed the property itself to register. So that was also changed in here. But if it wasn't changed for you, and if you did that renaming by hand, then you need to ensure to go into this text button in here and change from login to register for the register view, okay? I'm gonna close the login button on top, excuse me. So let's have a look here. The register button is all set, and I can see that the onPress goes to the register view. And in here, the button on the register view, instead of saying not registered yet, register here, it should say already registered, log in here. So let's say already registered, log in here. Okay, as you can see. Okay, and this one, it says go to register view, but it should really say go to login view. Okay, so let's say go to login view. All right, so that was it really. There's not much more that we have to do. So we're pretty much done with the login and the register view. So not that difficult, okay? Let's then go ahead and put all of this together. I mean, this is, you'd be surprised, but we're pretty much done with this entire application. You see, it's once you do the blocks, once you do the actual logic of the of your application, there's not much more to do. It's just putting the UI together and then just wrapping it up maybe inside the main Dart file. And this main Dart file is actually one of the most important functionalities of our application, because it's going to take care of a few things, very key things. One is going to be the displaying of all authentication related errors, and the other one is going to be taking care of the loading screen. Remember, we have this loading screen. We have the Boolean stream for it, but no one is really at the moment displaying the loading screen, and we're going to do that inside our main Dart file. So let's go ahead and start putting this main Dart file together. If you go to our main Dart file, okay, let's have a look at what it looks like today. And if you go in here, you can see we have the main function. However, we are working with Firebase, so we need to ensure that Firebase is initialized. So let's go ahead and do our widgets Flutter binding. So let's turn the main function into an async function and do our bindings in here, okay? So Firebase, let's import Firebase core, as you can see, and then this one also needs to be imported from Firebase options. So now our main function pretty much is ready. Our app is just a simple material app. We're not going to change anything about the app itself, and the app is creating the home page. Our home page at the moment is a stateless widget, but we're going to turn it into a stateful widget, okay, because it needs to have subscriptions to is loading stream, and also it's going to have a subscription to auth error, okay? So let's turn the home page into a stateful widget. Good stuff. Inside the state object of our main Dart, inside the state object of our homepage stateful widget, let's go ahead and actually get a reference late final app block. So we need to import app block and then put the app block in here. So if you had this question in your head that, oh, wait a minute, but who is going to create the app block? Who's going to hold onto an instance of app block? Then you have your answer. It is going to be our homepage that it actually is the only component in the entire application that has a reference to our app block. So app block isn't a singleton. It could be a singleton, but at the moment it isn't, and it's placed inside the homepage state. All right. So it is a late final variable though, so we have to initialize it and construct an instance of it and then later dispose of it when this homepage state is rebuilt. So that's one thing that we have to keep in mind. Then let's go ahead and create a stream subscription for our auth errors. As you know, auth errors were optional. So let's auto import auth error, make it optional. And then we're going to call this guy, and this whole thing itself is an optional. Then we're going to say auth error sub. Okay, so it's a subscription. We need another subscription for this one is going to be for loading. So we're going to say this is Boolean, and then we're going to call it is loading sub. All right. So inside init state of our application in here, inside the init of our homepage. So we say init state. All right, super init state first. Then we're going to create the app block. So we say app block is equal to an instance of app block, as you can see in here. Okay. And then in dispose, so let's override dispose, if I can spell. All right, before we call super, let's go ahead and first get rid of our app block. We call dispose on it. And then we're going to just cancel the subscriptions that we have in here if they're available, since they're both optional. So optional.cancel right there. And then is loading subscription also needs to be canceled optionally because it is an optional variable itself. All right. Let's go ahead and add some functionality inside our homepage in here that takes care of loading and also takes care of auth errors. So first, we're going to have a look at handling auth errors. So let's create a little function in here called handle auth errors. So handle auth errors. Okay, we get a build context, and then we say context. We need the build context because we are going to display alerts to the user. Okay. What we need to do in here, if you say handle auth errors, this function is going to be called from our build function soon, as you'll soon see. Okay, and then in here, what we need to do is to first of all cancel the previous subscription for auth error sub if it's there. Okay, so we're going to say in here, we're going to say wait on this cancel. All right. After doing that, we're going to create it again. So this is going to be equal to our app block auth error, and then we're going to listen. Okay, for events, and then we're going to say auth error, final auth error is equal to our event, and this is going to be an auth error optional, as we know that, okay, because the event is already an auth error. Let's go and move our mouse over it. And then we say if auth error is equal to null, then we don't do anything. We just return from in here, okay? However, if there is a valid author to display to the user, what we need to do in here is just to say show author, and that was auto-imported. I hope you noted that. So when I typed show author, Visual Studio Code was like, oh, do you want me to auto-import it? And I just tapped on the enter key. So if you have some errors and the show author function isn't available for you, it's because you have to import that, okay? So you can see in here, it's very simple. We're just saying show author, and that's it really, okay? Just like with the handle authors, we need another function for setting up the loading screen. So let's go ahead and say void setup loading screen, and we need the build context in here as well. Build context, and then we say context. This is an async function as well. Similar to handle authors, when we cancel the subscription to author sub, we have to also cancel the subscription to this is loading sub in here. Okay, so let's await on this, optionally cancel it, and then we set it up again. Then we say the app block is loading, then we're gonna listen to it, okay? And we're just gonna call this is loading. And inside this, we're gonna say if is loading, and we display the loading screen. So we say loading screen, which is going to be auto-imported in here, instance, then we say show, instance dot, what do we have in here? We have controller, and we don't have the show. That's interesting. Let's go into our loading screen and see what happened with the show. Oh, I see. That's really strange. So what we've done in here is that in our loading screen, we've just created the show overlay, but we actually haven't taken care of show and hide in here. So we need to go ahead and do that. So let's go ahead inside our loading screen. Now this is a little bit of a detour. It seems like we've forgotten to actually write the public APIs for our loading screen. So let's go ahead in here and say void show. It has two required properties. So we say required build context, which is our context, okay? And then we have a required string of text, okay? So then we say if we already have a loading screen displayed to the user, meaning that loading screen controller is not null, then we say if controller dot update, if we can update the current controller, if there's a loading screen already displayed to the user and we can update its text, or false. So if the controller isn't available, we want a default value in here, okay? Then we just say, okay, seems like we could update the loading screen. Otherwise, let me put a colon in here as well. Otherwise, in here, we have to create a new overlay. So we say controller is equal to show overlay and the context and the text. All right, so that was very simple for the show function. Let's go ahead and do the hide function in here. So we say void hide. All right, in here, we have to close the controller. So we say controller optionally close yourself if you are there. And then we set the controller to null in here. Okay, very simple. And that was it really. Our loading screen is ready. So let's go back to main Dart, and inside the setup loading screen function, we say if we're loading, instance show, and we have the context and the text, all right? Actually, the text doesn't seem to really have been passed in here, so we just say loading, ... Okay. However, if the loading is false, then we say loading screen instance, loading screen instance, and then we say hide, just like that. All right. So that's for our loading, and also we have the subscription for handle authors. Okay. Let's go ahead and create a little function in here, which is going to be called get homepage. So we say widget get homepage. Okay, and the functionality of this, or the responsibility of this function, is actually to create our homepage for us. So we then go inside our build function. So inside build, what we're going to do is just to say, first of all, set up the author handling. So say handle authors. Then we're going to say set up loading screen. And then we say return get homepage. Okay. So now we're delegating the responsibility for actually creating the entire homepage to this little function in here, which is called get homepage, okay? So inside get homepage, let's go ahead and create our stream controller or our stream builder, okay? So let's say that, you see, because You may be a little bit surprised in here and say, okay, where's my scaffold? Well, we're not going to create a scaffold inside this homepage. The reason behind it is that homepage really, all it's going to do is to display various screens. There is no homepage. We don't have a homepage in our entire application. We either have the login view, the register view, or we have the contacts list or the contact creation view. So the homepage, all it's going to do is just to return one of those views to as a widget to then be displayed to the user. And those views themselves, they have the scaffolds and the app bars. Okay, so we're not going to create a scaffolding here. So let's say what we want to do is to return a stream builder, which works with the current view. Okay, we're going to auto import that. Its stream is going to come from the app block current view. Okay, and then we're going to say the builder is going to be context and then a snapshot. All right. And we're going to close that off there. Okay. And we're going to say switch the snapshot connection state. All right. And then add the missing clauses. For none and waiting, we're going to return a centered circular progress indicator. So let's remove that and say return circular progress indicator. Okay. And I'm going to put it in center in here. So wrap it with center and comma to get that right, and then make this constant, entire thing constant in here, okay? And we can remove the break because we have a return statement in there. All right, in case of active and done, we're gonna do the same things. So let's remove that. And then what we're gonna do is say final current view is snapshot require data, because this is actually gonna give us the current view. And you can kind of guess the rest of it. So we're gonna switch to current view. So let's say current view, and let's add the missing clauses in here. So for login, we need to basically return the login view. So let's say return login view. Okay. So it says, okay, what should I use as a function for login? So we're going to say go to app block. Okay. And for the login, we're actually say use the app block's login function. And for going to a register view, we're going to say use the app blocks go to register view, as you can see in here. Okay, so that was it really for a login view. Similar to login view, we're going to create the register view. So let's say return register view. Okay, oops, register view, auto imported. It says, okay, for the register functionality, what should I do? Then we say, well, the register functionality is inside the app block. So we say app block.register. Okay, and going to login view is a function also that's available on the app block. So we say go to login view. All right, good. For the context list as well, we have to pass a few more parameters in here. So let's just say return contact list, context list view, auto imported again. Okay, as you can see, there are 4 parameters, I believe, that we have to pass in here. Oh, 5 actually. For logout, we say app block dot logout, delete account, again, app block delete account. It's very simple. It's just plug and play. Delete contact is app block delete contact. Okay. Create new contact is app block create new contact or create contact. Okay. The argument type void. Let's see what the create contact is actually doing in here. So for create contact, create a new contact, it should go to the create contact view really. So let's say go to create contact view. So, okay. And also in here, we have contacts, which should be app block contacts. Yes. All right. Great stuff. So that's for the contact list view. And what we need to do is to go to this create contact. Okay. So let's return the new contact view. So we say return new contact view, auto import it. And let's have a look at this. And we say create contact should be app block dot create contact, and go back should be app block go to contact list view. All right, so you can see in here really it's just a lot of plug and play stuff, and this is our current application. So all of a sudden the login view is appearing in here, and you can test that by going to login in here and just say return text of hello world, and you'll see without material, it'll just be a hello world in here. And if you remove that, then you go and see your login view. So I'm gonna hot reload this, and let's have a look then at how all of this is gonna work. What we need to do then is also bring up our console .firebase.com. I'm going to switch to the correct project in here and bring it up to the screen, which is right here. So let's have a look at the various components that are available here. Let's go to authentication and just double check that you've enabled sign-in method of email and password. Okay. So then what we're going to do is to have a look at our users. At the moment it's empty. So if we go back to the simulator in here and have Safari available as well, if I say login, you'll see that we get these dialogues. And this is the auth error dialogues that we set up in our homepage, okay? The given user doesn't exist. So we say, okay, go take me to the register view, and I'm going to register with this user. Register. And you can see we ended up in the context view. So if I just refresh the screen now, you'll see that we have a user, okay? And if I then press the little button at the bottom of the screen, it takes us to the new contact view. And I can see that we missed the title on top. And the title on top of the screen should say, let's go here, should say create a new contact. So let's go back to our new contact view or new contact view. And on top, where we have the app bar, we've created leading, but we haven't created the title. Okay, the title is going to be a const text. Create a new contact. Okay, I'm going to go back to our application and then save. And now all of a sudden you see it says create a new contact. We can put a comma in here to get the formatting right as well. Okay, so now all of a sudden we say save contact, and you can see the contact was created. Let's create another one. I'm going to say 2 and then add some more text in there, and perhaps 3 as well. Okay, let's log out and see if that works. Log out, log out. I can log back in. I get my contacts, and if I log out again, and I create a new account as van.2 in here, and then add 2 in here as well, and say register, this user doesn't see the other user's contacts list. So this user can also create a new contact in here, and then can log out. So what we can do is to go back to Safari in here in authentication. Now we should say see 2 emails. Okay, let's go back to Firebase, Firestore database, and have a look at how our collections are looking in here. So let me do a little bit of a resizing. Good stuff. So if you look in here, we have 2 collections. They have different IDs in here, and these IDs are actually the user identifiers. So the first user, Vandot, has 3 contacts. Okay, you can tap on them in here, and you can actually see their data. Okay, and the first user only has 1 contact in here. Okay, so if I go into this first user, which has 3 contacts, and I press login, I log in. Now I try to delete this contact that is right here, van.2, and then I said delete contact. And if we go here and refresh the screen and have a look, and I can see that delete contact didn't really work, and we can actually see it here. It seems like we haven't actually done the delete contact properly. So that's one thing that we have to fix. And so delete contact isn't working, and also delete account isn't working. So nothing is happening. So 2 things we need to take care of now. So let's go ahead and do that. So let's go and have a look at why delete contact may not be working. If we open our app block, go here and open our app block, you can see that we have delete contact function in here. All this function is doing at the moment is just delegating its functionality to the contacts block, and it's going to this delete contact sync. Let's go to the contacts block and see what we can do there. The first thing that you'll see in the contacts block is that these 2 stream subscriptions are not being used. And this is a really good warning, actually, because we're not using them simply because we're not canceling them. So copy the create contact subscription in here. This is a little bit of a detour, but it's kind of important to also do. So create contact subscription. Let's cancel that inside the dispose function. Let's do the same thing with the delete contact subscription in here. Cancel. All right. After we've canceled these 2 subscriptions, let's go and find our delete contact sync. And if you continue, you'll see somewhere in here, down here, right after we did the create contact code, we've also copy pasted the same thing. And this is the danger of copy pasting, because I remember when we created, and maybe you also remember, when we created and wrote the actual code for create contact and its stream subscription, we copy pasted the same thing and just put it in here for delete contact. And we even forgot to change the comment to say delete contact. That is not the reason delete contact isn't working. The reason delete contact is not working is this particular thing in here, is that the delete contact stream subscription is not hooked to delete contact behavior subject. It's a problem of copy pasting of the create contact code and we forgot to change this particular code in here. So the entire delete contact subscription stream subscription is starting with create contact sending a message. So let's go ahead and change that and say this should actually be from delete contact. So we fixed the delete contact part. If we do a hot restart of the application and go here and say we want to delete the second contact and say delete contact, then delete contact is working fine. There's one thing we've also forgot inside our application, and that is when you delete your account. So at the moment, delete account isn't working. It isn't really doing anything. So let's go in our app block and take care of that. Let's go inside the app block and say that we want a new function. And I think we actually have delete account already. So that's really good. We have the delete account function. So this delete account function has to do two things. One is that it needs to ensure that all the contacts that that particular user has created are deleted before the deletion of this particular user. And then it has to go to the auth block and say, delete this user as well. So let's start with the contacts block. If you go to the contacts block in here, okay, in this contacts block, what we need is a delete all contacts. We need basically a sync, okay? We basically need to get a message to this contacts block that say that the UI wants to delete all the contacts that belong to the current user. So let's say a sync, a void, and we're going to say delete all contacts, okay? When you have syncs, you need to always ensure that you're disposing of them. So go to the dispose function, and in here, just say close that sync. Then we're going to take that as a parameter inside the constructor. So right here, let's say required this delete all contacts. And when I say right here, I mean inside the private constructor of our contacts block. Just ensure that you're taking in delete all contacts, okay? And since delete all contacts is a message that comes from the UI, and we are basically going to go ahead and just perform this work, we need a subscription to it. So let's go ahead and in here, and we say that we need a delete all contacts stream subscription. So a stream subscription of void, and we say delete all contacts subscription. And before we forget it, let's go inside the dispose function and cancel this subscription as well. All right. Now that we have that, we also need to take it in as a parameter inside the private constant constructor of our contacts block, just like we have these two. So I'm just going to copy this. Actually, let's not copy. We've learned our lesson. So required stream subscription, and this is void, and we're just going to chuck it in here without the underscore. Okay, and in here, then we're going to say, okay, our private property is equal to this parameter that comes in. All right, so that's for our constant constructor. At the moment, you can see contacts block is not so happy. It's displayed as red in here, if you can see the colors on your screen. And that is because when we're creating an instance of contacts block in the factory constructor, we haven't actually passed the value for those two, the sync for delete all contacts and also the delete all contacts subscription. Okay, but we're going to take care of that. So let's go ahead and create a little an Rx block in here, and we're going to call it delete all contacts. Okay, and first we need a behavior subject that takes in the message from the sync. So let's say delete all contacts, and this is a behavior subject of void. Okay, and you should be kind of familiar now with this pattern in that you create a sync so that you can take a message from the outside world. The backing store of the sync is a behavior subject. Then you take this behavior subject and then you do some stuff with it. Okay, so you can do some Rx operations with it. All right. So let's say a stream subscription of void, and this is our delete all contacts subscription. Okay. And we could also comment the data type out right now, because otherwise we'll get plenty of errors on the screen before we're actually done with this Rx chain. So what this guy is going to do is wait for delete all contacts to send a message. And what we want out of this is to get the current user ID. So let's switch map, because user ID is a stream of optional strings. Remember, if we say user ID, you can see it's the behavior subject of optional string. but we want to actually get the current user ID if it exists, okay? So let's say user ID, take the current user ID and unwrap it, meaning that we are only interested in you trying to delete all contacts while the user ID is available. That's what we're saying in here, okay? So that's that part. Then we're going to go ahead and take a user collection with that particular user ID. So we're going to do an async map, which is going to turn a future into an element in our stream. So in here, the input is our user ID, okay? And what we're going to do is to say backend collection with that user ID, and then we're going to issue a command that is called get. You can see this function, the return value of this is actually a future of query snapshot of our map, string, and dynamic, all right? So when we get that, what we're going to do is to go ahead and delete all the documents that is inside that collection. This part is a little bit tricky because the deletion of any document inside any collection is itself a future. So if you have 10 of those futures, then right here, you somehow need to go through all of them and then delete them all. So in my head, when we have lots of futures, somehow it would be really great if we didn't have to, I mean, because we can't like say for loop in here, okay? So what we need to do is kind of turn these futures into a stream and then use a switch map. So when we're here, we're getting a value in, which is our collection, okay? And then in here, we need to basically return another stream. So let's see how we can do that, all right? So if we say collection, docs, and in here we have, if we map all the docs, so in here if I say doc, and then I say doc reference dot delete, all right? So what happens if you call this function? So if I put this inside foo, let's see what the return type will be. You'll see that it is actually an iterable of futures. So now we have a list of futures or an iterable of futures that we want to create a stream out of. So how do we do that? There is a function called stream from futures. You can see in here, and it takes an iterable of futures and it returns the same stream of this. Sorry, it returns a stream with the same data type. So in here, if we say stream from futures and we put this code that we wrote in here right there, and then say final foo is equal to that. Let's see what happens in here. It says the body might return, okay, and then we return foo. What is it saying in here as an error? The argument type iterable of future void can be assigned to the parameter type future of dynamic. Okay, because I wrote in here from future, we should say from futures. So if you look at the data type of foo, now it is a stream of void. That is great because what we can do in here is just turn this function into an error function and return this stream. Okay, like that. So if we have a look at this, then delete all contact subscription, you can see now its data type is actually a stream of void. That is really good because it's very close to becoming a stream subscription of void. And the way we turn it into a stream subscription of void is through the listen function. So in here, we just ignore the incoming data and we just listen. And now all of a sudden, delete all contact subscription is a stream subscription of void. Okay, so let's put the data type back now that we actually know that the data type is correct. Then inside here, we're missing two parameters. So delete all contacts, which is going to be delete all contacts, which is our behavior subject, which is a sync as well. And the last parameter is delete all contact subscription, which is equal to delete all contacts subscription, as you can see in here, okay? So I'm going to save this file and hot restart the application. But before we forget, we need to go inside the delete account in app block and actually tell the app block that it has to do two things. First of all, it needs to go to the contacts block and it needs to go to delete all contacts is a sync, and then it adds a null message to it. All right. Then it also needs to go to the auth block and then it should say a delete account. Oh, we probably didn't actually do the auth block, perhaps. Say we forgot to do the auth block. Okay, so we've taken care of the contacts block, but not the auth block. We need to go into the auth block and do a delete account in there. So let's take care of that now. So if we open our auth block, then in here, we need a delete account command that can come in here. You can see we have a few syncs in here, okay? So let's go ahead and take care of a delete accounts sync as well. So in your auth block, where we're defining the properties, let's go ahead and say final sync delete, void, because it's just a command and we should say delete account. Before we forget it, let's go into dispose and close that. So let's say delete account close, as you can see in here. Let's take it as a parameter as well. So we say inside the private constant constructor of auth block, we say required this delete account. All right. We're getting an error in here because we're not actually creating a proper instance of auth block because we don't have delete account, but we're going to take care of that right now. So let's go ahead and say that the backing store of delete account, like usual, is going to be it is going to be a behavior subject. So right before the creation of auth error, let's go and add a comment and say delete account, and we're going to say final delete account is equal to behavior subject of void. Okay, then what we're going to do is to say delete account error, because there may like an error might actually happen while you're trying to delete your account, and we want to grab an auth error out of that, because if you're trying to delete your account and it can't go through, then we need to display an auth error to the user. Okay, and we already have the logic for accumulating all the auth errors in this RxMerge. So let's see if we can create another stream of auth error optional and for this delete account. So I'm just going to copy this guy and place it here and comment the data type out for now. So at least we know that is our goal, okay, to grab a stream of auth error out of all of this. So let's say we start the chain by using delete account in here. And what we need to do is we say set loading. We are loading on which sync is loading. Okay. Right after this, what we need to do is to basically have a look at deleting the current user. So let's go ahead and say async map, because we are going to trigger a future. The incoming value for delete account doesn't really matter, so we could just put an underscore there. And let's turn this function into an async function in here as well, okay? So let's say we are going to try, and we are going to have a code that is very similar to this. So let's just copy the logout code. So try catch, because it has authentication auth exception handling in here. So let's place it inside async map, and the only thing we really have to change in here the code for the deletion of the account. So we're going to say Firebase auth instance current user optional dot delete. All right. So as you can see in here, it's just waiting on the current user to be deleted. That's all it's doing. Okay. And then after that, we're going to change the loading parameter to false. Okay, false, and that's it. So if you now have a look at the delete account error, you can see it is in fact a stream of auth error optional. Okay, let's remove the comments that we put around this so that we type it properly. So anybody looking at this, they know what data type it is. Then we go into delete account error, copy that, and you need to paste it then inside the creation of your auth error stream. So right after logout error, we're going to go ahead and say that delete account is actually one of the streams that contributes to the entirety of auth error calculation. Okay. And let's go in here inside the constructor, or inside the factory where we're creating an instance of our auth block using the private constructor. Right after logout, we're going to say delete account, and then we're going to say delete account is actually the backing. Delete account is the backing for this delete account parameter. Okay, so I'm going to save this, and what we could do is now the moment of truth. You can see in here. Actually, let's see what happened. Okay, that document was deleted. So let's go inside our application and log out. All right. Then what we're going to do is to go inside authentication and have a look at this user that we've created. This is the second one, and this is the first one. And this user's ID starts with PD. All right, PDX. Then let's go back to Firestore database and have a look at a user that has PDX. And we see in here that is the user. And that user has 2 documents. And that is completely correct because that's what we see on the UI as well. Okay. So what we could do then is to log in with this user and then go in the menu and then say delete account. What we expect here is by deleting your account, we need 3 things actually to happen. One is in the UI and 2 things are going to be in Firebase. Let's start with the Firebase stuff. The first thing that needs to happen is for all these documents to be deleted. And then the collection will disappear automatically from Firebase. So in Firebase, this is a rule. If you can't have empty collections. So if you delete all the documents inside a collection, which we are doing with our contacts block, then all the then the collection itself is going to be deleted. After that is done, And the second thing that is going to happen is we're telling our auth block to delete the current user. And the third thing that is going to happen is, as a side effect of deleting a user with Firebase authentication, then the user ID is going to become null. And once the user ID becomes null, the user is null, which means that our application is going to log you out automatically. So it's the beauty of Rx and like reactive state management systems, and you don't have to really handle all these cases manually. Once you do it in one place, then you're good to go. So let's have a look at actually see if this works. Okay, I'm not sure. Delete account, and the dialog appears. Say, are you sure you want to delete your account? And we're say delete account. And I can see actually some things happen in here. You can see that the documents were all deleted for this user. Okay. And it would be interesting to see actually if authentication still has our user, and I can see our user still here. And let's go ahead inside the output. I can see nothing really happened in here. So that's a little bit interesting. So it seems like the documents were deleted for this user, but the user itself wasn't deleted. So let's have a look at delete account and see what happened in here. So we have delete account error, and it's saying delete account. And then we're saying delete account, set loading to, okay. And then we're saying delete account error in here as well. So what we could do really is just to put a simple print statement in here and say print delete account. It is very possible that we're not actually coming in here, okay? So let's hot restart the application. Since the user still exists, I'm just gonna go in here and say, it's like the screen's kind of like frozen for me. So I don't know if it's a simulator problem or something. Keyboard hardware, something is happening with the simulator. So I'm just gonna log out. All right, let's log back in with this user. Then I'm gonna right click in here, have a look at the debug console, and I'm gonna say delete account. And I can actually see that the message for delete account isn't coming here. And it could be because we've forgotten to actually add the functionality for deleting the user's account in the delete account inside app block. So let's go into the auth block, okay, auth block, and then we're going to say delete account.add and null. And that was the reason really that this was not working. Let's remove the print statement from our auth block and ensure that in your app block you have inside delete account, you're making the call first to delete all the contacts and then make a call to delete the account itself. So let's hot restart the application. The user's logged in. Let's see if we go back in Firestore database, our PBX user doesn't have any contents or any contacts. I'm going to create 1 and then 2 and then 3. Okay, like we had it in the absolute beginning. And then if you go in here, I'm going to refresh the screen. Now we have or PDX. Now we have 3 documents in here. Then let's repeat the process. Let's just say delete account and see if it works this time. Delete account. And you can see we landed back in the login page and all our documents are gone. The collection itself is gone. And then if you go back to authentication in here, let's go here and then say authentication, you will see that the user itself is also gone. So this was actually great. So we could actually put it together, create the contacts, delete contacts, log in, log out, register, delete an account. So there's quite a lot actually going on inside our application. So we've already tested it out, so we don't actually have to take care of this at the bottom, but we could just give it a simple test. Now, if I log in with this user, I shouldn't be able to do that because we deleted this user. Let's go register this user. We log back in here. We can create contacts as many times as we want. We can create the same contact over and over again if you want to, because we don't have any logic in there. We can delete contacts one by one if we want to, right? And also we can log out, no problem, log back in, and then we can delete this account, and that should also work as expected. Okay, let's go ahead inside terminal in here and commit our work. So let's see what we have. If I say in here git log, have step 10. So let's say git add all, and then we're going to say git commit step 11, and we're going to say git tag. We have up to 10, and then we're going to say git tag step 11, as you can see in here. Okay. So as I mentioned quite many times before, Rx really is all about operators. And once you nail the basic ideas of Rx, like how streams work and how streams connect together, different these commits that I told you, like in Git branches, how they get together, the merging, like the operation of rebasing as you do in Git. In Git, you don't have rebase, but you have something similar in Rx as well. So, and that is concat. Remember that, okay? So you have concat, you have a switch map, you have async map. So my suggestion for you is, if you really want to master Rx, at least in my idea, in my opinion, the best way to do that is to do projects. And one thing that could help a lot is that you don't think about what you can and can't do, except think about a project you want to do. And don't be afraid if that project is too big. It could be too big, but you will learn also quite a lot. So aim for something big. Aim for like an application that has server connectivity, it has API calls, it has caching, it has some heavy calculation or work that needs to be done on separate isolates maybe. So have a look at these things and see if you can come up with a good project idea that maybe means something to you and you can also enjoy, and then go ahead and do that project using Rx, using the patterns that I showed you with these different blocks. And I'm sure that you will get really far. And this last example was this example was the last example that we wanted to do in this chapter. So I hope that you enjoyed this chapter. I put a lot of time into creating it. Like I'm talking about a month and a half, almost 2 months. And if you enjoyed this chapter, please give me a follow on Twitter and LinkedIn. And if you have any questions, just please let me know as well. I'll do my best to answer your questions either here or on LinkedIn or on Twitter. So I hope you enjoyed this chapter. I had a lot of fun making it for you, and I hope to see you in the next one.